Good morning, my dear students. Today, let us start alternating current. So, that is abbreviated as AC, alternating current. So, what is the alternating current or alternating voltage or alternating EMF? Generally, for example, if you take, so this is one external resistance, right? And so here one battery I am connecting it, and every battery provides a constant potential difference, means V is constant here, and if the temperature of the conductor constant, the resistance of the given material is also constant. And so when you switch on the battery, it supplies some amount of the current, and that current is given by I is equal to, so V by R, and as V is constant, R is constant, so the current is also, we can say, there is a constant current, means with respect to the time. So, the current in the circuit or current in the resistor does not change. Therefore, now we can draw the graph, so between the current and time. So, this is the time, for example, this is the current. Now, for example, V is equal to, so 20 volts, and R is equal to, for example, 5 ohms. Therefore, now what the current we can get 4 ampere. Now, what this current we can take, that is a 4 ampere always, means what? After 1 second, 2 second, 3 second, after switch on the battery, every second the current does not change. The current is always equal to 4 ampere. We can represent like that. Therefore, so this is the constant current and the direct current amount. And for example, if you take this variable resistance. If you take the variable resistance, means what? You can increase the resistance, you can decrease the resistance, or you can keep the resistance constant. If the resistance is constant, we can get the current. That current is actually it is a variable current that may be so like this sometime. Therefore, now what? Current may increases. If you decrease the resistance, current may decreases, and if you increase the resistance, current may so decreases. That may any function. But here current is changing in magnitude, but its direction does not change, and here current is keeping constant in magnitude and direction. So, here current is not changing in magnitude, current is also not changing in direction. So, what? For example, if you take this is the A and this is the B, so always current is traveling from A to B after 1 second, 2 second, 3 second, means what? The magnitude of the current may change if the resistance changes, but the direction of the current always travel from A to B. There is no change in direction. Therefore, a current whose magnitude so may or may not be so change, but direction must be constant. So that current is called as a direct current. And so in the direct current, there is no change in the direction of current, always travel from A to B. So according to battery connection, right? No. So here maybe magnitude changes, because if you change the resistance, so continuous. But if you keep the resistance constant, current is always constant. Therefore, in the direct current, the direction of the current so never ever changes. But if you take, so in the yesterday topic we have discussed so about what? So electromagnetic induction. So motional EMF or EMF, different concept we have discussed. So what is that EMF? So E is equal to, we know that, so minus N into so d pi by dt. If you take now E is equal to minus N into d pi by dt, if nothing but so flux formula. So what that is B A cos so into omega t, because here what I am taking that generally flux pi is equal to, you can take that is equal to so N B A cos theta. So when a coil, for example, in the uniform magnetic field, if you take these are the magnetic field lines, and if you take this is a coil, one coil if you take, if this coil is rotated, therefore now when this coil is rotating, so inside the uniform magnetic field with an angular velocity omega at any time t, so what is the angular displacement? Angular displacement theta is equal to omega into t. Therefore, when a closed loop or when a coil is rotated in a uniform magnetic field, the flux changes. When the flux changes according to Faraday law, so there is a induced EMF. Therefore, instead of the theta after time t, so what I am taking that omega into t. And if you differentiate this one and you are getting that, after differentiating you are getting that, so NBA, so omega into what, that is equal to sin omega t will come. Therefore now, so this is called maximum in front of the sin omega t. Here this function NBA omega, where n is the number of the turns of the coil and B is the magnetic field what you applied, A is area of this coil, that may be circular, that may be a square, that may be rectangular, in any form you can take, and omega is the so constant angular velocity of the given coil. Therefore now this is called as a peak value, and E is equal to, you can represent so E naught sin omega t. Therefore this is if you take this one now, so this is called alternating EMF or alternating voltage, and you can use capital E is equal to capital E naught sin omega t, and sometimes you can use V is equal to V naught sin omega t, and here E naught is equal to given by E naught is equal to NBA omega, that is called as a so peak value of EMF. This is called what? Peak value or peak EMF, or sometimes also called amplitude of the given EMF. And so this total value, this total function is called instantaneous EMF. And therefore this total E naught sin omega t is called as the instantaneous value, and this value NBA omega is only called as the maximum value of EMF. That maximum value of EMF is called as peak value, or also called amplitude of the given electromotive force. So E naught sin omega t, this total value is called as the instantaneous value, this value is called as the peak value, keep in mind. Therefore now what? So here why we have to call alternating function? Because when the t value changes, so at the time t is equal to 0, if you draw the graph, for example, if the time t is equal to 0, so what we can get sin omega t, sin omega into 0, it becomes 0, and at the time t is equal to pi by 4, at the time t is equal to pi by 2, omega you can say what omega is equal to, so that is you can take a t by 4 also, so omega is equal to 2 pi by, therefore t is equal to pi by 2 means what? T by 4. When you are converting the pi by 2 angle into t by 4 means what? After turning, so 90 degrees, the time is equal to what? T by 4. Therefore now what? So 2 pi by t. So after substituting in this expression, so omega is equal to 2 pi by t, and so small t is equal to t by 4. If you substitute, you are getting that sin pi by 2, and sin pi by 2 is equal to 90. Therefore at that moment, when the time t is equal to 0, E is equal to 0, but when the time t is equal to t by 4, E is equal to, you are getting what? Plus E naught. And like this, if you take a small t is equal to time t is equal to capital T by 4, capital T by 2, capital T and capital 3t by 4. So like that if you take so you are getting the graph between EMF, the graph between EMF and time. Means what? This is the, for example, if you take, this is the, so EMF I am taking that, so your time t is equal to 0. Now here you can, so this is the, so t by 4 I am taking that. So this is the t I will take, therefore, so this is the, so t by 2, and this is 3t by 4. Finally, if you take at this moment, for example, last one is what? T. Then what? When the t by 4, if you take, now the value becomes maximum at the time t by 4. So nothing but what? That is so the function comes like this. Therefore now what? So this is called as so alternating voltage form generated by the AC generator by using formula what? E is equal to so NBA omega, so NBA into omega. Therefore this value is there, no, at the t by 4 we got that is the maximum value, that maximum value is that is nothing but plus E naught, and at the 3t by 4, after 3t by 4 again we are getting the negative value, but it is not in the same direction, it is what? It is in a opposite direction. Therefore now, so this is the the minus E naught, I am taking that. So, this is the T by 4, this is the T by 2 and this is the T by 4, this is the T. Therefore, now what? Here up to T by 4 means what? So, up to 180 degrees the current travels so in one direction, but when the after T by 2 the current travels in the opposite direction in the given so any element. That element you can take a resistor, you can take conductor, you can take the inductor, no problem. Therefore, in any inductor or so any material, therefore now current and this current and voltages both are reverses in direction. Therefore, now so this is called positive function, positive first this is a negative waveform. This is the positive, that is the negative. Therefore, during this T by 2 current travel in one direction, and after T by 2 current comes in the opposite direction through the same element what you are connecting to the circuit. And so this circuit symbol of this AC value is given by, for example, now we can take what? This is what? Therefore, now onwards we can use V is equal to V naught sin omega t. Of course, E is equal to E naught sin omega t also you can take, or V is equal to V naught sin omega t also you can take. Therefore, this is called as the sinusoidal waveform, alternating current or alternating voltage. And so instead of the current, for example, so this current, this element, if this alternating voltage, if you are connecting so to a resistance, for example R, then what is that? Some amount of the current is passing. That current is what? I. And here I is equal to what? According to Ohm's law, I is equal to E by R. When I is equal to E by R, therefore V naught sin omega t by R. Therefore, now here V naught by R nothing but maximum voltage by resistance nothing but that is the maximum current I naught sin omega t. Therefore, alternating current through the any resistance what you can say I naught sin omega t. Therefore, now the current is also in the sinusoidal function only. Understand? Therefore, the current which changes its magnitude and direction alternately in the form of a periodic sinusoidal function. So, is nothing but alternating current. And so, current may not changes always in the form of the sinusoidal function. So, it may changes in different ways. For example, if you take, so this is the sinusoidal function. This variation is called a sinusoidal function. Means what? Any function which is you are expressing f is equal to f naught sin omega t or f is equal to f naught cos omega t. So, any function which you express in terms of the sin and cos, that function is called as what? Sinusoidal function. And other forms of alternating voltage and alternating current are, for example, if you take like this, so this is called as the sawtooth wave function. So, this is called as the sawtooth wave. This is called as the sawtooth wave function, because here also sometime becomes what? Maximum, sometime becomes what? Positive, negative maximum, and again 0, again maximum. Means what? Alternately the current and voltage has to change with respect to the time. One time positive maximum, one time positive, one time negative maximum, and one time 0. So, like that if the current changes, that is nothing but alternating current. And another form is, so you can take a rectangular or rectangular or triangular function also. For example, if the function comes like this, if the function comes like this, is the positive what? This is the negative. Therefore, this you can take alternating current, and this you can take what? Time. Therefore, now this is called as a triangular waveform. And if you take the function like this, if you take the function like this, positive and negative, this is called as the square or rectangular waveform. Therefore, not only sinusoidal function, you can express the alternating current and voltage in terms of the different. So, this is a sawtooth, this is the triangular, that is the rectangular or square function. But so our AC generator, so the alternating EMF will be generated by an instrument. That instrument is called as what? AC generator. Inside the AC generator, the alternating EMF will be generated in the form of the sinusoidal function. That's why our complete discussion will be explained in the form of the sine function or cos function. You can express in terms of the sine, in terms of the cos, no problem. Therefore, now if the function is expressed in these two functions, sine and cos, that function is called as the sinusoidal function. Now, let us take that. Let us take one problem. Now, so for example, in AC generator of the coil has a total number of the turns, N is equal to 100, right? Now the frequency of oscillation, the frequency of rotation of the coil is equal to, for example, I am giving that 50 hertz, and so now the magnetic field is given by, so B is equal to, so 200 by, so pi Tesla beta, 200 by pi Tesla. What I am taking here, the magnetic field is equal to 200 by pi Tesla. So now what, the area of the coil A is equal to, that is equal to 100 centimeter square. Area of the coil is equal to 100 centimeter square. Then they will ask that, so what is the, so peak value of so EMF, and that is what E naught is equal to how much they am asking now. What is the peak value of the alternating voltage, or what is the peak value of alternating EMF? What I have given, N is equal to 100 turns, and the frequency of rotation. Frequency means what? For 1 second, how many rounds it is taking? 50 rounds. Therefore, now F is equal to 50 hertz. The magnetic field used in the AC generator, how much? 200 by pi Tesla, and the area is equal to 100 centimeter square. Now I am asking what? So E naught is equal to what I am taking. Therefore, now what? The peak value already we know that. So E is equal to, E naught is equal to N B A omega. So in this case, if you substitute, but omega value they have not given direct. Therefore, now what? N into A into, so B omega value estimate, that is a 2 pi F. Okay na? So that is the relation between angular velocity and the frequency of any so rotatory system. Therefore, now you substitute the value N. N is equal to, we are taking that 100, because they have given N is equal to 100, A is equal to 100 centimeter square, nothing but centimeter square you can convert into meter square. Therefore, now this is what I am taking that. So 200 by, so pi, so into, so 2 pi F nana, that is equal to how much now? That is equal to, so 2 pi into F value how much? 50 we have taken like that. Okay. Now if you simplify, what you can get, so this is the 100, this is the 100. Now this total value is cancelled. So 1 pi also cancel. Therefore, now what is that? So 50 into 2, that is 100. So 100 into 200, therefore now that is equal to, so 2 into, so 10 power 4 volts you can get. This is the peak value. E naught is equal to S2, that is equal to 2 into 10 power volts. And so in this case, for example, if a resistance is connected to the alternating source, then what is the current? Then you can find out the peak value of the current I is naught is equal to E naught by R only. Therefore, first find out the E naught value, then after substitute the resistance value, you can find out E naught is equal to 2 into 10 power 4 volts. Therefore, now, so other values, the other values of alternating voltage or current forms. So generally what we have taken here, now the alternating voltage V is equal to V naught sin omega t. This value is called instantaneous value, and the peak value is given by V naught is equal to NBA omega. This is called as a peak value or maximum value. Two values we have given. This is the peak value and this is the instantaneous, because instantly with respect to the time it is changing. Therefore, now we can call instantaneous value. Therefore, now here there is one more value. So what is that? RMS value, root mean square value, and average value. So if you take any function, for example, now I am taking that. So the function, any function f is a variable of f of t. F is any function. Means what? It is varying with respect to the time. When a function f is changing with respect to the time, now the average value is given by Ia is equal to, that average value Fa is equal to, so integration of f into, so dt, so by what? So integration dt, and if they will give the time interval, now the time interval given by t1 to t2, and here also t1 to t2, and after simplification you can get now, so this is the t1 to t2, so f into dt by what? Here integration of this one, this part I am taking what? This part integration of dt t, and you can get what? So t2 minus t1, remember this volume, it is applicable every cases, not only alternating cases. Therefore, if any function f is equal to f of t is expressed, so in terms of the time, Therefore, now its average value FA is equal to integration from T1 to T2 F into dt. That F value what they have given in terms of the time. They have given no, in this you substitute, you can get the answer, and the integration of dt, so T2 minus T1 you can take that, because integration of dt is equal to T, and so final minus initial limits you substitute and you can get the answer T2 minus T1. So okay now, therefore now, so here average value of the EMF, peak value, instantaneous value we have taken. Let's go average value. So what is the average value? For example, if you take one sinusoidal function like this. This is the plus, this is the minus, and this is the average voltage, and right now, sorry, this is the alternating voltage, this is the time function, this is the capital T, this is the T by 2, that's it. Now, what is that average value? So, here the average value of the voltage is given by VA is equal to integration of V dt. For what time interval? I want average value of the full circle. So, for the full circle or full cycle, therefore, what you can get now? So, 0 to capital T, because for one complete oscillation, the time taken is called as what? Time period. So, starting from the 0 to ending, therefore, now what? Integration of, so dt. So, what you can say, that is, you can take direct amount. What is that? So, T minus 0. T2 minus 0, and therefore if you substitute here, so what, that is the 0 to T, and that is the V0 value of V0 what? So V0 sin omega T dt by what? That is the T. And so after simplification, so remember one point, so integration of so sine of n into omega t 0 to t is always equal to 0. 0 to, so k, here you can better you take the k, and here you can take n. Therefore, n is equal to 1, 2, 3. Therefore, k is equal to 1, 2, 3. So, every sine function whose integration from 0 to nt is sine k omega t is equal to always 0. Here k is equal, you can take 1, 2, 3, 4. N is equal to also you can take 1, 2, 3, 4. Is always equal to 0. That's why for over the full circle, the average value of, so EMF or alternating voltage is always equal to 0 for the full cycle I have taken. For full cycle. But if you take the half cycle, means what? Either positive or negative. Therefore, over the half cycle, just to change the time interval. Now integration. So V0 sin omega t dt 0 to t by 2. So what here? So t by 2 minus 0, and after simplification you can get more. It is equal to, so 2V0 by pi. So for the positive half cycle we will get that answer 2V0 by pi. For the negative half cycle, so you can get that VA is equal to minus 2V0 by pi. Therefore, this is over for the negative cycle, and this is for what? So positive cycle. Therefore, the average value of alternating EMF in the sinusoidal function is over one full circle is equal to 0, over positive half circle is equal to 2V0 by pi, and over negative half circle is equal to, so minus 2V0 by pi. Therefore, instantaneous values over average value, peak value we have discussed. Next, RMS value, which is most important. Why? Because generally DC current or in the DC circuits we have to use so ammeter, galvanometer, voltmeter. All those are measure, so what, constant volume. But in case of the alternative circuits, we can't use the DC meters. Why? Because DC meters always measure average value. So already over one full cycle, average value is equal to 0. Therefore, whenever a DC meter, either a DC ammeter or DC voltmeter, if you connect it to the alternating circuit, that does not measure anything, that measures only, so nothing. Therefore, now what? Here alternating current. To measure the alternating current, there is one instrument that is called hot wire ammeter. This hot wire ammeter measures what? Alternating current. Nowadays, we are getting that multimeters. So in that multimeter, we can use all alternates. Therefore, now here RMS value. What is the RMS value? Instantaneous value over, so peak value is over, average value over, the half cycle, full cycle over. Next what? So last one, the most important one, RMS value. Actually, every AC meter measures the RMS value, not average value, not instantaneous value, not so peak value. Every AC meter always measure the RMS value. So what is the RMS voltage? Now the RMS voltage, this is also called effective voltage are also called, so what, that is the virtual value, effective value, RMS value. All these are the same, Nana. Just only small difference. Now what is that? That is given by, so V square, so into, so dt, so 0 to, so t by what, that is equal to integration, so what, that is the, so dt. Right, no? Now after that we can take the, so average time like that. Right, no? So this is the root mean square value function, therefore square root of, so integration of, so v square dt, take the over, and here also you can take what, so 0 to t, and if you simplify v square, v is equal to what, v naught sin omega t. If you substitute and simplify over the full circle, right, no, over the full cycle, you will get va is equal to v naught by root 2 beta. Sorry, this is what, instead RMS value, no? So V RMS value is equal to V naught by root 2, you will get the answer for that, okay? And this is not only for the half cycle, it is also for the full cycle, and any half cycle both are the same. V RMS is equal to V naught by root 2, just you substitute there and you apply the mathematical procedure, therefore now you will get V RMS is equal to V naught by root 2, and one more time, so this is only for, this is not only for half cycle, it is for the both positive half cycle, negative half cycle, and also for the full cycle. But average value is not like that. Average value over the, so full cycle is different, that is a 0. Average value over the, so positive half is equal to 2 V naught by pi, and average value over the negative value is a minus 2 V naught by pi. Okay, so these are the values. Next, for example, now, so in the previous question, so they may ask not only peak value, RMS value they will ask, average value ask, use the formula, just a simple formulas only, not need to discuss now. Next, now different elements, how to connect to the, so AC circuit. For example, now I am taking that, if you take one pure resistor, that is the R, now here I am connecting the alternating source, that source what, V is equal to V naught sin omega t. V is equal to V naught sin omega t, we are discussed. Therefore, now what, here when you switch on, the current is passing, therefore now you can say, so V is equal to V naught sin omega t. On applying, so what we can get, current I is equal to, no doubt at all, I naught sin omega t you can get, where I naught is equal to what, so I naught is equal to V naught by R. That's it. I naught is equal to V by R. And if you observe the phase, what is the meaning of the phase? The differences in angles of the function, because it is expressed in the sine, it is also expressed in the sine. Therefore, here the angle is equal to omega t, here the angle also omega t. Therefore, the first point is that, so the phase difference between the current and voltage is always equal to 0. Now we can say, when a AC circuit is connected to the pure resistive circuit, both are in the same phase, means what, pi is equal to 0. So current always follows the, so EMF. Therefore now the phasor diagram you are getting that, because all these I am not giving, because already you have the idea of the phasor diagram, what is the meaning of the phasor diagram, what is the meaning of the phasor difference and all those. Therefore now what, if you take, so this is the, this is one graph like that. For example, with respect to the x-axis, now if you take, this is the, so what, EMF, and the current also follows the same. Therefore that is what, that is the I am taking that. Therefore now, so this is what, so this is the omega t form. Right. So with respect to the x-axis, the angle made by the current is omega t. With respect to the x-axis, the angle made by the voltage also omega t. Omega t minus omega t is equal to 0. Therefore now what? So we can say both are in the same phase when, if you are applying a pure resistive circuit to the, so alternating current. Therefore now here next, if you take a pure capacitor, if you take one pure capacitor connected to a voltage source, its source, that is the alternating source. Now what is that? V is equal to V naught sin omega t. Means what? When alternating voltage of V naught sin omega t is applied to a capacitor, that capacitance how much I am taking, C. Now here what we have taken now, so the applied voltage V is equal to V naught sin omega t, that is no doubt. But the current in the circuit is given by I is equal to I naught, so sin omega t plus pi by 2 will come. I is equal to I naught sin omega t plus pi by 2. Right now, so this is what this is the capacitive circuit. I is equal to I naught sin omega t plus pi by 2. So if you see what we have taken here, this is the omega t, right, and this is what this is the omega t plus pi by 2. Here sin both are there. Now, so compare with voltage, current is 90 degrees forward, means what, 90 degrees faster. Therefore, now we can say current leads the voltage by how much? Therefore, I leads V by how much now? By pi by 2. Or you can say the voltage lags behind the current by how much? By pi by 2. Therefore, in the pure capacitive circuit, what? So current leads the voltage by how much? Pi by 2, you can say that. Current leads and voltage lags, both are the same. Current leads the voltage by pi by 2, and so voltage leads the current, voltage lags the current by current how much? That is a pi by 2. Both are the same only. So therefore, now what? So this is the pure capacitive circuit. If you take pure inductive circuit, means what? So that is the inductor. And every inductor having some inductance. Yes, yesterday we have discussed there is a self-inductance L nano. In this case, yes, as it is, what is that? Now, V is equal to V naught sin omega t, and the current is given by I is equal to I naught sin omega t minus pi by 2. So this is the current in the, through pure inductive circuit. Pure inductive circuit means what? Along with that, we should not connect any other element, resistance, so like that. Therefore, now what? I is equal to I sin omega t minus pi by 2. Here you can say I lags, current lags the voltage by how much now? By, pi by 2, or voltage leads the current by how much? That is equal to by pi by 2 only. Therefore, now what? These are the small points. Now, let us go power in the AC circuit. So what is the power in the AC circuit? Now the power formula. So generally, if you take the DC circuit, the power generated formula what? P is equal to V into I is equal to V square by R, that is equal to I square into R. When a direct source is connected to the resistance, therefore now what? This is the power generated. P is equal to V into I is equal to V square by R is equal to I square into R. Now in that case, right, now in case of the AC, so we have to check what is the power now. For example, now the power in the formula in AC circuit is given by P is equal to, V RMS value, I RMS value, and extra we have to get what? That is a cos pi. So what? The power in AC circuit is given by P is equal to VRS, VRMS, IRMS into cos pi. So this is the power generated in the circuit, and sometimes this is also called as what? So true power, right? No, or so this is called as a true power. And if they will mention, so average power or true power. So in the circuit, P is equal to how much now? So VRIR is equal to cos pi. And if you convert into peak values, this is the V naught by root 2 into this is the I naught by root 2 into cos pi. Therefore, now that you can say, so V naught I naught by 2 into cos pi, and this cos pi function means the cosine of angle of phase difference between the voltage and current is called as the power factor. So this is called as the power factor, not power. So power is equal to P is equal to V naught I naught by 2, and cos pi is equal to what? That is equal to power factor. This is the power factor we have discussed. Okay, na? Therefore, that is the power formula. And if you take the pure resistive circuit, for the pure resistive circuit, what? Pi is equal to 0. Phase difference is equal to 0. Both are in the same phase, current and voltage. No one is the leading, no one is the lagging. Therefore, phase difference is equal to 0. If phase difference is equal to 0, power in the pure resistive circuit is equal to, so what? So cos pi, cos 0 value 1. Therefore, now V naught I naught by 2, that is equal to what you can, now what you can write, V naught I naught by 2, that is okay. Next, if you take, this is the pure resistive circuit. If you take pure capacitive circuit. For the pure capacitive circuit, pi is equal to how much now? Pi is equal to 90 degrees. And so what now? The power in pure capacitive circuit PC is equal to what? That is equal to how much? That is equal to 0. Why? Because you see here, so cos pi, cos 90 value 0. When cos 90 value is equal to 0, power is equal to 0. And last one is what? Now power in pure so inductive circuit, that is equal to again pi is equal to 90 degrees. When pi is equal to 90 degrees, power through the inductor PL is equal to also 0. Again cos 90 value 0. Therefore, a pure capacitive circuit never produces any power, and a pure inductive circuit also never produces any power. Therefore, these two circuits are called as wattless circuits or powerless circuits. Therefore, a circuit or an element so which does not produce any power is called as a wattless current or wattless circuit. So like that. Therefore, now what? Here pure capacitive and pure inductive circuit do not produce any power. Therefore, those are called as wattless circuits. Next, let's go. So here one more important term. In pure capacitive circuit, what is the current formula? So for the pure capacitive circuit, for pure capacitive circuit, the peak value of current formula what? I naught is equal to V naught by XC. Here we have taken no. So what? So V is equal to V naught sin omega t, and the current in the circuit is given by I is equal to I naught sin omega t plus pi by 2, nothing but what? 90 degrees. Here I naught is what? In case of the pure resistive circuit, I naught is equal to so V naught by R, and but here I naught is equal to V naught by XC, and this XC is called as a capacitive reactance. You know all this. So this is called as the capacitive reactance that is given by what? 1 by C omega, where C is the capacitance of the given capacitor, omega is called as the angular frequency, and this is equivalent to resistance only, and this is called what? Capacitive reactance. Right now, so this is the capacitive reactance which is equivalent to resistance, but it is not resistance, actually equivalent. The unit also same. So XC is acting as the opposition to flow the charge, or so to flow the current through the system. Therefore, now what? XC is called as the capacitive reactance. Now, so in case of the pure inductive circuit, if you take the inductive circuit, instead of the XC you can take what? That is the XL. Now the current here what? That is equal to omega t minus pi by 2, because current lags the voltage in the pure inductive circuit, and here this XL is called as inductive reactance, that is given by XL is equal to L into omega. Therefore, now XL is equal to L into omega. Right. Therefore, now so these are the just small basics in this discussion. Okay. Now, so let's go. Let's go LCR series circuit. LCR series circuit. If I will go through this, you can get all LCR series circuit. LCR series circuit means what? At a time 3 element we have taken. Up to now we have taken individual. L is different, C is different, R is different. But inductor, capacitor and resistor, all at a time if you are connecting in series to the alternating source, so what are the voltages and current? Let us discuss. For example, let me take, this is the inductor and this is the capacitor, and this is what? Resistor. We have to take that C, and this is the L, and this is the resistor R, and the total branch we are connecting to a alternating source of voltage, that V is equal to V naught sin omega t. V is equal to V naught sin omega t. Therefore, now what? So in this, some current is passing. When you switch on the source, then current is I is passing. Therefore, the voltage across the inductor, for example VL I will take, the voltage across the capacitor I will take that VC, and the voltage across the resistor what? So VR I am taking that. So voltage across the inductor, capacitor and resistor. And generally, if you are taking this is the direct battery, means direct source, only we have to take. Therefore, if it is the direct, now you can take what V is equal to VL plus VC plus so VR we can take, of course. So with the direct battery, inductor does not work, that is not a matter. But for example, if it is the first resistor, second resistor, third resistor, voltage through the first, second, third, what you can take? V is equal to V1 plus V2 plus V3, direct algebraic sum only we can take it. But these are not, so this alternating voltage, alternating current, these are the not, algebraic, we can't take the algebraic sum, because those are the phasors. They are maintaining the phase difference among them. So current in the, pure capacitive circuit leads the voltage by pi by 2. Therefore, now such quantities which are maintaining the phase among them, so those are called as the phasors. So through the phasors, we can't take the algebraic sum, direct we can't add. Therefore, the total voltage supplied is equal to VL plus VC plus VR is wrong in this discussion. We should not take so total voltage applied is equal to VL plus VC plus VR. So then what we can take now? So now let us suppose, now I am taking that. So this is the, now if you take this is the current amount. This is the current I am taking it. Now, the voltage across the resistor and current both are in the same direction. For example, the current, the main current in the circuit I will take on the x-axis. We know that the current in, so AC circuit through the pure resistor, therefore what? Both are in the same direction. Because all are in the series, means what? Current is the same. Therefore, for all elements current I have taken the same only. Therefore, we are. Now, you know that the current in the, for example, now here I am taking that voltage across the inductor VL, because in the pure inductive circuit, so voltage leads the current by 90 degrees. Therefore, compare with the current direction, voltage is forward how much? That is the 90 degrees. And compare with the current, in the pure capacitive circuit, voltage lags behind how much? That is the 90 degrees. Therefore, in pure capacitive circuit, the voltage lags behind 90 degrees, that is the 90 degrees backward, this is 90 degrees forward. Now, if in this diagram, now you can say voltage across the inductor and capacitor both are out of the phase. Out of the phase means what? Both are in opposite, so sense of direction. Means what? Therefore, now if you take now what? So here condition that I am taking that VL greater than VC. If VL greater than VC, now the resultant what you can say, so this is the VR I am taking that, therefore this is the VL minus VC, correct? Because here what I am taking, VL greater than VC and VL VC both are in the opposite direction, the effective voltage across the, so inductor and capacitor combination is 2, that is equal to VL minus VC. VL minus VC the effective voltage across the, so inductor and capacitive circuits, right? No, therefore now what? Here VL minus VC, we are, as I told you, this we should not add them directly. Those are also acting as the vectors. If they are acting as the vectors, therefore if you take this is the Vy value and this is the Vx value, therefore now the total voltage applied V formula V is equal to under root of, so Vx square plus Vr square. Therefore now you can say what? Vr square plus VL minus Vc whole square. This is the most important formula in this discussion. Therefore, whenever a alternating voltage V is equal to V naught sin omega t is connected across this inductor, capacitor and resistor in the series combination, don't take total voltage V is equal to VL plus VC plus VR. That is wrong, because so here the current and voltages both are having the phasor relationship. If those are the phasor relationship, so we should take them as a vector sum. Therefore now the resultant voltage applied, the first formula in this discussion, what? It is equal to voltage applied is equal to, now what? It is equal to VR square plus so VL minus VC whole square. That's it. And now what is that here? Inductor opposes the flow of the current because of the inductive reactance, and capacitor also opposes the flow of the current because of the capacitive reactance. Resistance also opposes the flow of the current because of its resistance. The total opposition offered by the any LCR circuit is called as what? That is the impedance. That impedance is given by Z is equal to under root of that is equal to R square XL minus XC whole square only. XL minus XC whole square. That's it. So Z is equal to under root of R square plus XL minus XC whole square. Next what? The current in the circuit is given by I is equal to what? That is equal to V by Z. I is equal to V by Z. Just you substitute that, because according to Ohm's law you can take. So I is equal to V by Z, we can get the answer. Right? But so in terms of, for example, applied voltage V is equal to V naught sin omega t. Therefore, now the alternating current I is equal to, you can say I naught into sin omega t plus or minus pi. Omega t plus or minus pi. So here I don't know. Direct, we can't take direct plus only. We can't direct minus only. This is the plus or minus pi, we have to take that. For example, in this case, if the voltage across the inductor is greater than the voltage across the capacitor, therefore now what? Inductor dominates the capacitor. When inductor dominates the capacitor, now what? That is acting as the, dominant L circuit. If it is a dominant L circuit, we can take what? Omega t minus pi, because in the pure, in the inductive circuit, in the inductive dominant circuit, current always lags. And if you take VC greater than VL, then who is dominant here? Capacitor is dominant. If the capacitor is dominant, in the dominant capacitor circuits, the current always leads. That's why omega t plus pi we have to take. Right now, not exactly pi by 2, because these are the not pure capacitive, pure inductive circuit. In the pure capacitive circuit only, current leads the voltage by pi by 2. But here, so R is present, inductor also present. That's why if the capacitor is the dominant, then we can take omega t plus pi. How can I know which is dominant? Because VC or VL, which is greater, you check it. Therefore, now what we can say? So if VC greater than VL, so this is the capacitor is dominant. In the capacitor dominant circuits, so omega t plus pi. And if VL so greater than VC, omega t minus pi, you take it, you can get the answer like that. Okay. Therefore, this is the current and voltage across the pure circuit. Now, let us solve one problem. Let us solve one problem, Mama. Now, the problem is, right. Now, the first problem is, in an AC circuit, the voltage is given by V is equal to, V naught, V is equal to, 200 into sin omega t, and I is equal to, I am giving that is equal to, 10 into sin of omega t minus pi by 6, pi by 3. Right now, I is equal to 10. So, sin of, that is equal to omega t minus pi by 3. So, then they will ask that, first of all, find out the power factor. Find out the power factor and also find out the power in the AC circuit. Power factor and power in the AC circuit. What is the power factor? First of all, what is the phase difference between them? So, V is equal to 200 sin omega t, and the current I is equal to how much? 10 sin omega t minus pi by 3. Here V is dominant, because this is not a pure resistive circuit, that is not a pure inductive circuit, that is not a pure capacitive circuit. Because see, if it is a pure resistive circuit, compulsory 10 into sin omega t will come. But what is there? Omega t minus pi by 3. If omega t minus pi by 2 is there, we can say it is a pure inductive circuit. But here what? Omega t minus pi by 3. means what? It is a inductor dominant circuit. So all three elements are there. So inductor dominant circuit, therefore now what? Power factor and power. Therefore power factor what formula what? So between them the power is the phase difference is equal to 0. Phase difference between the, so given two functions voltage and current is equal to 0. Therefore the power factor is given by cos pi. Cos pi value estima, it is equal to cos 60 degrees. Cos 60 degrees is equal to how much now? That is equal to 1 by 2. And what is the power formula? Power is equal to, so what formula? So the power P is equal to V naught I naught by 2 into, so what? It is equal to, so that is equal to cos pi. Therefore now what? V naught value, it is equal to 200 and into I naught value 10 by 2 into 1 by 2. Okay. Therefore now what? So 2 ones are 2 5s are and 2 ones are, so 200s are, that is equal to what? That is equal to 500 watt power is producing in that particular given circuit. Right now, next. Now let us take one more problem. See now. A pure inductor of inductance given, that is equal to, so 50 millihenry, and so connected to a source of 220 volts, means V is equal to 220 volts. Next, find the inductive reactance, means what? XL is equal to how much they are asking, and also and RMS current in the circuit if the frequency of the source F is equal to, so 50 Henry they have given. F is equal to 50 Hz they have given. Right? Therefore now this is the data. L is equal to 50 millihenry, V is equal to 220 volts, XL is equal to how much, and also they are asking what RMS current. So IRMS value is equal to how much? IRMS, that is the so question to us. Generally you see this one, generally we will express the given alternating voltage V is equal to in the form of V naught sin omega t. If they won't give this value, for example like this, let us take that V is equal to 100 sin omega t we are measuring. V is equal to 100 sin omega t, and you know that this is a peak value. This is a peak value. Therefore now what? That peak value how much? V naught is equal to, so 100 volts we can take that. They are asking what? IRMS. IRMS what? Therefore current through the IRMS is equal to compulsory VRMS by, this is the pure inductive circuit. Therefore instead of that what we can take XL value. Initially we have to find out firstly XL value, and VRMS value how much now? 100 by root 2, because VRMS is equal to, so peak value by root 2. So from this what we can find out? VRMS is equal to, so 100 by root 2 you can find out when if they give the values like this. But what they have given 220 volts, then we have to, there is a doubt. So this 220 volts can be taken as RMS value na, peak value na, instantaneous value na. So as I told you, every instrument in the AC circuit measures only RMS. Therefore if they want to mention the given voltage, alternating voltage in the form of either sine or cos function, if they will give the direct value of alternating voltage, please you consider the given value is always a RMS value only. Don't forget this point. Okay na? So if they won't give the sine function or cos function, from this you can find out the RMS value. But if they will give the direct value like that, that is compulsory what? That is the RMS value only we have to consider. So now, here what is that? In this discussion, VRMS value given. Therefore, first of all, let us go for the, so impedance. What is that? So this reactance. XL is equal to how much now? XL is equal to omega into L. So omega value, omega is equal to, so 2 pi F, so into what? Into L, that is equal to 2 pi FL. Therefore, now here, so 2 into, so 3.14 into, so frequency how much? 50, and L value if you take so 50 millihenry, nothing but what? 50 into, so 10 power, so minus 3. So after simplification, so you will get the answer what here? So after simplification, x is equal to, so 15.7 ohms you got it. That is what? So reactance. So which reactance? Inductive reactance. Then after what we can find out now the IRMS value. So IRMS value is equal to what? VRMS value by the given, so reactance XL. VRMS by XL, you can take that. Therefore now, so you can get the answer what? VRMS they have given, so 220 volts by, so 15.7. So if you simplify, after that you can get a almost 14 ampere current. Therefore this is the IRMS current. RMS value of the given current in the circuit. If the same question if you take, so what is the peak value of the current? In the same question I am asking that what is the peak value of the current? If they will ask the peak value of the current, already RMS value you know that. Therefore from this what we can take now? So IRMS is always equal to I naught by root 2, and so I naught is equal to, so root 2 times of so IRMS. Therefore now if you substitute this value 14 into root 2 1.414 into 14, you will get the so RMS value. Next. So last one point. So resonance. So what is the, if you take one inductive and capacitor and resistor connected in series R, C, this is the L, and all these are connected to a AC source of voltage how much? V is equal to V naught sin omega t. Therefore the current passes is what? Nana I. Right now, let's go back to the impedance again. Therefore, now what? Z is equal to under root of, so R square plus XL minus XC whole square. And if you take like this, therefore now R square plus XL is equal to L omega, so 1 by C omega whole square also you can write. Now, what we have to give that? For example, if the circuit frequency means what? This omega value or F value, because omega you can write omega is equal to 2 pi F. If the frequency of the AC source slightly you increase. So when this slowly, if you increase the frequency of the alternating source, then what happen here? So this L omega value increases, 1 by C omega value is going to be, so decreases, and what is that? At a particular value, therefore now what? This both are equal. At a particular frequency of the alternating source, therefore now this both are equal, means what? XL minus XC becomes is equal to 0, because when you for initially this value is maximum. For example, omega is less. When the omega is less, 1 by C omega is more and omega is lesser. Therefore, on increasing the omega, L omega value increases and 1 by C omega value decreases at a particular level. Therefore, now both become equal. When both become equal, so XL minus XC is equal to 0 and XL is equal to XC. Therefore, now what? So, L into omega is equal to 1 by C omega, and after simplification we can get what? Omega is equal to, so that is 1 by root over L into C. This is called resonant frequency, and the circuit under this condition is called as a, so in under resonance. So under resonance, XL is equal to XC, so the impedance in the circuit is minimum, that Z minimum is equal to what? That is equal to R only, and current in the circuit is maximum, that current is I maximum is equal to what? That is equal to, so V by Z minimum, because and when XL is equal to XC, the impedance of the circuit becomes so small. When the impedance of the circuit becomes minimum, therefore now automatically current becomes maximum, that what? That is equal to V by, so Z minimum, so we are giving like this. Right? Therefore now Z value becomes minimum, current becomes what? Maximum. Therefore now the circuit in this case we can call as under resonance. And so what? Here if you express resonant frequency in terms of the linear, so what? Instead of that, better you take omega naught. Therefore now omega naught is equal to what? Omega naught is equal to, so 2 pi F naught and if you substitute there, what you can get, amma? So 2 pi f naught is equal to 1 by root LC, and f naught is equal to what? F naught is equal to 1 by 2 pi root over LC. So all these are formulas for that, and so simple problems only there on the alternating current, and just to go through the LCR series circuit, and one more condition, and sometimes only CR circuit. When CR circuit is there, just to take what? XL is equal to 0 and VL is equal to also 0. Only CR, capacitive and resistor, that is called CR circuit in the series combination. If only L and R are there, therefore now what? L and R, so inductor and resistor circuits, under that condition you take XC is equal to 0 and VC is equal to 0, same formula you will get, right? No, so and L and C also you can take, therefore, so these are the small information related to the alternating current. So all these are the formulas, just to go through the formulas, and it is one of the easiest lesson in the first part of the second year, and more scoring chapter, therefore prepare well. Thank you. Hi sir. అయిపోయింది సార్, మీదైందా?
Okay, ma'am. Good morning, all of you. Right. Today I am going to discuss about again same topic, that is called carbonyl compounds, aldehydes, ketones, and carboxylic acids. Today, right. Remaining part I will cover that. Already yesterday I discussed some of the named reactions. That named reactions, one is the haloform reaction I explained. Other one is aldol condensation also I explained. Now some other named reaction. The named reaction is called what? Cannizzaro reaction. Cannizzaro reaction is already yesterday I have given total information about Cannizzaro, aldol and what you call haloform reaction. Conditions I was given, right? So based on that, again I am giving the small information to you. This one, Cannizzaro reaction want to takes place, we know what we know, absence of alpha hydrogens. So, absence of alpha hydrogens we need carbonyl compound, either aldehydes or ketone containing absence of alpha hydrogens are present, that is undergo Cannizzaro reaction. And again it required concentrated alkali, that means concentrated base, either NaOH or KOH, BaOH twice, any one you can take, right. In this, so yesterday I told which one will give, which one will not give, yesterday I was given positive, negative I told you, right. So, in this one of the example is formaldehyde, that is means methanol reacting with concentrated KOH or concentrated NaOH, anyone you can take, like this they will give you, they will give the question. The first you need to identify that reaction, which type of reaction, right. Concentrated KOH is given means compulsory, that is called Cannizzaro. So, Cannizzaro means how to know that, again absence of alpha hydrogen, presence of alpha hydrogen we need to identify first. So, this is the functional group. Functional group, first carbon, adjacent carbon, there is no other carbon. Adjacent carbon here, that is called alpha carbon. Here alpha carbons are not there, that means alpha carbons are not there means alpha hydrogens are not there, that is the meaning, absence of alpha hydrogen, yes, okay, it is undergo Cannizzaro. So, I told you aldol and Cannizzaro reaction, how many moles of carbonyl compounds we need, the 2 moles of carbonyl compound, 2 moles we need, that is the aldehyde, this also aldehyde, 2 moles of aldehyde, and that what will happen. So, in this 1 mole, first mole and second mole, there first mole, second mole I told already, first mole what you have to remove, second mole what you have to remove. There first mole oxygen, second mole is hydrogen H2 from which carbon, alpha carbon I told, like that. Here 2 moles are there and that first mole is undergo reduction, converted to alcohol, reduction, aldehyde is reduction, aldehyde reduced to alcohol. Again second mole of carbonyl compound is oxidized to salts of carboxylic acid. O minus K plus, is observed now here. From this to this what happened? From this to this addition of oxygen. The addition of oxygen means what you call oxidation. Here to here. What happened here? Here to here. Oxygen is same. Here hydrogens are 2 are there, here hydrogens are 4 are there. That means addition of hydrogens. Addition of hydrogen means this is called reduction. That means what you have to do? What I have to say, in these 2 moles aldehydes are there, the first mole is reduced to, in the presence of KOH, reduced to alcohol, second mole is oxidized to, converted to what, salts of carboxylic acid, that means final product is alcohol and salts of carboxylic acid. That meaning what happened here, 1 mole reduction, other mole oxidation, that means one chemical reaction both undergo oxidation reduction is called as, this is called as, this total information is called as redox reaction. Why you call redox reaction? One chemical reaction undergo both oxidation and reduction simultaneously takes place, that reaction is called as redox reaction. This redox reaction is a special type of redox reaction that is called as disproportionation reaction. What do you call? Disproportionation reaction. Why you call disproportionation reaction? Same molecule, here also this one, both are same molecule. Same molecule undergo oxidation, undergo reduction. At a time simultaneously will takes place, that is called as disproportionation reaction. Finally, what you have to say? Cannizzaro reaction is it is a special type of redox reaction that is called disproportionation reaction, right? That is the product only now. This is called, what do you call, Cannizzaro reaction. Now some other reaction, reactant I am giving to you, this one what you call benzoaldehyde. This is aromatic aldehyde, this is called aliphatic aldehyde with concentrated alkali. Instead of that KOH I am taking NaOH, then what I can get? So NaOH concentrated means compulsory Cannizzaro, because concentrated, that is one of the condition. There are absence of alpha hydrogen, yesterday I told you, absence of alpha hydrogen. So absence of alpha hydrogen means Cannizzaro means compulsory we require 2 moles. They will not mention the question that how many moles we want, that many moles we have to know, we have to take. We have to take means compulsory, that reaction we want to know, right. 2 moles of aldehyde, on the 2 moles of aldehyde, first mole is reduced to, aldehyde reduced to, reduction means alcohol, oxidation means compulsory acid. So it is reduced to alcohol, other mole is oxidized to salts of carboxylic acid. Yes, sodium I am using now, that is why sodium salts of carboxylic acid. This is benzyl alcohol, this is alcohol, this is salts of carboxylic acid. In this is called reduction, that is called as oxidation, right. Next one, observe here. With concentrated KOH, one of the time they ask the question, this one again. One of the time, this is the one of the neat question. COHO, CHO, this is called aldehydes, 1, 2, benzene 1, 2 dicarbaldehyde, also called phthalaldehyde, right. This one aldehyde is there, both are aldehydes are there now. Reacting with what? Concentrated KOH, that means this is also called what you call Cannizzaro reaction. This Cannizzaro reaction will take place within the same molecule. Then what happened? These aldehydes are there. In the 2 aldehydes, one aldehyde is, that means 1 mole. 1 mole of aldehyde is converted to alcohol, CH2OH. Other mole of aldehyde is converted to salts of carboxylic acid, COOK. Sir, why sir this mole is aldehyde, alcohol, this mole is carboxylic acid? Your choice. This mole is alcohol, this mole is, this aldehyde is alcohol, this aldehyde is what do you call salts of carboxylic acid. Your choice. Both are same, right? This is only product. Observe here, this to this. This Cannizzaro reaction will take place between the 2 molecule, one aldehyde, other another, 2 aldehydes, here also 2 aldehyde. This is called as intermolecular Cannizzaro reaction. Like intermolecular hydrogen bond, intramolecular hydrogen bond. It is not a hydrogen bond. So intra, the difference I am saying now. Inter means hydrogen bond present, I am saying hydrogen bond. Hydrogen bond is present between the 2 molecule, 2 polar molecule is called inter. Hydrogen bond present within the molecule or same molecule is called intra. Observe now, here Cannizzaro reaction will take place between 2 molecules, here also here, that is called, these two are called as intermolecular Cannizzaro reaction. Intermolecular Cannizzaro reaction. This Cannizzaro reaction will take place within the molecule or same molecule is called as intramolecular Cannizzaro reaction. Intramolecular Cannizzaro reaction, right. This is the question one of the time they ask in the NEET exam, right. This is the information about what you call Cannizzaro reaction. This is another named reaction, and last and final one named reaction by that named reaction from carboxylic acid, that is called one of the named reaction HVZ reaction, Hell-Hollard-Jelansky reaction. This HVZ reaction will observe in carboxylic acid containing at least 1 alpha hydrogen, that is only in a condition here. So, any carboxylic acid want to undergo HVZ reaction means it requires alpha hydrogen, presence of alpha hydrogen. It is similar to aldol condensation. Aldol condensation means that must be aldehyde. HVZ reaction means that must be carboxylic acid. There also alpha hydrogen, here also alpha hydrogen, the difference observe now. There, that is aldehyde or ketone, that means carbonyl compound. Which one? Aldol. This one is carboxylic acid. Acid must be carboxylic. That is what carboxylic acid. That carboxylic acid having at least 1 alpha hydrogen, it is undergo HVZ reaction. Observe here. I am giving one question to you. This is called formic acid, also called methanoic acid. This is coming from formica, natural source, formica. Formica means ant, red ant. So, formic acid. This will not undergo HVZ reaction because absence of alpha hydrogen. I will take this one. These three, simply I will take these two. This one is what? Propanoic acid. This is called ethanoic acid. These two undergo HVZ reaction. Why? Functional group first carbon is alpha. Alpha carbon containing hydrogen, alpha hydrogen. Yes, alpha hydrogens are there. This is the functional group. Functional group first carbon is called alpha. This is called alpha hydrogen. So that's why these two are undergo HVZ reaction. In case of this one, observe benzoic acid. In case of this one, observe 1, 2, 3, 1, 2, 3, 1, 2. That means 2-phenyl ethanoic acid. In this two, which will undergo HVZ reaction. This will not undergo HVZ because absence of alpha hydrogen. This will undergo HVZ. How? Functional group. Functional group first carbon is alpha. Alpha carbon containing hydrogens are called alpha hydrogen. That's why it is undergo HVZ reaction. Like that, they are asking some questions. So, how many of the following or which of the following undergo HVZ reaction? Some of the question. So, 4 options they will give you. That 4 option, which option we have to choose? How to choose? We should know the condition, right? So, observe now. Question: CH2COOH. I am taking one carboxylic acid. This carboxylic acid is treated with halogen X2. X2 may be chlorine and bromine. In the presence of red phosphorus, small amount of red phosphorus followed by hydrolysis, then what I can get? What I can get means in this alpha hydrogen removed by halogen, then what I can get? R CH COOH. H is replaced by what I can substitute X. H2 is there, X2 is there now. Your X, your H, HX eliminate, byproduct HX, and I am getting this product. So, X may be chlorine or bromine. Chloro means that the product name is called, functional group, this is called alpha. Alpha halo carboxylic acid. What the product I am getting? Alpha halo carboxylic acid I am getting now. Alpha halo carboxylic acid. This is called as what you call HVZ reaction. So, hydrogen atom removed by substituting of halogen. Which hydrogen? Alpha hydrogen means which hydrogen? Alpha hydrogen. Why alpha hydrogen is removed? Because this alpha carbon attached, this group is functional group. Functional group is which functional group? Carboxylic group. Carboxylic acid is a -I and -M electron withdrawing group. Electron withdrawing group. Electron withdraw means what happened? Electrons are withdrawing from this carbon, adjacent carbon. Why sir? This carboxylic acid directed at this carbon, directly attached. So, electron withdraw, pulling towards carboxylic acid. Why pulling towards carboxylic acid? Because electron withdrawing nature. Pulling means what happened? Carbon hydrogen bond strength will be weak. Electrons are pushing means, then what happened? Oxygen hydrogen bond strength will be strong. Now this one, pulling. Why pulling? Because electron withdrawing. That time carbon hydrogen electrons are pulling towards carboxylic acid. That time what will happen? Carbon hydrogen bond strength will be weak. That time hydrogen is coming as H plus. So, loss of H plus means loss of proton. Loss of proton is called acid. That's why this hydrogen is called acidic hydrogen. That is the reason this hydrogen is replaced by halogen. Not, sir, this is alpha, sir, this is beta, sir. Beta also containing hydrogen, sir. That beta hydrogen is acidic hydrogen. Yes, acidic, but compared to this one is somewhat less acidic because this directly attached to the electron withdrawing group. That is the reason now. So, more electron withdrawing group is there, more acidic nature. I am getting alpha halo carboxylic acid. This is called as what you call HVZ reaction. Right. Next one, I will give some questions related to acidic nature of carboxylic acid like a acidic nature of phenol. Already we discussed alcohol, phenol, ether chapter, acidic nature, basic nature also I discussed on the chapter is amines, right? Same information. Acidic nature, just I will remind you, acidic nature is directly proportional to minus I and minus M. That means electron withdrawing group. Now also I told you, so electron withdrawing group. Electron withdrawing group is there, acidic nature is more. That means finally what I have to conclude? Acidic nature of carboxylic acid directly proportional to minus I and minus M, but inversely proportional to plus I and plus M. Minus I means what? Electron withdrawing group. Plus I means what? Electron releasing or electron donating group. Electron withdrawing group increases, acidic nature of carboxylic acid increases. Electron releasing groups or electron donating group increases, acidic nature decreases. Right? This is exactly opposite to the basic nature. Basic nature also I explained. Acidic nature, basic nature directly proportional to plus I and plus M, inversely proportional to minus I and minus M. Some other point I am reminding you, already we know. H plus ion concentration increases. H plus ion concentration increase means acidic nature increases, because H plus ion means proton, more number of proton. That means proton concentration increases, acidic nature increases. So what I can say, H plus ion concentration increases, what is increases? Ka increases, dissociation constant of acid. This is acid, there Kb I told, dissociation constant of base. Kb for base, Ka for acid. Then what happened? pKa. pKa value, the experimental values, no need to remember, they will provide experimental value. pKa value decreases. What about acidic nature? Acidic nature is increases. This is the information, right? H plus ion concentration increases, Ka increases, pKa value decreases, acidic nature increases. Based on this, I am going to give the one question to you. CF3COOH and CCl3COOH. Right? CHCl2COOH. CH2NO2COOH. CH2COOH NC. Sorry, CN. Okay, CN only now. These are the different types of carboxylic acid. I am asking what acidic nature of this carboxylic acid. Right? First one. This carboxylic acid adjacent group, this one. This group is minus I and minus M. This also minus I minus M. Groups you have to write first. Carboxylic acid group, this one, Cl2 directly, minus I minus M. Here NO2, minus I minus M. Here Cn, minus I minus M. Already we know. Electron withdrawing group increases, acidic nature increases, correct. So minus I and minus M order I was given. That order I was given, order is on that order, which one is strong electron withdrawing group? NO2. NO2 is the more withdrawing group, that order I was given, NO2 followed by Cn, Cn followed by halogens only, actually, right? If you observe that one, highest one is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, this is 4, this is 5, this is 3, this is 2, this is 1. Based on order, more NO2 is there, so NO2 is there, that is called actually more electron withdrawing group, more acidic actually, okay. But here, NO2 and fluorine, NO2 is the more electron withdrawing group than fluorine, order. But here only one NO2 group is there, here only one fluorine is there, that's why NO2 is more than fluorine, correct. NO2 1, F also 1. But here NO2 is 1, fluorines are 3, that means more fluorine, more means more electron withdrawing compared to NO2. More electron withdrawing group is there, more acidic, that's why it is first one. First one is first one, you know. Next, same as it is, NO2 and Cl, which one is more? Cl only, no, sorry, NO2 only, NO2 more than Cl only, no, electron withdrawing order. But there NO2 is there, here more 3 Cls are there now, that's this is more electron withdrawing, that's highest. Same again, NO2 and Cl, NO2 only highest, but here 2 Cls are there, here only one NO2 there, that's why 3, next one fourth one, next one is fifth one. This is the order, acidic nature order of carboxylic acid. One of the time they ask the question like that, they are given, write the increasing or decreasing. Now this is called decreasing order, they are asked increasing order of acidic nature. Next, this one, carboxylic acid with OCH3, this is aromatic. This is called benzoic acid. Right. These three are there. Write the increasing order of acidic nature of these carboxylic acids. These all are benzoic acids. Here NO2 group is there, that is what? Minus I and minus M. This group is there. What is the group? This one, alkoxy, also called methoxy. Methoxy group in case of inductive effect is minus I. In case of mesomeric effect is plus M. Already I told you, some of the groups will exhibit minus I and minus M. That time dominating factor is plus M. Mesomeric effect is dominating than inductive effect. That means electron, plus M means electron releasing group. Minus I means electron withdrawing group. So electron releasing is dominating than electron withdrawing. That means this is plus M only dominating. Right? This is neutral. This is not having any group. In these three, which are highest? NO2 is highest. That means 3. Electron withdrawing group increases, acidic nature increases. Now 2 and 1, which one highest? This electron releasing group, this is neutral. So neutral is more than electron releasing group. This is the order, acidic nature order of this what you call aromatic carboxylic acids. Next one. This is these three. One of the time they ask the question. Simple question. Fluorine, chlorine, bromine. So here all carboxylic acids, but here fluorine, bromine, chlorine, these all are minus I, and so in case of minus I, I will see there. Plus M also will there. Plus M here. Plus M when we have to follow when resonance is there. Here resonance chance is there. That's why it will exhibit minus I only. Minus I factor you have to include. Minus I means electron withdrawing group. In this picture, highest electron withdrawing group. Highest electron withdrawing group, how can you say? Based on the electronegativity. In this picture, is the more electronegative. Fluorine is the more electronegative than chlorine than bromine. More electron withdrawing group is more electronegative element is more electron withdrawing nature. More electronegative element is more electron withdrawing nature. Which is the more electronegative element? Fluorine. Next one, chlorine. Next one, bromine. That's it is minus I more. Next minus I, next minus I. Means electron withdrawing group nature is more, acidic nature is more. So answer is 1 first, next followed by 3, next followed by 2. This is the information about what you call acidic nature. Right. Some other questions we have to solve now. Listen, previous year questions. CH3, KMNO4 followed by KOH followed by heat and hydrolysis. That one. Next one is Br with NO2, Mg in dry ether, again dry ice followed by hydrolysis. What the product I can get? This is only, these are the questions. These two first. Later we will discuss remaining. KMNO4 followed by KOH. This KMNO4 in alkaline medium, it is a strong oxidizing agent. Already we know. Strong oxidizing agent, mild oxidizing agent I was given. Strong oxidizing agent is a direct final product is carboxylic acid. So answer is first one, salts of carboxylic acid first, that means COOK followed by hydrolysis means what I can get benzoic acid. Here whatever the group is there, that group we do not want now. Whatever the group is there. So benzene ring will not touch benzene ring as it is. Whatever the group is there, whatever the alkyl group is there, that alkyl group is directly converted to carboxylic acid. Whatever the longest chain is there, irrespective of the longest chain. This longest chain may be 100 carbons also there, directly converted to benzoic acid. That means, sir, 100 carbons are there, 99 carbons straight chains are, 100 carbon is directly converted to acid. Not like that. Whatever the carbons are there, we don't want to directly attach to benzene ring. For example, like this. Just I will go other example, then you will get it. CH2, CH2, CH3. This is called propyl benzene or N-propyl benzene. Okay, leave it now. So this is carbon, this benzene ring is there with KMNO4, KOH, very important question number this one, right? So KOH followed by hydrolysis. This is strong oxidizing agent. Benzene attached carbon, that is called benzyl carbon. That benzyl carbon is, it will oxidize more fast compared to remaining. That means this longest chain is 3 carbons are there. The 3 carbons, the total carbons will be break down. Only this carbon will be converted into carboxylic acid. Remaining carbons are this byproduct. Sir, actually these 3 carbons are there, sir. 3 carbon, 2 carbon as it is, sir. The third carbon is converted to carboxylic acid. That is the answer we will expect actually. But that is wrong, purely wrong. Then whatever the carbon group directly attached to the benzene ring, that is called benzyl carbon. That group only will convert it to carboxylic acid. That means answer is what? Directly benzoic acid only now. There also benzoic acid, here also benzoic acid, but there is 1 carbon, here 3 carbons are there. That means, that is the meaning. Irrespective of the longest chain, directly converted to what? Benzoic acid. This one observe. This is called, those two are called benzyl. This is called isopropyl. This is the longest chain. These two. This is substituent. Isopropyl benzene is called cumene. KMNO4 followed by alcoholic KOH followed by heating followed by hydrolysis. Next one. Same reagent. That is toluene, this is N-propyl benzene, that is called straight chain. Straight chain directly converted to benzoic acid. This is called isopropyl. This is called tertiary butyl benzene with KMNO4. What is the product? Here also whatever chain is there, we do not want. Direct answer is benzoic acid. Remaining carbons are there, what will happen, sir? Remaining carbons are converted to byproduct. Okay, that is the benzoic acid. What about this? Here also directly, what will think directly, sir? You will directly convert it to benzoic acid. You only told, sir. what I told. So whatever the carbons are there, irrespective of the carb, directly converted to benzoic acid. Yes, benzoic acid, you know. But here, no product will get it, you know. What is the reason? Simple. What is simple? Our understanding point of this is primary, this is secondary, this is tertiary. This want to undergo which carbon will undergo oxidation, I told, irrespective of the chain. Which carbon is directly attached to the benzene ring, which carbon is directly attached to the benzene ring, that carbon will directly converted to carboxylic acid. Yes, this carbon, in this carbon directly converted to carboxylic acid. In this carbon directly converted to benzoic acid. In this carbon directly converted to benzoic acid. In this which carbon? This carbon. Yes, that carbon will undergo oxidation, but this is tertiary. Tertiary means what happened? Absence of alpha hydrogen, that is the condition we need. Absence of alpha hydrogen. That means any carbon, any functional group any group want to undergo oxidation means it required alpha hydrogen. Yes, observe here. This is the functional group, sir. Functional group means double bond, sir. Double bond attached to first carbon. Functional group attached to first carbon is called alpha. Alpha carbon containing hydrogens are alpha hydrogens. Yes, three are there. Here, functional group double bond. Functional group first carbon alpha. This is beta. This is gamma. We don't want beta gamma. We want alpha. Yes, alpha carbon containing hydrogens two are there. Two alpha hydrogens are there. That's why it is undergo oxidation. Observe here. Double bond. That is called functional group. First carbon alpha. Alpha carbon. This is alpha. This is beta. This is beta. Alpha carbon containing hydrogens are called alpha hydrogen. Yes, how many there? 1, here 2, here 3. These are undergo oxidation. What about this? Functional group. That means double bond. This is alpha. Alpha carbon. This alpha. This is beta. This is beta. This is beta. Alpha carbon there, but absence of alpha hydrogen means alpha hydrogens are not there. That's why it is not undergo oxidation. That means no product. One of the time they ask the question. Which are the following different types of benzoic acids, different types of what you call alkyl benzenes will not undergo oxidation. They are asked one of the question. So this is the answer now. Tertiary butyl benzene will not undergo oxidation with KMnO4. Reason is absence of alpha hydrogen. That is the question. Right. Next one. Question. Br is there, NO2 is there with magnesium in dry ether, that is called Grignard reagent. Grignard reagent means magnesium metal is inserting or introducing between carbon and halogen. And what I can get? MgBr, here NO2, followed by dry ice. Dry ice means, dry ice is called carbon dioxide, adding of carbon dioxide. Grignard reagent with carbon dioxide. What I can get? Carboxylic acid, one of the reaction, already named reaction, like a named reaction, right? Carbon dioxide, they are given dry ice. Dry ice means carbon dioxide. Then what I can get? Carbon and oxygen, which is the more electronegative? Oxygen, electron towards oxygen side. Oxygen getting which charge? Negative charge. Carbon getting which charge? Positive charge. Here, this is called Grignard reagent. Already told, Grignard reagent will generate nucleophile. Magnesium plus 2, halogen minus 1, this carbon having the negative charge. That means nucleophile. This nucleophile will be added to the, where the electrophile is there only will be added. Oxygen getting negative charge means negative, carbon getting what? Positive charge. That positive charge will be added here. Then what I can get the answer? C. O minus, double bond O. What is there now? MgBr. This MgBr attached to this with NO2. Then followed by what? Hydrolysis. Breaking. Hydrolysis. Adding of water. Where I have to add the water? Here I have to break the bond. This side HA. This side OH. Adding of water H2O. That means byproduct is MgOHBr byproduct. This is our requirement product. C double bond O with H, that means carboxylic acid and NO2. That means para-nitrobenzoic acid. or 4-nitrobenzoic acid. This is the final product. Byproduct is MgOHBr. This is only answer for this compound. This one. So one of the time they ask the match the following question. Direct answer I will write you. Ethanoic acid. These are the uses of carboxylic acid. Ethanoic acid, where we have to use. That is only called application. Ethanoic acid, where you have to use. Ethanoic acid used as a vinegar. Vinegar in food industry. Food industry. Next one. Hexane. Okay, simply hexane dioic acid. Hexane dioic acid name already we should know. We have to know hexane dioic acid, also called adipic acid. Where we have to use this? We have to use in manufacture of nylon 66. Sodium benzoate. Where you have to use sodium benzoate. Sodium benzoate is used in a food preservative. Food preservative. Next one, higher fatty acids. Where you have to use higher fatty acids. Manufacture of soaps and detergents. This is only information. These they are given jumbling. Match the following. So, ethanoic acid where you have to use used as a vinegar in food industry. Hexane dioic acid, that is called adipic acid, where you have to use manufacture of nylon 66. Next one, sodium benzoate, where you have to use food preservative. Higher fatty acid, where you have to use to the manufacture of soaps and detergents. This is only now. One of the time they ask this, match the following question. Some other one is there. Formalin. Formalin. Formalin, what is the name of formalin? 40% aqueous solution of formaldehyde is called as formalin. One of the time they ask the question. So what is formalin? Formalin is called 40% aqueous solution of formaldehyde is called formalin. What is the use of the formalin? To preserve the biological specimens. First one. What is the use of the formalin? Why I am saying this point, one of the time they ask the statement based question. 40% aqueous solution of ethanol is called formalin, statement 1. That is wrong. So 40% aqueous solution of formaldehyde is called formalin. So where we have to use, that is applications, where you have to use formalin used as a biological to preserve the biological specimens. That is the first point. Second point is manufacture of phenol formaldehyde resin. Phenol plus formaldehyde to making of resins. Phenol is mixing with formaldehyde to form a resin. This you will use in polymer chapter. Of course, polymer is not there. That's what phenol plus formaldehyde is called resin. This is called as bakelite. Phenol plus formaldehyde making is called as bakelite. So one of the time they ask the question. Bakelite. Bakelite is called the mixture of phenol plus formaldehyde with one of the polymer. Bakelite. Nylon 66 also one of the polymer. Next one. Urea plus formaldehyde. Urea is mixing with formaldehyde. It is also one of the polymer. It is used as a glue. Making of glue. Making a glue means what they will use? Urea plus formaldehyde. These all are having what they are no formaldehyde combination. One is biological specimen, there also formaldehyde is there. Other one is bakelite formation, also formaldehyde is there. Again glue formation, that is also having the formaldehyde. This formaldehyde is called 40% we have to take. 40% aqueous solution of formaldehyde is called what you call finally formalin. Is the information about carbonyl compounds. Now we will solve some questions now. Right. I will write some questions on the board, then we have to solve. C6H5 C double bond OH with NH2 NH C double bond NH2. First question, what the answer, that is X. Product name, product. Next one. This one with next one. Benzophenone from benzene. Right. There are some questions now. The question answers are observed now. Benzaldehyde reacting with what is this? Ammonia and ammonia derivative, that is called semicarbazide. That is called semicarbazide. So these are called ammonia and ammonia derivative means what you have to do? Directly you have to remove the water molecule I told yesterday. Right? So water molecule, then write the product. Water molecule means oxygen from carbonyl group, H2 from this group, ammonia and ammonia derivatives. So H2 remove from which side? I told you already clearly, right and left. Right side NH2, left side NH2, right side NH2. Left side NH2 you have to remove. Why? Because right side NH2 having the lone pair of electron involving in the conjugation, because having the lone pair of electron having the conjugation, so involves resonance. Conjugation is lone pair, single bond, double bond. So double bond, single bond, lone pair, that is having the conjugation. Conjugation means it involves in resonance. That's why right side H2 will not involve, left side H2 will involve. H2 and O water eliminate. So answer is C6H5CH double bond, H2 eliminate, N, NH, C double bond O, NH2. This is the product, water eliminated. Right, next one. This is the product, cyclohexane ring is given. One is aldehyde, other one is ketone. This is the ketone. Aldehyde and ketone is given with very, very important. What is this reagent? That reagent you should know. That is called ammonical silver nitrate. Silver is there. Ammonical silver nitrate. Here Ag in the oxidation state is +1 because ammonia is a neutral ligand. In the presence of alkaline medium, that is called basic medium, this reaction is called, that reagent is called as what you call Tollens reagent. Tollens reagent, ammonical silver nitrate. Yesterday I told that yesterday I discussed in the class. Tollens reagent, what is the Tollens reagent? Ammonical silver nitrate, freshly prepared ammonical silver nitrate is called Tollens reagent. Right? This is a mild oxidizing agent. This mild oxidizing agent uses distinguish between aldehydes and ketone, or Okay, distinguish test for aldehydes and ketone. That means aldehydes will give the positive, ketones will give the negative. That means a tolerance reagent with aldehyde will reaction will takes place, tolerance reagent with ketone no reaction. Then what happened? Aldehyde and ketone is there, which one will react? Aldehyde. Ring as it is, ketone as it is, ketone will not touch, will not oxidize, but aldehyde is oxidized to salts of carboxylic acid. Oxidized means mild oxidizing agent. Mild oxidizing agent means compulsory directly converted to acid only. So from this to this one step only, mild. That's what salts of carboxylic acid. From here to this what happened? Addition of oxygen. Addition of oxygen means what you call oxidation. This is oxidation, which is undergo oxidation, that is called reducing agent. This is reducing agent. What about this? Oxidizing agent. This is called oxidizing agent. Which oxidizing agent? Mild oxidizing agent, tolerance reagent. So this is the answer. Next one. Starting metal benzene to benzophenone. From here is what the difference is there now. Benzene as it is, this group extra. That means keto with benzene. That is called benzyl chloride extra. This one is this one. This we have to add extra chlorine. In the presence of anhydrous AlCl3, what is called Lewis acid. This reaction is called as, that means benzene with, for example, this benzene place R you take, RC11OCl. That is called acid chloride. Acid chloride in the presence of anhydrous AlCl3 is called Friedel-Crafts acylation. Friedel-Crafts acylation. What do you call? Friedel-Crafts acylation. Friedel-Crafts acylation is one of the electrophilic substitution reaction. Benzene and benzene derivatives undergo electrophilic substitution reaction. So this is Friedel-Crafts acylation. Electrophile is AlCl3 with Cl, AlCl4 eliminate, then benzene with CO, acyl carbonium or benzyl carbonium ion. Benzoyl carbonium ion is the form that will attack to that, then you will get this product. Next. Cyclohexane, hexane with double bond CH, that means unsaturated compound. Unsaturated compound directly converted to aldehyde. Then how to do? How to do means that is aldehyde. If it is ketone, some other way, if it is aldehyde means what? So aldehyde, how it will get primary alcohol or secondary alcohol? Primary alcohol undergo oxidation. Primary alcohol undergo oxidation will get aldehyde. Secondary alcohol oxidation will get ketone. Now the product is aldehyde. That means this must be primary alcohol. This must be, I want primary alcohol. Primary alcohol means how to get? Two possibilities are there now. Two possibilities. The two possibilities also I will write. H2O followed by H plus. Alcohols you are getting two possibilities. H2O followed by H plus one possibility. One alcohol will get. Second possibility is BH3 twice, that is called diborane, followed by H2O2 in the presence of OH, alkaline medium, NaOH. See, hydrogen peroxide means with condition. Here without condition. Here adding of what? Water. Adding of water in the presence of acid, that is called acid catalyzed hydration. Adding of water means that is called hydration. Adding of water in the presence of H plus is called hydration. Now means without condition. Without condition means it is follows which rule? Markovnikov rule. Now here diborane in the presence of H2O2 by adding up in the presence of alkaline medium. That means it is also here adding water only now, but here water is not given, that water is coming from OH is coming from H2O2 hydrogen peroxide. That means here also adding water only, that means indirectly. So but here condition is there, which condition? Peroxide, hydrogen peroxide. It is follows which rule? Anti-Markovnikov rule. That is only now different. If it is Markovnikov rule is there, addition of water, H plus and OH minus, it is the product. CH2 first. Here OH we have to add, here hydrogen. Oh, this is the answer. For what? This one. Water in the followed by H plus. Now this is which alcohol? 1, 2, 3, tertiary alcohol. This tertiary alcohol, this we don't want tertiary alcohol. We want either primary or secondary. Primary means aldehyde, secondary means ketone. So in case of BH3 followed by H2O2 and OH means that means anti-Markovnikov rule. So anti-Markovnikov rule means what I can get the product? Observe here, same. CH2, right? We are adding indirectly water means H2O. That means where how do you add OH here, hydrogen here. That which alcohol? Primary alcohol. Which follows which rule? Anti-Markovnikov. Exactly opposite to the Markovnikov rule. Negative part, nucleophile will be added to the carbon containing more number of hydrogen. This is what? Alcohol. Which alcohol? Primary alcohol. Our product is aldehyde. So this alcohol undergo oxidation, further oxidation. Further oxidation means two possibilities are there, strong oxidizing agent, mild oxidizing agent. If strong oxidizing agent is the directly final product is carboxylic acid. But we don't want strong oxidizing agent. What we have to use here? Mild oxidizing agent, because the reaction will stop at aldehyde or ketone. That means mild oxidizing agent. Mild oxidizing agent, what are those? PCC, PDC, anhydrous CrO3. Anyone you can use. So PCC I am using, pyridinium chlorochromate. So answer is alcohol is converted to what? Aldehyde. So this is our requirement product. That is the requirement product. So first what you have to do? This one unsaturated compound followed by hydroboration and oxidation, HBO, hydroboration followed by oxidation. This one, it is follows anti-Markovnikov rule, we will get the primary alcohol followed by primary alcohol followed by oxidation by using mild oxidizing agent, we will get the aldehyde. Next one. So this is the product they are given. This product we want to get means the reactant is under ozonolysis. So they are asking reactant, product is formed. Actually sometimes they will be reactant, this type of question also we discussed. Reactant they will give you by ozonolysis, you will get the product, what are the product they will ask. Now here reverse they are given, what they give reverse? Product they are given, they are asking what do you call? Reactant, ozonolysis. Already we know how many moles you are getting? 2 moles of this one, 2 moles of this one you write down first like this adjacent. So ozonolysis means what I told? Identification of double bond. Identification of double bond I told. Wherever the double bond is there, double bond you have to break down. Left side and right side you have to keep the oxygen I told. So breaking of double bond, keeping of oxygen on both sides. That is called ozonolysis. Now we are making whatever the bond, double bonds with the double bond you have to remove. Means oxygen we have to remove. Then you have to join. So O remove. Why sir 2 moles you are taken? They are given 2 moles in the product. And what I can get? These two both we have to join. What is their double bond? This is the answer. If you are getting doubt, again product due to the ozonolysis reverse. Breakdown, oxygen, oxygen. You will get benzene with cyclohexane with keto group. That is cyclohexanone you will get it now. This is the product. Next. CH3NO2. Br2 followed by Fe. Again Fe followed by H plus. This is 1, this is 2. Third one HONO. Fourth one CuCl. Fifth one KMNO4. What is the product? That means 5 reagent they are given now. Observe here. First one, what they given? Right. Toluene. Otherwise 1, 2, 3, 4. 4 nitro methyl benzene with Br the presence of Fe. Fe they are mentioned, they are not mentioned. condition means that is called Fe in the presence of dark. Br2 in the presence is they are not mentioned Fe means they will compulsory they will mention the light, sunlight. They are not mentioned anything means that is called dark. That's it is undergo. This is called halogenation. Bromine in the presence of FeCl3, that is called halogenation. Halogenation. Halogenation means what will happen here? Observe now. Halogenation means benzene and benzene derivatives undergo electrophilic substitution reaction. It move to ortho and para position. So here one important point. What is the important point? Incoming electrophile moving to which position? That position will be decided by already whatever the groups present on the benzene ring. Those groups will be decided. Incoming electrophile move to which position? Here what are the groups are there? Here one is NO2, one is CH3 is there. Right? Electrophilic substitution reactions are increased by only electron releasing groups. So main electron releasing group. That meaning two different groups are there, which is highest electron donating group is there, that electron donating group will be decided. But order is there, that order. Electrophilic substitution reaction is increased by plus I and plus M means electron donating and electron withdrawing groups. Electron releasing plus I and plus M. Electrophilic substitution reaction is inversely proportional to minus I minus M means electron withdrawing group increases, electrophilic substitution reaction decreases. So electrophilic substitution reaction want to increase means we need electron donating group or electron releasing group. This electron releasing group which one? CH3 than NO2. That means CH3 is the dominating factor, more activating, this is deactivating. This group will be decided. So activating groups are there, ortho para directing, withdrawing groups are there, meta directing. So which will decide? Every time activating group will be decided in case of electrophilic substitution reaction. That point keep in mind. So for this one, ortho which one? This is the ortho, this is the ortho, this is meta, this is meta, this is para. So we will move to ortho and para. So para already blocked because of NO2. We will move to which position? Ortho. So answer is CH3 followed by Br and followed by NO2. This is the first one, first reagent. This is the answer, first reagent. Second one, FeHCl. Fe followed by H plus means Fe followed by HCl. That is called reducing agent. Reducing agent means the CH3Br will be same. NO2 converted to NH2. Reduction. This is the second one. Third one, HONO. HONO means HNO2. Combined now. HNO2, that is called HNO2, nitrous acid. This nitrous acid is coming from NaNO2 plus HCl. This already we know. So HNO2 plus byproduct is NaCl. This HNO2. This HNO2 is coming from NaNO2 plus HCl. Sodium nitrate plus hydrochloric acid, that is called diazotization. Then you will get diazonium salt. CH3 as it is, Br as it is, NH2 is converted to what? N2 plus Cl minus. Then that is third, this is third one. Fourth one, cuprous chloride. That means diazonium salts with cuprous chloride followed by HCl, that is called Sandmeyer reaction. Then you will get CH3, Br as it is. Here what you get? N2 plus, N2 gets eliminate, HCl eliminate, then what I can get? Cl. Chloro in the fourth position. Then that is called fourth one. Fifth one, by using KMnO4, strong oxidizing agent. Already we discussed KMnO4. Alkyl group is there. Only alkyl. Br chlorine as it is. Only alkyl groups. Alkyl group directly converted to what? Carboxylic acid. So CH3 is converted to COH. Br as it is. Cl as it is. This is the product. Last one. This is 1. This is 2. This is 1. This is 2. This is 3. This is 4. This is 5. 5 reagents. This is the answer now. Right? This is the information. Right? Okay, ma. Thank you. Remaining I will continue. Remaining just only one chapter is there. That is what? For total organic chemistry, first year and second year. That is what? Only biomolecules. Tomorrow I will discuss some important points and some important concepts. Tomorrow I will discuss. Okay. From Monday onwards we will start the grand test. Okay ma? Thank you. Right.
Good morning all and very glad to see you. Yesterday we have discussed about axial skeleton. Ribs are remained. Except ribs, we have discussed everything regarding axial skeleton. So today we are going to discuss about ribs. My dear students, basically in our body 12 pairs of ribs or 24 ribs are present. In our body 12 pairs of ribs or 24 ribs are present. These 12 pairs of ribs are distinctly divided into three categories. 12 pairs of ribs are distinctly divided into three categories. Number one, true ribs. Number one, true ribs are vertebrosternal ribs. First one, true ribs are vertebrosternal ribs. And second category, false ribs. False ribs are vertebrochondral ribs. Vertebrochondral ribs. And third category, floating ribs. Don't confuse. 12 pairs of ribs are distinctly divided into three categories. Number one, true ribs are vertebrosternal ribs. Second one, false ribs are vertebrochondral ribs. And third one, floating ribs. Floating ribs. So discuss individually. First one, true ribs. True ribs are scientifically called vertebrosternal ribs. Got it? True ribs are scientifically called vertebrosternal ribs. Dear students, first 7 pairs of ribs come under true ribs or vertebrosternal ribs. First pair, second pair, third pair, fourth pair, fifth pair, sixth pair and seventh pairs of ribs. Simply we can say first 7 pairs of ribs are commonly called true ribs or vertebrosternal ribs. First 7 pairs of ribs are commonly called true ribs or vertebrosternal ribs. Dear students, dorsally true ribs are vertebrosternal ribs. Nothing but first 7 pairs of ribs. Dorsally true ribs or vertebrosternal ribs will be attached to thoracic vertebra. Understood? Dorsally true ribs or vertebrosternal ribs or dorsally first 7 pairs of ribs will be attached to thoracic vertebra. Yesterday we have learnt about thoracic vertebra in detail. Dorsally true ribs or vertebrosternal ribs or dorsally first 7 pairs of ribs will be attached to thoracic vertebra. But ventrally true ribs are ventrally vertebrosternal ribs. Ventrally true ribs or vertebrosternal ribs will be attached to sternum with the help of hyaline cartilage. With the help of hyaline cartilage. We have learnt about sternum yesterday. Sternum is commonly considered as breastbone. Total number of sternal bones 1. Sternum comes under axial skeleton. Sternum is a flat bone. Sternum is situated on ventral midline of thorax. Ventral midline of thorax. Coming to hyaline cartilage. Basically, cartilages are of 3 types. Cartilages are of 3 types. Namely, number 1, fibrous cartilage. Second one, elastic cartilage. And third one, hyaline cartilage. Fibrous cartilage, elastic cartilage, hyaline cartilage. Fibrous cartilage is the strongest of all other cartilages. Fibrous cartilage is the strongest of all other cartilages, but hyaline cartilage is the delicate of all other cartilages. Understood? True ribs are scientifically called vertebrosternal ribs. First 7 pairs of ribs are commonly called true ribs or vertebrosternal ribs. Dorsally true ribs or dorsally vertebrosternal ribs or dorsally first 7 pairs of ribs will be attached to thoracic vertebra, but ventrally true ribs or ventrally vertebrosternal ribs or ventrally first 7 pairs of ribs will be attached to sternum with the help of hyaline cartilage. Understood? Right. Once focus here. First 7 pairs of ribs are true ribs or vertebrosternal ribs. Dorsally true ribs or vertebrosternal ribs or dorsally first 7 pairs of ribs will be attached to thoracic vertebra. But ventrally true ribs or vertebrosternal ribs or ventrally first 7 pairs of ribs will be attached to sternum with the help of hyaline cartilage. Okay? And next category, false ribs. Next one, false ribs. False ribs are scientifically called vertebrochondral ribs. False ribs are scientifically called vertebrochondral ribs. My dear students, first 7 pairs of ribs are true ribs or vertebrosternal ribs, very clear. Next, 8th pair, 9th pair and 10th pairs of ribs. 8th pair, 9th pair and 10th pairs of ribs are commonly called false ribs or vertebrochondral ribs. First 7 pairs of ribs are true ribs or vertebrosternal ribs, very clear. And 8th pair, 9th pair, 10th pairs of ribs are commonly called false ribs or vertebrochondral ribs. Based on this, we can conclude like total number of false ribs or total number of vertebrochondral ribs are 3 pairs. Total number of false ribs or total number of vertebrochondral ribs are 3 pairs, namely 8th, 9th and 10th pairs of ribs. Just like true ribs, dorsally false ribs are dorsally vertebrochondral ribs. Dorsally false ribs or dorsally vertebrochondral ribs or dorsally 8th, 9th and 10th pairs of ribs will be attached to thoracic vertebra. Dorsal attachment to thoracic vertebra is common salient feature of both the true ribs and false ribs. Understood? Dorsally false ribs or dorsally vertebrochondral ribs or dorsally 8th, 9th and 10th pairs of ribs will be attached to thoracic vertebra. But ventral arrangement will be different. Here dorsal arrangement of true ribs and dorsal arrangement of false ribs will be the same. But ventral arrangement will be different. So in case of true ribs, ventrally true ribs or ventrally vertebrosternal ribs or ventrally first 7 pairs of ribs will be attached to sternum with the help of hyaline cartilage we have discussed just now. Here ventrally false ribs or ventrally vertebrochondral ribs or ventrally 8th, 9th and 10th pairs of ribs will not be attached to sternum directly. Ventrally false ribs or ventrally vertebrochondral ribs or ventrally 8th, 9th and 10th pairs of ribs won't be attached to sternum directly. Please keep it in your mind. Instead of that, ventrally false ribs or vertebrochondral ribs or ventrally 8th, 9th and 10th pairs of ribs will be attached to hyaline cartilage of 7th pair of rib. Hyaline cartilage of 7th pair of rib. Andre ventrally 8th pair of rib will be attached to hyaline cartilage of 7th pair of rib. At the same time, ventrally 9th pair of rib will be attached to hyaline cartilage of 7th pair of rib. At the same time, ventrally 10th pair of rib will also be attached to hyaline cartilage of 7th pair of rib. Understood? Please keep it in your mind. 8th, 9th and 10th pairs of ribs are commonly called false ribs or vertebrochondral ribs. Here total number of false ribs or total number of vertebrochondral ribs are 3 pairs. Dorsally false ribs or dorsally vertebrochondral ribs or dorsally 8th, 9th and 10th pairs of ribs will be attached directly to the thoracic vertebra. This is the common salient feature in case of both the true ribs and false ribs. But ventrally false ribs or ventrally vertebrochondral ribs or ventrally 8th, 9th and 10th pairs of ribs won't be attached directly to the sternum. Instead of that, ventrally false ribs or ventrally vertebrochondral ribs or ventrally 8th, 9th and 10th pairs of ribs will be attached to hyaline cartilage of 7th pair of rib. Andre ventrally 8th pair of rib will be attached to hyaline cartilage of 7th pair of rib and ventrally 9th pair of rib will be attached to hyaline cartilage of 7th pair of rib and ventrally even 10th pair of rib will also be attached to hyaline cartilage of 7th pair of rib. Okay, I hope you people have understood this. Once keep focus here everyone. Don't confuse amma. 8th, 9th and 10th pairs of ribs are false ribs or vertebrochondral ribs. Total number of false ribs are 3 pairs. Dorsally false ribs or dorsally vertebrochondral ribs or dorsally 8th, 9th and 10th pairs of ribs will be attached to thoracic vertebra just like true ribs. But ventrally false ribs or ventrally vertebrochondral ribs or ventrally 8th, 9th and 10th pair of rib will not be attached to sternum directly. Instead of that, ventrally false ribs or vertebrochondral ribs or ventrally 8th, 9th and 10th pairs of ribs will be attached to hyaline cartilage of 7th pair of rib. Okay na? So first 7 pairs of ribs are true ribs or vertebrosternal ribs. Dorsally first 7 pairs of ribs will be attached to thoracic vertebra. But ventrally first 7 pairs of ribs or ventrally true ribs or ventrally vertebrosternal ribs will be attached to sternum with the help of hyaline cartilage. But unlike true ribs, ventrally false ribs or vertebrochondral ribs or 8th, 9th and 10th pairs of ribs will not be attached to sternum directly. Instead of that, ventrally 8th, 9th and 10th pairs of ribs will be attached to hyaline cartilage of 7th pair of rib. Right. Only one category is remained, floating ribs. Floating ribs. Remaining 11th and 12th pairs of ribs. 11th and 12th pairs of ribs are commonly called floating ribs. First 7 pairs of ribs are true ribs or vertebrosternal ribs. 8th, 9th and 10th pairs of ribs are false ribs or vertebrochondral ribs. And remaining 11th and 12th pairs of ribs are floating ribs. It means total number of floating ribs are 2 pairs. Total number of true ribs are 7 pairs. Total number of false ribs are 3 pairs. Total number of floating ribs are 2 pairs. Namely 11th and 12th pairs. Just like true ribs, just like false ribs, dorsally floating ribs are dorsally 11th and 12th pairs of ribs. Dorsally floating ribs are dorsally 11th and 12th pairs of ribs will be attached to thoracic vertebra. Amma, conclusion. Dorsal arrangement of true ribs, dorsal arrangement of false ribs, dorsal arrangement of floating ribs is same. Dorsally true ribs, dorsally false ribs, dorsally even floating ribs will be attached to thoracic vertebra. But ventral arrangement of true ribs, ventral arrangement of false ribs and ventral arrangement of floating ribs will be different. Okay na? Dorsally floating ribs or dorsally 11th and 12th pairs of ribs will be attached to thoracic vertebra. But ventrally floating ribs are ventrally 11th and 12th pairs of ribs will not be attached. Will not be attached either directly or indirectly to the sternum. Clear? Ventrally floating ribs or ventrally 11th and 12th pairs of ribs will not be attached to the sternum either directly or indirectly. Understood? But ventrally false ribs or ventrally vertebrochondral ribs or ventrally 8th, 9th and 10th pairs of ribs will be attached indirectly to the sternum. It means will be attached to the hyaline cartilage of 7th pair of ribs. We have discussed just now. Here ventrally floating ribs or ventrally 11th and 12th pairs of ribs will not be attached either directly or indirectly to the sternum. This is about floating ribs. My dear students, thoracic vertebra, ribs and sternum. Thoracic vertebra, ribs and sternum. These three components constitute rib cage. Rib cage. Thoracic vertebra, ribs and sternum constitute rib cage. It means rib cage is formed by the union of thoracic vertebra, ribs and sternum. Or simply we can say thoracic vertebra, ribs and sternum constitute rib cage. Thoracic vertebra, ribs and sternum play a vital role in formation of rib cage. My dear students, I have given one essential statement just now. Dorsal arrangement of true ribs, dorsal arrangement of false ribs, dorsal arrangement of floating ribs is same, but ventral arrangement is different. Dorsally true ribs are vertebrosternal ribs. Dorsally false ribs are vertebrochondral ribs. Dorsally floating ribs will be attached to thoracic vertebra. Understood? It means each rib has two binding sites. Each rib has two binding sites or two articulating sites. Articulating sites nothing but binding sites. Each rib has two binding sites or two articulating sites on dorsal side. Understood? Each rib has two binding sites or two articulating sites on dorsal side. That is why ribs are commonly called bicephalic ribs. Bicephalic ribs. Each rib has two binding sites or two articulating sites on their dorsal side. That's why ribs are commonly called bicephalic ribs. Assertion: human ribs are bicephalic. Assertion: human ribs are bicephalic. Reason: because in human beings each rib has two binding sites or two articulating sites on its dorsal side, hence the name bicephalic. Here assertion, reason both are correct, and reason correctly explains assertion. Reason correctly explains assertion. Why do we call human ribs as bicephalic? Because in human beings each rib has two binding sites or each rib has two articulating sites on its dorsal side, hence the name bicephalic ribs. And sternum is flat bone. At the same time, ribs are also flat bones. Sternum and ribs both are flat bones. Both are flat bones. So axial skeleton successfully completed. Amma. Now appendicular skeleton is remained. Okay. Thoracic vertebra, ribs and sternum constitute rib cage. Or rib cage is formed by the union of thoracic vertebra, ribs and sternum. Okay na? Each rib has two binding sites on dorsal side or ventral side? Dorsal side. Hence the name bicephalic ribs. Next. Appendicular skeleton. My dear students, total number of bones in appendicular skeleton 126. Axial skeleton includes 80 bones and appendicular skeleton includes 126 bones. Here 126 bones of appendicular skeleton. 126 bones of appendicular skeleton are arranged in 4 categories. 126 bones of appendicular skeleton are arranged in 4 categories. Namely, number 1, bones of forelimb. Bones of forelimbs. Second one, bones of hind limbs. Bones of forelimbs, and second one, bones of hind limbs. And third one, pectoral girdle. Here, pectoral girdle gives support to forelimbs. Pectoral girdle gives support to forelimbs. And last one, pelvic girdle. Here, pelvic girdle gives support to hind limbs. Got it? 126 bones of appendicular skeleton are arranged in 4 categories. Namely, number 1, bones of forelimbs. Next, bones of hind limbs. Third one, pectoral girdle, and fourth one, pelvic girdle. So total number of bones in forelimbs are 60. Total number of bones of hind limbs are 60. 60 plus 60, 120. And total number of bones in pectoral girdle, 4, 124. Total number of bones in pelvic girdle, 2, 124 plus 2, 126. Okay na? Discuss individually. First one, bones of forelimbs. Dear students, forelimbs nothing but hands, hind limbs nothing but legs. My dear students, each forelimb includes 30 bones. Each forelimb includes 30 bones. Here 30, here 30. 30 plus 30, 60. Each forelimb includes 30 bones. So 30 plus 30 is equal to 60 bones. Understood? Each forelimb includes 30 bones. Those 30 bones are arranged in 6 categories. 30 bones are arranged in 6 categories. Namely, number 1, humerus. Second one, radius. Third one, ulna. Fourth one, carpals. Fifth one, metacarpals. Sixth one, phalanges. Understood? Each forelimb includes 30 bones. In left forelimb, 30 bones are present. Same time in right forelimb, 30 bones are present. 30 plus 30, 60 bones. Understood? So each forelimb includes 30 bones. Those 30 bones are arranged in 6 categories. Number 1, humerus. Second one, radius. Third one, ulna. Fourth one, carpals. Fifth one, metacarpals. And sixth one, phalanges. Sixth one, phalanges. My dear students, number of humerus bones in each forelimb, 1. Number of humerus bones in each forelimb, 1. Humerus is the bone of upper arm. Humerus is the bone of upper arm. In each forelimb, 1 radius, and in each forelimb, 1 ulna bones are present. In each forelimb, 1 radius and 1 ulna bones are present. Here, radius and ulna, both are the bones of forearm. Number of humerus bones in each forelimb, 1. Humerus is the bone of upper arm. And each forelimb includes 1 radius bone and 1 ulna bone. Radius and ulna, both are the bones of forearm. Coming to carpals. Number of carpals, 8. Number of carpals, 8. So basically, carpals are wrist bones. Carpals are wrist bones. Total number of carpals in each forelimb are 8. So carpals are the bones of wrist region. Simply we can say carpals are the wrist bones. Next. Number of metacarpals in each forelimb, 5. Number of metacarpals in each forelimb, 5. So metacarpals are palm bones. Or metacarpals are the bones of palm region. Metacarpals are the bones of palm region. Next, phalanges. Number of phalanges are 14. In each forelimb. In each forelimb, 14 phalanges are present. Here, phalanges are the bones of fingers. Phalanges are the bones of fingers. Simply we can say finger digits. Finger digits. Here, thumb includes 2 phalanges. Thumb includes 2 phalanges and rest of the fingers include 3 phalanges each. Exclusively thumb includes 2 phalanges. Thumb includes 2 phalanges and rest of the fingers include 3 phalanges each. Understood? This is about bones of forelimb. Once recapitulate what we have discussed, my dear students. Forelimbs nothing but hands, hind limbs nothing but legs. Each forelimb includes 30 bones. Each forelimb includes 30 bones. Total number of bones in both the forelimbs, 30 plus 30, 60. Understood? So 30 bones of each forelimb, 30 bones of each forelimb are arranged in 6 categories, namely number 1 humerus, radius, ulna, carpals, metacarpals and phalanges. Each forelimb includes 1 humerus. Humerus is the bone of upper arm. Each forelimb includes 1 radius and 1 ulna. Radius and ulna both are the bones of forearm. Each forelimb includes 8 carpals. So carpals are wrist bones. And each forelimb includes 5 metacarpals. Metacarpals are palm bones. And each forelimb includes 14 phalanges. Phalanges are the bones of fingers, or simply we can say finger digits. Exclusively thumb includes 2 phalanges and rest of the fingers include 3 phalanges each. Okay. Right. So bones of forelimbs successfully completed, and next one bones of hind limbs. Dear students, forelimbs nothing but hands, hind limbs nothing but legs. Just like forelimbs, here also each hind limb, includes 30 bones, or each leg includes 30 bones. Total number of bones in both the hind limbs 30 plus 30 60. Got it? Each hind limb includes 30 bones. So 30 plus 30 60 bones, and 30 bones of each hind limb. 30 bones of each hind limb are arranged in 7 categories. 30 bones of each hind limb are arranged in 7 categories, namely number 1, femur bone. Second one, tibia. Third one, fibula. First one, femur. Second one, tibia. Third one, fibula. And fourth one, tarsals. Fifth one, metatarsals. Metatarsals. And sixth one, phalanges. And seventh one, patella. Understood? 30 bones of each hind limb are arranged in 7 categories, namely number 1, femur, next tibia, third one, fibula, fourth one, tarsals, fifth one, metatarsals, sixth one, phalanges, and seventh one is a patella. Discuss individually. First one, femur. Number of femur bones 1. Number of femur bones 1. Femur is thigh bone. Femur is a thigh bone. My dear students, femur is the largest bone in our body. Discussed yesterday, stapes is the smallest bone in our body. Each middle ear includes 3 ear ossicles, namely malleus, incus, stapes. Malleus are hammer bone. Incus are anvil bone. Stapes are stirrup bone. Especially stapes is the smallest bone in our body. Here femur is the bone of hind limb. Number of femur bones 1. Femur is thigh bone. Femur is the largest bone in our body. Next, each hind limb includes 1 tibia bone and 1 fibula bone. Each hind limb includes 1 tibia bone and 1 fibula bone. Tibia and fibula. Tibia and fibula both are the bones of shank region. Tibia and fibula both are the bones of shank, S-H-A-N-K, shank region. The region which is located just below the thigh. The region located below the thigh is called shank region. Number of tibia bones 1 in each hind limb, and number of fibula bones 1. Tibia and fibula both are the bones of shank region. Next, tarsals. Number of tarsals 7. My dear students, carpals are the bones of forelimb. Carpals are the bones of forelimb. Each forelimb includes 8 carpals. Each forelimb includes 8 carpals. Here, tarsals are the bones of hind limb. Each hind limb includes 7 tarsals. 8 carpals and 7 tarsals. Enumerate the difference between them. So, number of tarsals 7. Understood? Okay? Tibia and fibula both are the bones of shank region. Number of tarsals in each hind limb 7. So, tarsals are the bones of ankle region. Tarsals are the bones of ankle region. And number of metatarsals 5. Number of metatarsals 5. Metatarsals are the bones of instep region. Metatarsals are the bones of instep region. Don't confuse tibia and fibula. Both are the bones of shank region. Tarsals are the bones of ankle region. Metatarsals are the bones of instep region. And phalanges. Number of phalanges 14. Phalanges are the bones of legs, or simply we can say digits. Here also same strategy apply here. Toe includes 2 phalanges and rest of the toes include 3 phalanges each, just like 4 limbs. And patella, number of patella bones 1. In each forelimb 1 patella is present. Patella is otherwise known as kneecap, also known as a sesamoid bone. Understood? Patella is also known as a kneecap or sesamoid bone. Each hind limb includes 1 patella bone or 1 kneecap bone or 1 sesamoid bone. Dear students, patella or kneecap or sesamoid bone is cup-shaped bone. Patella or kneecap or sesamoid bone is a cup-shaped bone. Here, patella or kneecap or sesamoid bone covers knee region vertically. Understood? Patella or kneecap or sesamoid bone is a cup-shaped bone. Here patella or kneecap or sesamoid bone covers knee region vertically. This is about bones of hind limbs. Once recapitulate what we have learnt. Each hind limb includes 30 bones. 30 bones of each hind limb are arranged in 7 categories, namely number 1 femur. Number of femur bones in each hind limb 1. Femur is thigh bone. Femur is the largest bone in our body. Next, number of tibia bones 1. Number of fibula bones 1. Tibia and fibula both are the bones of shank region. And number of tarsals in each hind limb 7. Tarsals are the bones of ankle region. And each hind limb includes 5 metatarsals. Metatarsals are the bones of instep region. Number of phalanges in each hind limb 14. These are the bones of digits, leg digits. And each hind limb includes 1 patella or kneecap or sesamoid bone. Patella or kneecap or sesamoid bone is cup-shaped bone, and patella covers knee region vertically. So, we have discussed regarding bones of forelimbs and bones of hind limbs. I hope you people have understood these 2 categories. Understood? So here, if we talk about forelimbs, humerus is the bone of upper arm. Radius and ulna both are the bones of forearm. Understood? Number of carpals in each forelimb 8. Carpals are wrist bones. Number of metacarpals 5 are the bones of palm region. Phalanges 14, finger digits. Understood. Thumb includes 2 phalanges and rest of the fingers include 3 phalanges each. Next, third category, pectoral girdle. Dear students, pectoral girdle. Pectoral girdle gives mechanical support to 4 limbs. 4 limbs can survive successfully in the presence of pectoral girdle, or simply we can say pectoral girdle provides mechanical support to 4 limbs. Understood? So pectoral girdle includes 2 equal halves. Pectoral girdle includes 2 equal halves. Each half of the pectoral girdle includes 2 bones, namely number 1 clavicle, second one scapula. There also second half includes 2 bones, namely number 1 clavicle and second one scapula. So based on this we can conclude like total number of clavicle bones in pectoral girdle 2 and total number of scapula bones in pectoral girdle 2. Okay. So Srinivas sir is waiting. It takes more time to justify pectoral girdle, to be continued. Tomorrow I will justify regarding pectoral girdle in detail. Thank you for your kind cooperation. Thank you. Thanks a lot.
Good morning, students. Yesterday the concept of discussion was cell cycle, cell division. If you observe the end of the yesterday's class, we are under the discussion related to this meiosis. The concept of meiosis 1 and meiosis 2 are there. If you come to the preliminary concept, what we said, cell division, it may be of mitosis or it may be of meiosis. Mitosis is a equational division that includes number of chromosomes will be same in the parent cell and also the progeny cells. Whereas in case of this meiosis, number of chromosomes will be reduced to half. So I told you during the gametogenesis of the organisms and in the germ cells, the meiosis going to happen. Meiosis 1 and meiosis 2 are there. How come? There are two sequential cycles of nuclear division and cell division, and there is only one cycle of DNA replication. So, that's why we are dividing first karyokinesis and first cytokinesis into meiosis 1, second karyokinesis, second cytokinesis into meiosis 2. The gap between meiosis 1 and 2 is going to be the interkinesis. Now, the meiosis 1 is considered as a true meiosis. Why? Because the number of chromosomes will be reduced to half during the meiosis 1. Meiosis 2 is same like mitosis. Now, in this meiosis 1, yesterday itself we have completed the first phase, longest phase, that is the prophase 1. In the prophase 1, based on dash, it is divided into 5 steps. If you remember, it is a behavior of chromosomes. Based on that, we are dividing them into 5 different types, 5 different stages actually. The first stage is going to be the leptotin. So, in this leptotin, chromosomal condensation is started. How can you compare this? The prophase 1 is a phase in which condensation will be started, and there are many other details are there. So, the prophase, earlier prophase we can consider it as a leptotin. After the prophase, the next phase, in the prophase, the second phase is going to be the zygotin. In this zygotin, what is happening? Pairing of homologous chromosomes. In this perspective of homologous chromosomes, all of us has to understand, every organism contains 2 sets of chromosomes. One is a paternal set, another one is a maternal set. One paternal and one maternal chromosome which looks similar, which are having similar structure and arrangement of genes, we can call them as homologous chromosomes. So, during this zygotin phase, there is a pairing of homologous chromosomes going to happen. That leads to formation of a structure, we call it as a bivalent. Why? Because it contains 2 chromosomes, and it is also called as a tetrad because it is a combination of 4 chromatids. So, bivalents and tetrads, this is the point yesterday I did not mention, bivalents and tetrads are formed in the zygotin but not clearly visible. They are clearly visible by the starting of the next stage, that is the packetin. So, the third phase here is going to be the packetin. So, in this packetin is the longest phase in the prophase 1. In this packetin, what is happening? There is a structure called recombination nodule. So, what is the significance of this structure? That is a place where crossing over occurs. Crossing over occurs between 2 non-sister chromatids of homologous chromosomes. I am repeating, crossing over occurs at a site called as recombination nodule, and it is occurs between dash chromatids, non-sister chromatids, and dash chromosomes. Those are homologous chromosomes. That is the logic. And after the crossing over, that leads to a new combination. I mean by in the crossing over, exchange of genetic material between 2 homologous chromosomes happens. So that a new combination of chromosome is formed, that is called as recombination. And the enzyme which is mediating this entire process, we can call it as a recombinase. So, crossing over and recombinase. Here one point you have to connect it with the principles of inheritance. If the distance between genes is more, crossing over is also more. If the distance is less, crossing over is also less, which is inversely proportional to linkage. So, what is a linkage? Suppose in a chromosome, there are 2 genes which are closer. In between them, strength of linkage is more and strength of crossing over is less. Whereas the genes which are present in a far distance, crossing over will be more, linkage will be less. So, distance is directly proportional to crossing over or recombination. Linkage is inversely proportional to crossing over. Linkage is inversely proportional to crossing over, and it is also inversely proportional to distance. Less distance, more linkage. More distance, less linkage. Just for connection I told this, packetin. After that, next phase is going to be the diplotin. Now, during this diplotin phase, what is happening? The synaptonymal complex which is attaching the 2 homologous chromosomes, that will be dissoluted. So that the paired homologous chromosomes started getting separated except at the site of crossing over. So, this leads to formation of a X-shaped structure called as chiasmata. So, chiasmata formation occurs during the diplotin because there is a dissolution of synaptonymal complex. And this diplotin related already one neat question came. What is that? In oocytes of some vertebrates, female reproductive sets, oocytes of some vertebrates, this diplotin will last for months or years. In that case, this is longer than the packaging. Next one is going to be diakinesis. See, diakinesis is a late prophase, simply to understand. Yesterday we are under the discussion at the end of this diakinesis, what is the scenario? In the diakinesis, late prophase, this is early prophase, this is going to be the late prophase. In this diakinesis, the chromosome condensation almost completed and there is exchange of genetic material also happened. The recombined chromosomes are attached at the tip and the nuclear envelope is almost disappeared and chromosomes are ready to enter into the cytoplasm. At the same time, the centrioles which are formed in cytoplasm, they started moving to opposite poles during the leptotene. By the end of the prophase, I mean by diakinesis, the centrioles have reached the opposite poles. After reaching the opposite poles, they are forming the asteroids. So what is the function of the asteroids? Asteroids helps in attaching the centrioles towards the plasma membrane. And there are long thread-like structures, those are called as spindle fibers. Remember, these spindle fibers are made up of microtubules and the microtubules are made up of a protein called tubulin protein. So now these two asteroids along with the spindle fibers, two sets of asteroids and spindle fibers, we can consider it as apparatus. In mitosis we call it as a mitotic apparatus. Here it is going to be called as meiotic apparatus. Sometimes it also be considered as a spindle apparatus. Now there is again disappearance of nucleolus, nuclear envelope, ER and the Golgi. Why ER and Golgi are disappearing? Because the chromosome movement requires the space inside that. So this ER, which is an extensive compartment which should be disappeared for the easy movement of these chromosomes. Now, so this is diakinesis end of the prophase 1 and there is a statement diakinesis is a transition to metaphase 1. I told you the karyokinesis is a progressive process, there is no clear cut lines, differences are not there, stages are not there. For our understanding, for our convenience, we are dividing into different types. So that what we can say, ending of one phase is starting of the another phase. So that diakinesis, which is the end of the prophase, can be considered as a starting of the next phase called as a metaphase. So the metaphase which we are going to discuss is going to be called as metaphase 1. So metaphase 1. In this metaphase 1, what is the scenario? These circular structured cell inside that chromosomes already released into the cytoplasm. Why they are released? Because complete disintegration of nuclear envelope and these spindle fibers now will come and attach the kinetochores of homologous chromosomes. Now here one chromosome is there, let us say like this. Here one kinetochore is there, to that spindle fiber is attached from one pole. Its homologous chromosome, here also it is attached. Now the point here is, same point if we have to say in mitosis. What we said in the mitotic metaphase, spindle fibers from the opposite poles attach to kinetochores of sister chromatids. Now what we are saying, spindle fibers of opposite poles attached to kinetochores of homologous chromosomes. There makes the difference, carefully how to understand. In the metaphase of mitosis, spindle fibers from the opposite poles attached to kinetochores of sister chromatids. Here spindle fibers are attached to kinetochores of homologous chromosomes. So, and they are aligned at the equatorial plate. We can call it as a double metaphase plate because pair of chromosomes are there. Shall I consider it as a bivalent? Yes, it is a pair. Shall I consider it as a tetrad? Yes, it is a combination of 4 chromatids. And number of bivalence equals to number of chromatids. Remember it, we are going to do the numericals related to that. Then metaphase agmale, next phase is going to be the anaphase. So what happened in the metaphase? Nuclear envelope is completely disintegrated, chromosomes are released into the cytoplasm, spindle fibers are attached to kinetochores of homologous chromosomes and these chromosomes aligned at the equatorial plate, that is going to be called as double metaphase plate. Now, the metaphase slowly undergo transition into the anaphase 1. So, what is going to happen in the anaphase 1? It is most favorite question for the examiner. So, carefully how to understand, for every question paper sector, anaphase 1 and anaphase 2 are the hot spots where they like to give the questions. In this, what is going to happen? The spindle fibers will pull the chromosomes to opposite poles, so that there is a separation of the homologous chromosomes, whereas in the mitotic anaphase, two sister chromatids are there, they are going to separate by the splitting of the centromere. So, centromere split and separation of sister chromatids happening in the anaphase of mitosis. But here anaphase 1 of the meiosis, there is no splitting of centromere, but there is a separation of the homologous chromosomes. While this homologous chromosome is moving towards opposite pole, the force is acting on the centromere, so that centromere is going to be the leading edge, whose backside arms are trailing behind. Same is the case opposite pole chromosome also. Arms are trailing behind and they are moving to the opposite poles. After that, so what has happened in the anaphase? Very carefully you have to understand. The homologous chromosomes are separated, and because of shortening of the spindle fibers, the separated homologous chromosomes started moving towards opposite poles. And I told you, during the anaphase of mitosis, chromosome number will be increased. But here there is no increase in the chromosomal number, there is a decrease in the number of chromosomes. That process is started in the anaphase 1. Because this is a divided situation. Now it will be separated into n plus n. To each pole, one set of chromosomes are moving. So basically what you have to understand here, why I have taken two chromosomes? It is a representation of one chromosome for one set, another chromosome for another set. It is not possible to draw 46 chromosomes on the board, no? So that's why we are saying it as like this. This is one set, this is another set. Now, one set of chromosomes are moving to one pole, another set of chromosomes are moving to the opposite pole. So that decrease in the number of chromosomes was happening during which phase? Anaphase 1 of meiosis. Meiosis 1. Next. Last phase in this discussion is going to be the telophase. So in the telophase, what is the scenario? Telophase 1. Chromosomes undergo decondensation. Here, complete decondensation is not going to happen. In the telophase of mitosis, complete decondensation, chromosome structure loses its identity, completely became the chromatin. But textbook statement, what it says, very carefully how to underline that statement. Chromosomes undergo some dispersion, means some amount of the decondensation going to happen for sure. But it cannot become the complete structure of chromatin. Why? Because logically if you think, after the meiosis 1, immediately the cell is entering into meiosis 2. That's why what is the scenario here? The chromosomes undergo some dispersion. If you want to once observe the textbook line, chromosomes undergo some dispersion but do not reach the extremely extended state of interphase. In the interphase, what is the scenario? The chromosome structure is not there, chromatin is there. Complete chromatin is there. Like that, chromatin not going to form here, because the cell immediately has to evolve into the meiosis 2. That's why there is some dispersion going to happen, but complete dispersion, complete decondensation not going to happen. So how can we draw this? They are undergoing decondensation for sure, but not complete decondensation. It is an incomplete process. So that is the telophase 1. Next, after that the cell now entering into the cytokinesis phase. Karyokinesis was completed, now it is entering into cytokinesis. How come cytokinesis? Same method what we have discussed earlier. In animal cells, cell furrow method, cell furrow is formed at the periphery, it gradually deepens, dividing the cell into two, that is the cell furrow method. Cell plate method in case of the plants, Golgi apparatus forms some vesicles in the middle, these vesicles form a plate, That plate is called as a cell plate. The cell plate gradually extends towards the periphery, dividing the cell into two. And I told you important thing, cell plate is a precursor of the cell wall and it is going to represent the middle lamella. That is the logic. Now, there are two particular cells are going to form after cytokinesis. Two particular cells are formed. These two cells formed at the end of the meiosis 1 are the haploid cells. This contains single set of chromosome, one set. As I told you, one chromosome represents one set here. This is another set of chromosomes, another chromosome is there. So, each is having the single centromere, what do you say, centrioles are there. So, these cells are called as dyad of cells. This is called as dyad of cells. This dyad of cells are called as two haploid cells. Two haploid cells are formed at the end of the meiosis 1. At the end of the meiosis 1, two haploid cells are formed. So, where the number of chromosomes are decreased, that is decreasing process is happening during the anaphase 1. So, that is the thing. After this cytokinesis, the cell is entering into interkinesis. I told you interkinesis is a short break between meiosis 1 and meiosis 2. So, this interkinesis is very short lived and in this no DNA replication going to happen. Because I told you earlier itself, 2 karyokinesis and 2 cytokinesis, there is only single cycle of DNA replication. And this interkinesis, at this who are going to duplicate centrioles. Centrioles will be duplicated. One set of centriole is there here. That will become 2 sets again. That is the logic. And whatever proteins and RNA and other nucleotides, whatever required, or protein forming structures are there, all those will be doubled during the interkinesis. After interkinesis, cell is entering into meiosis 2. Cell will enter into the next phase, that phase is going to be called as meiosis 2. So, meiosis 2 is the same like mitosis, we can consider it as an equational process. Because the number of cells a cell before entering into meiosis containing is haploid. One haploid cell entering into the meiosis 2, one cell will become 2 cells at the end of the meiosis 2. If the 2 cells are entering, which are the products of the meiosis 1, 2 cells entering into meiosis 2, they will form 4 cells. Carefully we have to understand what diploid cell after entering into meiosis 1, 2 haploid cells are formed. 2 haploid cells after entering into the meiosis 2, 4 haploid cells are formed. So, products of meiosis 1 will be dyad of cells which are haploid. Products of meiosis 2 is going to be the tetrad of cell which are of diploid. So, let we observe the stages one by one. I will go in this direction. This is the prophase 2. Prophase 2. So, there is a statement in the textbook very beautifully below to this prophase 2. Prophase 2 is started immediately after cytokinesis. Statement is there. Prophase is started immediately after cytokinesis. Meaning what? What the meaning of this? So, the interkinesis is very short lived, that it is very negligible. That is why the textbook statement, this is started before, after immediately this, because it is very short lived. That does not mean that this is not there, it is there but it is short lived. That is the logic. Now, in the prophase 2, what is going to happen? Whatever decondensation, some decondensation happened here, again it undergo condensation. For our understanding, I am taking one cell, again it undergo condensation. And one more thing I forgot to mention, during the telophase, there is a reappearance of nuclear envelope, Golgi, endoplasmic reticulum and everything. Everything are reappeared in the telophase. Whatever reappeared there, again they will disappear here. Nucleolus, nuclear envelope, ER and the Golgi again reappear. Disappear. Reappear at this phase, here they are going to disappear. And the centrioles which are duplicated, they has moved into the opposite poles, and they are going to form the asteroids and also spindle fibers. Here the spindle fibers are there to separate the sister chromatids. Question may arise like this, the spindle fibers in the meiosis 1 will be formed to separate dash, homologous chromosomes. Spindle fibers in the meiosis 2 will be formed to separate the sister chromatids. So this is in the prophase 2, condensation happened, spindle fibers are formed, we can call it as a meiotic apparatus. Next phase is going to be the metaphase 2. In this metaphase 2, the spindle fibers which are already formed during this prophase, they will attach to the kinetochores of dash. Guess what? Here what we said, spindle fibers from the opposite poles will be attached to the kinetochores of homologous chromosomes. Here only one set of chromosome is there, these are not the pairs. So here the spindle fibers from the opposite poles are getting attached to the kinetochores of sister chromatids. To the kinetochores of sister chromatids. So that in the next phase what is going to happen? During the anaphase 2. What is going to happen? These sister chromatids are going to get separated by the splitting of primary constriction, we can call it as a centromere. And the separated chromatids, after separation those chromatids are not chromatids, those are called as daughter chromosomes. And they will move to the opposite poles. Force is acting on the centromere, that is a leading edge, and the arms are trailing behind. That is the logic. So what is happening in the anaphase 2? The splitting of centromere is happening. The chromosomes are moving to the opposite poles because of the shortening of the spindle fibers at the poles. So that the two sister chromatids are separated and moving to the opposite poles. Here, suppose the question will be like this. There are two chromosomes in the meiosis 1. How many chromosomes will be there in the anaphase 2? Again 2 chromosomes, because one set of chromosome will be divided here one set, here one set again. Next phase is going to be the telophase, T2. In this telophase, the chromosomes by the end of the anaphase, they have reached the opposite poles already. And they will undergo decondensation. What is meant by decondensation here? Chromosome structure completely becomes the structure of a chromatin. So because of this decondensation procedure, completely. So chromosome structure will become the structure of a chromatin, and there is a reappearance of nuclear envelope, Golgi apparatus, ER and nucleolus. Again the two nucleus are formed. The cell now entering into the cytokinesis, where cell furrow method, centripetal in animals, centrifugal in case of the plants. So from this one cell, two daughter cells are formed. These two daughter cells are containing the single set of chromosomes. Actually it is chromatin. As for the comparison purpose, I am drawing it as like this. So this is the scenario of the entire procedure. From one, as I have taken one cell, two are formed. If I take the two cells, 4 cells will be formed. 4 cells will be formed by the end of the cytokinesis 2. I mean by end of the meiosis 2, 4 haploid cells will be formed. So this is the entire scenario of the meiosis 1 and meiosis 2. Meiosis 1 is same like mitosis, where sister chromatids are separated, chromosome number will be same. There one chromosome is there, here also each cell contains one chromosome. Whereas meiosis 1 is a reductional division, 2 sets of chromosomes at the end of the meiosis 1 produce only one set. These 4 cells formed at the end of the meiosis 2 are called as tetrads. So this is the entire scenario of this meiosis 1 and meiosis 2. Then a small question, what is happening comparatively in anaphase 1 and anaphase 2? In anaphase 1 there is no splitting of centromere, just homologous chromosomes are separated. In anaphase 2 there is a splitting of centromere, sister chromatids are separated. Sister chromatids not separated in the anaphase 1, they will separated in the anaphase 2. That is the logic. So after saying this, let me enter into the significance of the meiosis. So meiosis significance. First, it helps in the formation of gametes. Formation of gametes with reduced number of chromosomes. I told you meiosis is happening during the gametogenesis time, and it leads to formation of the 4 haploid cells. The cells which are formed here is the gametes, either both in male and also female. Next, after that. Second, it is going to reduce chromosome number. Reduce chromosome number. Therefore, it helps in maintenance of chromosome number. Maintenance of the chromosome number across the generations. So, across the generations. Means what ma here? Same point I told you in case of the mitosis. In the mitosis, chromosome number will be maintained within the organism. In my body, one cell is dead, another cell will be formed with the same chromosome number. The division there happening is the mitosis. Whereas the meiosis division is happening during the gametogenesis, so that number of chromosomes will be maintained from the parents to the progeny. Suppose parent is having 46 chromosomes, another parent is having 46 chromosomes. After meiotic division, 23 chromosomes are formed. Here 23 chromosomes are formed. After fertilization, 46 chromosomes are restored. So there is a statement in the textbook, in sexually reproducing organisms, haploid phase is formed by meiosis. Haploid phase is formed by meiosis, and the diploid phase is restored by fertilization. So meiosis, as it is decreasing the chromosome number, it helps to maintain the chromosome number from one generation to another generation. So I am repeating, meiosis maintains the chromosome number from parental generation to progeny generation because it is reducing the chromosome number. Whereas mitosis maintains the chromosome number within the organism. That is the logic. That is the difference here. Next. After that, because of this meiosis, there are variations are arising. Variations arises because of meiosis. Because in the meiosis there is a crossing over and recombination. New combinations are formed. Because of this process, the variations are arised. These variations are important for the evolution. And there is a normal stock question, what do you say, continuously this question we can observe in different kinds of materials. What are the reasons for the variations? Reasons for the variations, first thing crossing over and recombination, and second one is going to be the mutations. Mutations also leads to the variation. That is the logic here. So these are the significant features of the meiosis. Next, after saying this, a flow chart we have to draw here for understanding the different kinds of numericals. Let me draw that. Onion cell, I am taking onion root cell. This is a reference from the textbook, onion root cell. In this, 2n is equals to 16 chromosomes are there. I am considering this, 2n is equals to 16 chromosomes are there. Suppose this cell is entering into the cell cycle G1 phase, and the amount of DNA will be 2C. Amount of DNA is 2C, or let we take it in the picograms form. For competitive purpose, it will be familiar to you. 10 pg DNA is there. So at the G1 phase, onion root tip cell having 2n is equals to 16 chromosomes and 10 picograms of the DNA. Now this cell, after the S phase, the cell is entering into G2 phase. In this G2 phase, the cell is having 2n is equals to 16 chromosomes. Remember, chromosome number not going to reduce during S phase, but chromosome number will be same, amount of DNA will be doubled. 20 picograms of DNA is formed. How do we understand this, Generally during this interphase, chromosome structure is there, chromosome structure is not there, chromatin is there. For our comparison and understanding, I am drawing it as like this, Here 2 sets of chromosomes are there, each chromosome contains single chromatin. Because of this S phase, amount of DNA doubled, but chromosome number will be same, so that chromatid number is increased. 2 sets of chromosomes with 2 chromatids are there. Now, this is entering into the divisional phase, that is going to be after meiosis 1. After meiosis 1, how many cells are formed? 2 cells, 2 haploid or 2 diploid cells are formed. 2 haploid cells will be formed. Why? Because meiosis 1 is the reductional division or true meiosis. True meiosis. Now one set will enter into one cell, another set will enter into another cell, so that the structure will be like this, and the number of chromosomes there 2n, it will become n is equals to 8, here also n is equals to 8, and amount of DNA also decreases, 10 picograms and 10 picograms. How to understand this, ma'am? Here 2 sets of chromosomes are carrying 20 picograms of the DNA. Now each set going to carry half of the DNA of it, 10 picograms and 10 picograms, and number of chromosomes will be reduced during which phase, ma? Anaphase. Anaphase 1 actually in the meiosis. Now this is entering into the meiosis 2. After undergoing meiosis 2, ma, each cell going to produce another 2 cells, so that ultimately 4 cells are formed. These 4 cells are going to be the gametes. Either it may be a microspores or megaspores. Now here also n is equals to 8 and amount of DNA will be reduced to half, 5 pg of the DNA. How come? Because in the meiosis 2, sister chromatids are separated. This chromatid into one cell, this chromatid into another cell, so that half of the amount of DNA going to happen. So these two are divided like this. So understand here, ma, here one chromatid containing chromosome 10 picograms are there. Now it will be separate, doubled. While it is getting doubled, ma, it will become 20 picograms. Number double, no? Here also by decreasing the chromatid number, amount of DNA also decreases. That is the logic here. N is equals to 8 and the number of amount of DNA will be 5 picograms. Here also n is equals to 8, amount of DNA will be 5 pg. Same, n equals to 8 and it is going to be 5 pg. N equals to 8 and it is going to be 5 picograms of DNA, because the number of chromatids will be reduced to half. You can take a screenshot out of it, ma. Different kinds of numericals about the amount of DNA and haploid or diploid situation, number of chromatids, you can calculate it with that. So that is the logic. After saying this entire structure, ma, let we practice some numericals. Related to this particular concept. And there are certain formulas, ma, where we have to focus. Number of mitotic divisions to calculate, it is going to be n minus 1 formula, whereas number of meiotic divisions, it is going to be n by 4, and number of generations, it is going to be 2 power n. Let me apply these formulas and observe different kinds of structures. First, to produce 256 cells, how many mitoses are required? It is going to be 256 minus 1 equals to 255. Number of generations required means, carefully understand, suppose this is one cell, it undergoes division and produces 2 cells. This is called first generation. These 2 cells undergoing mitosis produces 4 cells. This is called as second generation. And to produce 8 cells, the third generation going to happen. Logic. Now, for example, to produce 4 cells, how many mitoses happened? This is mitosis number 1, this is mitosis number 2, this is mitosis number 3. 1, 2, 3. 3 mitoses produced the 4 cells. Means to produce 4 cells, 3 mitoses are happened. So that 2 power n is going to be the formula. To produce 4 cells, how many generations? This is first, this is second generation, 2 power 2. That is the logic. If you go on increasing the number of generations increases. To produce 256 cells, 2 power 7 generations are there. 7 generations are required. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 into 64. 1, 2, 3, 4, 5, 6. Next, if you double it, it will come as 256 cells. Whereas, to produce 400 gametes, how many meiosis are required? The formula is n power 4, 400 by 4, it is going to be 100. 100 meiosis are required. Suppose the question is like this, if to produce 100 seeds, how many meiosis are required? So the combination here, the seed is a combination of pollen grain plus egg. Pollen grain plus egg. So to produce 100 pollen grains, 100 by 4 equals to 25 meiosis are required. Whereas to produce 100 eggs, one meiotic division produces 4 megaspores. Among the 4 megaspores, 3 will be non-functional. We have to remember that while calculating this. So among the 4, 3 will be degenerates, only 1 is functional. So for one meiotic division I mean by among the 4, only 1 is functional. So that to produce 100 eggs, 100 meiosis are required. So ultimately to produce 100 seeds, 100 pollen grains and 100 egg cells are required. To produce 100 pollen grains, 25 meiosis. To produce 100 egg cells, 100 meiotic divisions are required. Ultimately to produce 100 seeds, 125 meiotic divisions are required. So that is the logic here. And this is general things related to these formulas. And now let we observe the question related to these particular things. There are some general questions. What is the ratio between chromosomes? Ratio between chromosomes is to bivalents is to tetrads is to chromatids. So what is the relationship among these structures? Suppose, let me take it as like this. One bivalent is there. One bivalent means 2 chromosomes. One chromosome means 2 chromatids. 2 chromosomes means 4 chromatids. And one bivalent means 1 tetrad. So the ratio will be 2:1:1:4. How can we understand this? If 2 chromosomes are there, combinedly forming one bivalent. One bivalent is a combination of 2 chromosomes. Each chromosome contains 2 chromatids, means total 4 chromatids. It is a tetrad. One bivalent equals to 1 tetrad, and 1 tetrad containing 4 chromatids. This is the scenario when we are calculating these entire structures. And after saying this, if a human cell is there, 46 chromosomes are there. 46 chromosomes are there. How many bivalents are possible for this? 23. How many tetrads are there? 23. And how many chromatids are there? We can calculate it off based on this particular formula. So then after that, some other numericals, let we observe them. Cell cycle. So number of chromosomes in anaphase 2 of a human cell. This is the question. So human cell, we know there are 46 chromosomes are there. These 46 chromosomes during anaphase 2, we have to find the number. How to calculate this? 46 chromosomes are there during the meiosis 1. They will be separated into 23 and 23. And you have to remember, at the end of the meiosis 2, each chromosome contains 2 chromatids. Therefore, here each 23 chromosomes are there, each is having 2 chromatids. Now, these chromatids during the anaphase 2, they asked, during the anaphase 2, this will be separated to one side, this will be separated to another side. So that 23 will become 23 plus 23, separate. So that again anaphase 2 contains 46 chromosomes itself. 46 chromosomes itself. Again I am saying human cell contains 46 chromosomes. At the end of the meiosis 1, 23 plus 23 are going to happen. Anaphase 2 is related to meiosis 2. This 23 chromosomes containing cell is entering into meiosis 2. At the anaphase 2, these chromatids will be separated to one side, this is separated to one side. So that one side 23, one side 23. I told you after separation, the chromatids are not going to be called as a chromatids anymore, they are called as a chromosomes. So answer will be 46, like that we have to assume it. Then, if the DNA content of a cell, DNA content of a cell is 2C and they are saying it is after M phase. 2C amount of DNA is there after M phase. Then found the DNA at G1 and after S phase and G2 phase. G2 phase we have to find. Very simple question. After the M phase 2C is there. Same 2C will enter into G1 because after M phase immediately the gap phase is G1. And after entering into S phase 2C will become 4C, same amount will be there in the G2 phase. That is the logic. So amount of DNA first double, after that it will be remains same. Next, number of chromosomes related another question. Suppose a human, how many chromosomes shall be present in a diploid cell? So diploid cell, how many chromosomes are there? They are saying if its egg having 10 chromosomes, 10 chromosomes. Diploid cells during at anaphase we have to find this. Again same logic. During the anaphase how many cells are there in a diploid cell if its egg is having 10 chromosomes. So egg, all of us know it is a gamete, all gametes are haploid structures because they are the products of the meiosis. So that the number of chromosomes in a diploid cell is 20. 20 chromosomes are there. Those 20 chromosomes enter into anaphase. If they mention anaphase 1 or anaphase 2, we can connect it with the meiosis. If they didn't mention it is either 1 or 2, what is the clue there? It is related to mitosis. In the mitotic anaphase, how many chromosomes are there? That is the question. So 20 chromosomes are there, each are having 2 chromatids. At the anaphase, suppose this is the chromosome, this will be separated, this will be separated. So that above and below, total 20 is there, means above 20 and below 20. Number of chromosomes will be 40. 40 here. So answer is going to be 40. That is the thing. Next. What is the amount of DNA product of meiosis 2? The question they are asking, in the product of meiosis 2, have dash amount of DNA. And the clue what they are giving, meiocyte. I have said this word, meiocyte means the cell which are entering into the meiosis. If the meiocyte have 30 PG means what? Picograms of DNA. Meiocyte have 30 picograms of DNA in G1 phase. So G1 phase they are given 30 picograms of DNA is there. And they are asking what is the amount of DNA in the product of meiosis 2. Same logic here. So they have given here G1 phase, they are given 30 picograms. And they are asking to find it at the product of meiosis 1. How much will be there? So in the G1 30 is there, means G2 it will be 60. If it is 60 in the G2, how much will be there at the product of meiosis 1? It is going to be reduced to half, that is 30. At the product of meiosis 2, again there is a reduction, it is going to be 15 picograms. So answer is 50. The logic you have to observe, from the G1 to product of meiosis 2, 50% of DNA is transferred. If it is 30, it is going to be 15. I am repeating, if the amount, whatever amount of DNA present in the G1, only 50% of DNA will be transferred to the product of meiosis 1. Same from the G2 to the product of meiosis 1, how much will be transferred? It is 1/4, 25%. So from where to where, you have to get the clarity. There comes the concept here. Next. So this is related to this part of numericals. There we have completed the chapter cell, cycle and cell division. Let me enter into the next thing, that is cell, the unit of life. Cell, the unit of life. Another biggest chapter. The time we are having is only tomorrow, and today 10 minutes we have. Let me cover as much as possible. See, cell, the unit of life chapter, starting what they said. Cell is the basic unit of life. Fundamental unit of life or structural and functional feature of life is going to be the cell. Without a cell, you cannot call that particular thing as an organism. So anything less than a complete structure of cell, less than complete structure of cell, it cannot show the independent existence. So this is the basic first line where you will get the doubt in the first page. Less than complete structure of a cell means you can consider the viruses. Viruses don't have cell wall, cell membrane, cytoplasm, cell organelles and everything. They have only two things. One is a coat which is made up of protein, and inside that genetic material, either it may be a RNA or it may be the DNA. Remember, no virus contains both. Either it contains DNA or it contains the RNA. That is the logic. So anything less than complete structure of a cell cannot show independent existence. It cannot live on its own. How? Suppose viruses are inert crystalline structures. They are outside the body, they are not living. Once they attack the body, they start acting as a living organisms. Why outside the body they are not able to live? Because they are not having a complete structure of cell. So if it is a complete structure of cell, what do you understand by complete structure? Cell wall, cell membrane, cytoplasm and the cell organelles. At least cell wall is not there like in the animal cells, remaining structure should be there. So if it is a complete structure of a cell, it can show independent existence and it can show the essential features of the life, first thing. Second thing, for the first time after the discovery of the cell, there is a development of the microscope and it leads to the electron microscope. They have started searching what is there inside the cell. In this particular journey, they have first proposed the cell theory. Cell theory. What this cell theory says? This cell theory was proposed by two scientists, Sleeden and Schwann. Sleeden and Schwann, one botanist fellow and one zoologist fellow has proposed this. As per this cell theory, what it says, all organisms are composed of cells and their products. All living organisms are composed of cells and products of cells. They have said this. Sleeden and the Schwann combinedly proposed this. But they failed to explain how new cells are formed. It is very important turning point here. Sleeden and Schwann proposed the cell theory, but they are unable to say how new cells are formed. To complete this cell theory, there is another scientist called Rudolf Virchow. Rudolf Virchow is the scientist said omnis cellula e cellula. Cells arises from pre-existing cells. Means whatever cells are there, they will undergo division. So new cells are arise from pre-existing cells. Whatever existing cells are there, they are undergo division and produce as the new cells. That is going to be the structure here. So cell theory proposed by Sleeden and Schwann. They said cells are all living organisms are made up of cells and their products, and new cells are arised from pre-existing cells. Who had given the final shape to the cell theory? That is Mr. Rudolf Virchow. After that, the discussion will be leads to the first prokaryotic cells. After that, we will go to the eukaryotic cell and we can go for their differences. There are some introductory points are there once you go through with them. Prokaryotic cell. What are the examples of this prokaryotic cell? All the organisms belongs to first kingdom in the Whittaker classification, that is kingdom Monera. So what they are having? Bacteria, cyanobacteria, we can consider it as a blue-green algae, mycoplasma organisms, even the PPLO, pleuropneumonia-like organisms. All these are representatives of the prokaryotic cells. After that, majority of them are having the structures like cell wall, cytoplasm, cell organelles, everything was there. Majorly, they are not having the membrane bound organelles. That's the first difference you have to remember. Prokaryotic cells do not have membrane bound organelles, and the question is a debatable thing, nucleus is present or not there. Yes, nucleus is absolutely present in this, but nuclear membrane is absent. There is no well defined nucleus is present in this particular situation. That is the thing. Next, in this prokaryotic cell, first if you discuss about the cell envelope means the covering of the cell. There are three layered protection is there. Outermost layer is going to be the glycocalyx. Now this glycocalyx is of two types based on their thickness. It may be of, we can call it as a capsule, or it may be of slime layer. So what makes the difference? In some bacteria it is a thick and tough. If it is thick and tough, it is going to be called as a capsule. If it is like a loose sheath, it will be called as a slime layer. Below to the glycocalyx, the next layer is going to be the cell wall. Now the cell wall is a hard rigid structure. It is made up of different kinds of structures. In case of the prokaryotes, it is not made up of cellulose. It is different kinds of polysaccharides are there. Now this cell wall provides the protection first thing. Second thing, provides the shape for the cell, and it acts as a barrier for unwanted macromolecules, and it is protecting the cell from any attack from predators. So this cell wall is the reason behind the shape of the cell. Next, based on the thickness of the cell wall, these are divided into two types. One is a gram positive bacteria and gram negative bacteria. So gram positive and gram negative bacteria. What is the difference here? It is about the staining procedure. So Christian Gram is a scientist, have done the staining procedure. When he done the staining procedure, some bacteria is holding the stain after the washing. Some bacteria are losing the stain. The bacteria which hold the stain after the treatment of alcohol, those are called as gram positive bacteria. The bacteria which loses the stain after washing with this alcohol, it is going to be called as gram negative bacteria. Why one is able to hold, why another is not able to hold? Because the thickness of cell wall matters. The gram positive bacteria is having the thick cell wall. Thick cell wall is there. Whereas gram negative bacteria, when comparatively here, the cell wall is thin. That's why it is losing the staining process. So this is gram positive and gram negative bacteria developed by staining process developed by Christian Gram. Next, below structure is going to be the plasma membrane. So plasma membrane is the innermost layer. This plasma membrane function is of different ways it is going to function. And the main point what you have to understand here, it is a layer which is going to interact with the outside world. There comes the doubt for many students. So who is there outside? Glycocalyx cell wall. After that, cell wall is cell membrane or plasma membrane is there here. See, among these three, who is interacting with the outside world? That is going to be the plasma membrane. Why? Because it is a living structure. Whereas glycocalyx and cell wall are not the living structures. It is not going to interact. There is no interaction at all. It is like a gate and a watchman. Gate is a rigid structure which is a dead layer. It is not going to interact. Whereas at the gate, watchman is there. Watchman is not outside the gate, he is inside the gate. Still, if anyone coming, who are going to come, who are going to leave, he is going to interact with them. So plasma membrane is a living structure. That's why the cell, what going to enter, what is going to leave the cell, those are all controlled by plasma membrane. That's why we can say it is a living structure interacting with the outside world. So these structures, glycocalyx, cell wall and the plasma membrane, even though each is having a different function, together they function as a single protective unit. Single protective unit then function, means all these three are involved in the, what can you say, protection of the cell. Below to that, the next thing is present, that is going to be the cytoplasm. Now this cytoplasm related, there are many points are there. Simply main point I am touching here. Cytoplasm is a main arena for cellular activities. Arena means platform. Why it is called as main arena for cellular activities? Because there is the reason for it in this cytoplasm there are many chemical reactions occurring, metabolic reactions occurring to keep the cell in a living state. So the assertion is like this the cytoplasm is a main arena for cellular activities. Reason is going to be many chemical reactions or metabolic reactions happening in the cytoplasm to keep the cell in a living state. That is the logic. Inside the cytoplasm, which kind of organelles are there? Non-membrane bound structures are present in this. There are many kinds of structures this will be continued in the tomorrow's class. At the surface there are some structures what we have to discuss now. First one is the flagella. Second one is going to be the pili. Third one is going to be enough for this. So this flagella is a long structure, tail-like structure. It is having three parts: basal body, hook and the filament. Basal body, hook and the filament. Longest part of the flagella is going to be the filament. This flagella helps in the movement, swimming of the bacteria which is present in a streams. Whereas a pili is a structure useful for sexual reproduction. Textbook what they said, pili is a long tubular structure. How can we understand this? The bacteria during the time of sexual reproduction, primitive mode of DNA transfer it is going to happen. Between one bacteria to another bacteria, the connection during the sexual reproduction will be established by sex pilus. We call it as a pili. Pili is a tubular structure, helps in transferring of DNA between two cells. So it is elongated tubular structure. And the next structure is going to be the fimbriae. What is this fimbriae? Fimbriae are the structure. What the textbook said, these are bristle-like structures like this. Bristle-like structures means brush-like structures. These fimbriae help for the attachment. Fimbriae is helpful for the attachment of the structure. So fimbriae is for attachment, pili is for sexual reproduction, flagella is for movement. All these three are not involved in the movement. Remember it. So these are external structures inside the bacteria. Tomorrow we go into the bacteria and observe what are the structures are present. As of now, it is the conclusion. Once you revise the cell cycle cell division concept, later on we will discuss this tomorrow. Thank you. And the syllabus for this weekend examination, biomolecules, cell cycle cell division and the cell the unit of life. 3 you have to revise. Thank you.
Good afternoon all of you students. So today topic kinetic theory of gases. Kinetic theory of gases. Now listen. Can you discuss some important points, Amma? Now listen carefully. Now the first one is ideal gas equation. Ideal gas equation. First one is PV is equal to, sometimes we can write as MRT. PV is equal to MRT. M is nothing but a mass of the gas, where R is nothing but a specific gas constant. This one is mass of the gas, specific gas constant. T is the temperature. PV is equal to MRT. PV is equal to nRT. PV is equal to nRT. Now this is known as ideal gas equation. But PV is equal to nRT. N means number of the moles of the gas. Number of the moles. R is nothing but universal gas constant. T is the temperature. So pressure, volume, number of the moles, and this one universal gas constant and temperature. PV is equal to nKT. PV is equal to nKT, where n is nothing but the number of gas molecules. Kb is nothing but Boltzmann constant. N Kb into T. So PV is equal to MRT, PV is equal to nRT, PV is equal to nKBT. All are the important points, different problems or different expressions are there, important one. Now we can by this equation, PV, volume is nothing but mass by density. Volume is nothing but mass by density. Number of moles, moles is nothing but mass by molecular weight into RT. So MO cancel. P by rho is equal to RT by M. This is the another important formula. Rho, density of the gas. Capital M, molecular weight of the gas. Here number of moles mass by molecular weight. Mass by molecular weight. So M is nothing but molecular weight, R into T. P by rho is equal to RT by M. That is the another important point, Amma. So all of the important points, Amma, is the given on the previous years, some models. Now next point. Now next point, Amma. Dalton's law of partial pressure. Dalton's law of partial pressure. Dalton's law of partial pressure. Now in a vessel, so there are the number of the gases are there, non-mixable gases, that are non-mixable. Now this is the one gas, this is the another gas, another gas, another gas, like P1, pressure P1, pressure P2, P3, P4, P5, number of the gases are there. Now according to Dalton's law, the total pressure exerted by the gas in a vessel is sum of the individual pressure of the gases, like P1 plus P2 plus P3 and so on. For example, all the gases occupy the same volume and same temperature. What happens? According to the ideal gas equation, PV is equal to nRT. That's where what is the pressure, Amma? nRT by V. N1 plus N2 plus N3 that's where what is the total pressure exerted by the gas in a vessel? P is equal to N1 plus N2 plus N3 and so on RT by V. T is the temperature of the each portion of the gas is the same. V, each portion of volume of the gas is the same, where N1, N2, N3 are the number of the moles of the different gases. This is the Dalton's law of partial pressure of the gas. Now the important formula, previous NEET question is the given. Now another point. What is the idea? Next, what is the Boyle's law? Boyle's law. Boyle's law is nothing but the pressure is inversely proportional to volume. Pressure is inversely proportional to volume at a constant temperature. What is the Charles law? At a constant pressure, volume is directly proportional to temperature. Volume is directly proportional to temperature. So they having some important problems are there by these two. Okay, simple basic points. Now another important point. The total pressure exerted by an ideal gas in a closed vessel is. Now very important point. Pressure exerted by an ideal gas. Pressure exerted by an ideal gas in a vessel is. The pressure exerted by an ideal gas in a vessel is. That pressure is equal to. That is one of the important formula. Now listen carefully. 1/3 rho V square RMS. 1/3 rho V square RMS. 1/3 density, mass by volume. Mass is nothing but N into M. Where M is the mass of the each gas molecule. How many number of the molecules? N molecules. The total multiplying we get the total mass of the gas into V square RMS. Pressure is equal to 1/3 rho density, mass by volume into V square RMS. That is the another important formula. This is the total pressure of an ideal gas in a closed vessel. So this is the another important formula. Now listen carefully. Now another important point. What is the expression of kinetic energy? Half mv square. Kinetic energy is equal to half mv square. Right. Another important formula, previous question. Relation between pressure and kinetic energy. Relation between pressure and kinetic energy. This is the pressure expression. This is the kinetic energy. What is the relation? Now kinetic energy by pressure is equal to. What is the formula of kinetic energy? Half mv square RMS. M means the total mass of the gas. Take them capital M. Next, what is the pressure? 1/3 rho V square RMS. Now V square value cancel like reverse. 3/2. Mass is nothing but volume into density. Density cancel we get V. So kinetic energy is indicated by E. That value 3/2 PV. So what is the relation between the kinetic energy and the pressure? That kinetic energy is equal to 3/2 PV. Very important formula. 3/2 PV. Right. Already we know that from the ideal gas equation PV is equal to NKT. That is also written as 3/2. PV is nothing but nRT, or 3/2 is equal to NKT. The total kinetic energy is equal to 3/2 nRT or 3/2 NKT. Capital N is the number of the molecules, Boltzmann constant into temperature. So these all are the different expressions for the solving of the problems. Okay, important formulas. 1, 2, like this one, and a kinetic energy. Important formulas. Next, here one new word is there. What is that? V square RMS. Like that is known as root mean square speed of the gas molecules. VRMS. Root mean square speed of the gas molecules is equal to, what is the formula? 3RT by M. Actually, the original formula is nothing but root. What is this value? 3P by rho. Actual formula 3P by rho, or 3RT by M, or 3KT by M. Any one we get the same answer. So the mainly we use in that numerical sum like this one is the important one. What is the expression of RMS speed? Root 3 RT by M, where R is nothing but universal gas constant. T is the temperature. M is the molecular weight. M is the molecular weight. Okay, main formula. Right. Now another one is most probable speed. Most probable speed, like that formula 2 RT by M. 2 RT by M, another formula. Next, average speed. Average speed root 8p by pi m, 8p by rho, or 8 RT by pi m. 8 RT by pi m. This is nothing but average speed. Most probable speed, RMS speed. Actually, this value 0.82 VRMS. This value 0.92 VRMS. What is the relation between them? VRMS greater than V average greater than V most probable speed. One time is the given this one is the previous case set question but important formulas What is the RMS speed root 3 RT by M. What is the most probable speed root 2 RT by M. What is the average speed root 8 RT by pi M. Okay, which one is the more RMS? Next average, next most probable. This is the important formula for a different speed of the gas molecules in a vessel. Now another point. Mean free path. Mean free path. Mean free path. What is the meaning of mean? Mean means average. Free path, like distance. The average distance travelled by the gas molecule between two successive collisions is known as mean free path. The average distance travelled by the gas molecule between two successive collisions. Two successive collisions in a vessel is nothing but mean free path. What is the formula of that lambda? 1 by root 2 pi d square n. Previous NEET question. Direct asking the formula. Direct one time is asking the formula. One time is asking lambda ki and d ki relation. So this type of the questions is given. Where n is number of molecules per unit volume. Where n is nothing but a number of molecules per unit volume. And d diameter of gas molecules. Where d is nothing but a diameter of the gas molecule, not radius, diameter of the gas molecule. Where n is nothing but number of molecules per unit volume, like capital N by V. Capital N is nothing but a number of the molecules, V is nothing but volume. Number of molecules per unit volume. That is another important formula. Right. Now another important formula Now listen carefully. The total energy, the total kinetic energy of the gas in a closed vessel is the total kinetic energy of gas or internal energy of the gas is, what is the formula? U is equal to F by 2 nRT. U is equal to F by 2 nRT. Here one new word, where F is nothing but degree of freedom. Degree of freedom. Where F is nothing but degree of freedom. Therefore, U is equal to F by 2 nRT. Now another important formula. CV F by 2 RO. CP F by 2 plus 1 into RO. Next, gamma is equal to 1 plus 2 by FO. This is the another important formulas. This one is the given on the previous year 2 times. This one is the given amma, or 1 or 2 times ra previous K set question amma. K set question ra is the given other competition exam ra number of times. So U is equal to F by 2 nRT, where F is nothing but a degree of freedom. N is number of moles, R is the gas constant, T is the temperature. What is the value of CV? F by 2 R. What is the value of CP? F by 2 plus 1 into R, where gamma is nothing but 1 plus 2 by F. So, what is the meaning of F? Degree of freedom. What is the meaning of F? Degree of freedom. So, that point is the very important. Degree of freedom is the important one. What is the meaning of degree of freedom? The degree of freedom is nothing but a number of ways. Degree of freedom is nothing but a number of the ways in which the energy can be distributed. In a vessel, gas R is moving along X, Y and Z axis. So how many ways are there? 3 ways. That number of the ways is known as degree of freedom. So degree of freedom is nothing but a number of the ways in which the energy can be distributed. Like another point. N1 moles of the gas whose temperature is T1. N2 number of the moles of the another gas whose temperature is T2. Now they are mixed. What is the temperature of the mixer? So they are mixed. Then what is the temperature of the mixer? N1 T1 plus N2 T2 by N1 plus N2. N1 moles of the gas at a temperature T1, N2 moles of the gas at a temperature T2, they are mixed. What is the common temperature or temperature of the mixer? N1 T1 plus N2 T2 by N1 plus N2. That is another important formula. Okay, next. Now listen. In a degree of freedom, first gas, what is that? Monoatomic gas. Monoatomic gas. What are the examples of the monoatomic gas? Helium, neon, argon, krypton, xenon, radon, all are nothing but examples of monoatomic gas. So, how many degrees of freedom? 3. How many degrees of freedom? 3. Therefore, what is the value of Cv? F by 2 Arga. What is the value of Cv? F by 2 Arga? Like 3 by 2 R. 3 by 2 R. What is the value of Cp? 3 by 2 R plus 1 ga. 3 F by 2 plus 1 into capital R ga, like 5 by 2 into R. What is the value of gamma? Cp by Cv, like 5 by 3. Like 5 by 3. So simple ga, that is about the monoatomic gas. Another one is diatomic gas. Diatomic gas H2, N2, O2 and so on. So how many degrees of freedom? 5. That's why what is the value of Cv? 5 by 2 R, Cp 7 by 2 R, gamma 7 by 5. Important table, we can copy them on notebook. Next one is triatomic gas. Triatomic gas like CO2, H2S and H2O and so on. What are the degrees of freedom? 6. That's why what is the value of Cv? 6 by 2 R, like 3 R. What is the value of Cp? Cv plus R, 4 R. What is the value of gamma? 4 by 3. Gamma value like 4 by 3. Now another one. This is the diatomic gas. This is nothing but a non-linear. Triatomic gas, this is the non-linear. For example, same one, triatomic gas. Triatomic gas, like linear. Like linear, same examples clearly is given. They are the linear or non-linear. In case of the anyone is not given, take them non-linear. Particularly they are given the linear. That's why what are the degrees of freedom? 5A. Like similar to diatomic gas, 5A. So that's why Cv value 5 by 2 R, Cp value 7 by 2 R, gamma value 7 by 5. Very important point. In case of the triatomic gas, it is the clearly given linear. In case of the linear, how many degrees of the freedom? 5. What is the value of gamma? 7 by 5. In case of the triatomic gas, non-linear, how many degrees of freedom? 6. What is the value of gamma? 4 by 3. That is another important point. Next. Diatomic gas. In case of the diatomic gas, whose molecules are not rigid. Molecules are not rigid. Molecules are not rigid. That's why the molecules are not rigid means they having the additional vibrational mode. They having the additionally vibrational modes. In case of the vibrational modes, what happens? What is the value of what is the value of F? Like degrees of freedom like 7. The degrees of freedom like 7. So what is the value of CV? 7 by 2 R. What is the value of CP? So 9 by 2 R. What is the value of gamma? CP by CV? 9 by 7. This is also the previous NEET question. In case of the diatomic gas, whose molecules are not rigid, the degrees of the freedom are 7. CP value 7 by 2 R. CP value 9 by 2 R. Gamma value 9 by 7. That is another important point. Next. Polyatomic gas. Polyatomic gas. Polyatomic gas means they having the more than 3 molecules. More than 3 molecules. In more than 3 molecules, now listen, how many vibrational modes are like X vibrational modes? How many vibrational modes? X vibrational modes. That's why CV is equal to 3 plus XR and CP is equal to 4 plus X into R. What is the value of gamma? 4 plus X by 3 plus X. This is the 2025 question. 2024 lo 720 by 720 members and more number of the students are came ga. That's why again re-exam is there gamma like this one. Where X is nothing but vibrational modes. That's why what is the value of gamma? 4 plus X by 3 plus X. So these all are the important formulas, very very important formulas. Compulsory one question is the given possibility. So these points are the very very important one. Now this question is the given on the previous one. Diatomic gas whose molecules are not rigid. That's why how many degrees of the freedom? 7. That's why what is the value of gamma? 9 by 7. Next. Polyatomic gas. How many vibrational modes? X vibrational modes. What is the value of gamma? 4 plus X by 3 plus X. Okay, next one. Triatomic gas non-linear. How many degrees of the freedom? 6. For linear, how many degrees of the freedom? 5. So this is the important table. That's why we can copy them. Each and every point we can read the textbook. Each and every point is there. Right. Now we can discuss some models. Now in a 2024 question, so the temperature and volume graph is given. There are the 3 different lines. There are the 3 different lines whose pressures are P1, P2 and P3. That's why what is the relation between them? What is the correct relation? What is the correct relation between P1, P2, P3? First, what is the slope? slope is nothing but tan theta. Tan theta is nothing but opposite side by adjacent side. So according to the ideal gas equation, what is the value of T by V? P by NRA ga. We can cross multiply them. PV is equal to NRT ga. Here amma, NR value is constant amma, like proportional to P nega. Like more slope having more pressure. More slope having the more pressure. Which one having the more slope amma? Like this one nega. Because of amma, each and every line is passing through the origin amma. But which one having the more slope? Like this one, more angle. That one having the more pressure. So P1 greater than P2 greater than P3. P1 greater than P2 greater than P3. That is the 2024 question. Now next one. 2023 question. Wait amma, 1 minute amma, just. Okay. In 2023 question amma, a container having the volume 200 centimeter cube contains the 0.0 moles of oxygen, N value 0.2 moles of hydrogen gas and 0.3 moles of argon gas. The pressure of the system at a temperature 200 Kelvin, but R value already we know that 8.3. So what is the total pressure exerted by the gas? What is the total pressure exerted by the gas? In a vessel, how much volume? 200 meter cube of the volume. 2 moles of them, 0.2 moles of the hydrogen. 0.3 moles of the argon at a temperature and R value is given. What is the total pressure? Like partial, Dalton's law of partial pressure. N1 plus N2 RT by V. N1 plus N2 0.2 into plus 0.3 0.5 R value 8.3 temperature 200 Kelvin by volume 200 into centimeter cube converted into meter cube like 10 power minus 6. Like 200 cancel. This value take them on numerator 10 power 6. So 8.3 into 0.5 approximately 4.2. Sorry, approximately 4.1. So 4.01 something value like this one is the pressure Newton per meter square or Pascal. So that is the answer amma. The formula is like Dalton's law of partial pressure. That is the previous question. Now another question. Now 2023 question. Again 2023 question. The temperature of the gas is minus 50 degrees centigrade. The temperature of the gas is minus 50 degrees centigrade. To what temperature of the gas to be heated, the RMS speed is increased by 3 times. At what temperature gas can be heated, the RMS speed is how many times? 3 times. And initial V, here 3 times. At what temperature can be increased, RMS speed is increased by 3 times. How to solve that one? Already we know that Vrms is equal to 3 RT by M. So same gas number. So that's why directly proportional to root T. First one V, second one 3V ratio root T1 actually minus 50 degrees centigrade plus 273. How much value Minus value 3, 7 minus 5, 223 by another temperature, don't know. So squaring on both sides, 1 by 9, 223 by t. Therefore, t is equal to 223 into 9. 9 3s are 27. 9 2s are 18. 18 plus 2, 20. 20. 9 2s are 18. Like kelvins. 2007 kelvins. So that is another important concept. Next, another one, the 2022 model. Now listen carefully. An ideal gas is following the rule PV square is equal to C. PV square is equal to constant. Then the initial pressure volume temperature is changes to final pressure volume temperature. The gas is changed from initial state to final state. Then which of the following them is correct, amma? I am giving the option also, amma, because of a very important concept, amma. Then V1 greater than V2. Second one, P1 greater than P2, then T1 less than T2. V2 greater than V1, then T2 greater than T1. V2 greater than V1, then T2 less than T1. These all are the options, amma. Here options is based question, that's where I give the options. Now listen, what is the gas equation, amma? PV square is equal to C. Clearly condition is given. What is the initial system of the gas? P1, V1, T1. Final value like this. How to solve this one? Listen carefully. PV square is equal to constant like C. Pressure is inversely proportional to V square and more pressure having the less volume. First one is, what is that given, amma? P1 greater than P2. Inversely proportionality and P1 greater than P2 means volume more pressure less volume and V1 V2 relation inversely like this one. So P1 greater than P2 but V1 less than V2 but given V1 greater than. That's why this is the wrong. So that point is over. Now second one is the given about the pressure and the temperature. Pressure and about the temperature. And you can eliminating the volume pressure. What is the ideal gas equation, amma? PV is equal to nRT. What is the volume? nRT by P nega. nRT by P is nothing but volume whole square. That value constant. So here nr value constant, leave it. What is the value? T square. Here denominator lo P square 1P value cancel is equal to constant. What is the relation between pressure is directly proportional to temperature. What is the second one is given, P1 greater than P2 directly proportional to T1 greater than T2 ne. But T1 less than T2 and like wrong. Total is nothing but option verification method, important model. Now another one, volume temperature. But given pressure and volume and here we can eliminating the pressure from the ideal gas equation. What is the pressure expression? nRT by V nega. Pressure is nothing but nRT by V nega. What is the remaining value? V square is equal to constant. Here 1 V value constant, TV is equal to constant. nR value is also constant like temperature is inversely proportional to volume. In these two, which one is given, V2 greater than V1. Mari over volume is nothing but less temperature. What is the relation between T1 and T2? Inversely like this one. So what is the value? T2 less than T1. This is the correct one. This is the Wrong. So this question is the given the on 2022. Like here option verification method. So important model amma. So here volume temperature relation is asking and pressure is eliminating. How to eliminating the pressure by the ideal gas equation. Here temperature and pressure is asking volume eliminating. How to eliminating the volume by the ideal gas equation. Simple models just 1 or 2 times you can practice them have the idea. Now next one. In a 2022 question, 3 vessels having the equal capacity, 3 gases having the equal capacity means the equal volume and the same temperature and pressure, all are same all are same. The final vessel, the first vessel contains the helium. First one helium, that is nothing but a monoatomic gas. Second one is nothing but fluorine. Next, third one is nothing but sulfur hexafluoride. Sulfur hexafluoride. Sulfur hexafluoride. That's why what is the correct statement? Is asking root mean square velocity is asking. Root mean square velocity is asking the relation. Root mean square velocity all gases same. Like helium ki more or fluorine ki more. This type of the options is given What is the formula of VRMS 3RT by M. Now listen, 3RT by M. 3 value, R value constant. All gases having the same temperature. This one is also same and like VRMS is inversely proportional to root M. So less molecular weight having the more speed. Less molecular weight having the more RMS speed. Here helium, fluorine, sulfur dioxide. Which one having the less molecular weight? Helium. Helium ki molecular weight 4. But fluorine ki more by 4 above. Sulfur hexafluoride ki 4 above. And the least one is nothing but helium and more speed. Is the one of the option is there RMS speed of the helium, the gas is more compared to the all the gases. That's why that is the correct one. So for all the gases RMS speed for helium is more compared to other gases. This is the option. Compared to other gases, RMS speed is more because of less molecular weight having the more speed, more RMS speed. That is the given previous. Now another one. So one question is that given match the following like one side that match the following simple is asking the formulas we can check them easy model. Now another question 2020 model. 2020 model. Now listen carefully. A cylinder contains the hydrogen gas of the pressure 249 kilopascal at a temperature 27 degrees centigrade. That's why what is the density? But R value 8.3 SI units. R 8.3 SI. What is the density amma? Is the clearly given helium gas. Helium gas is the given. How to solve that one? Sorry amma, a cylinder contains hydrogen gas. Sorry hydrogen gas. Right amma, what is the ideal gas equation PV is equal to nRT. Volume is nothing but mass by density. This one mass by molecular weight, number of the moles mass by molecular weight, R into T. Mass value cancel. Is asking the density rho. That rho is equal to how much amma? Pm by RT. What is the pressure amma? 249 into kilo like this one. Hydrogen gas, molecular weight amma 2 grams. Grams are converted into kg. Like what is the value of R value amma? 8.3. Temperature amma 300 kelvins. So 300 kelvins amma. Now the simplify them. We get the exact 0.2 kg per meter cube. So 0.2 kg per meter cube amma, simplify them we get. That is the one of the previous question, the important model. Now next one amma. In 2020, the mean free path of an ideal gas with a diameter and a number density is expressed as. What is the expression of mean free path amma? 1 by root 2 pi d square n. What is the mean free path? 1 by root 2 pi d square n. That is the direct formula is asking in 2020. Next, another question, 2020. The average thermal energy of the monoatomic gas is. The average thermal energy of the monoatomic gas. For monoatomic gas, U is equal to F by 2 nRT. F by 2 nRT. Already we know that monoatomic gas degrees of freedom 3 ga F by 2 nRT or 3 by 2 nKT. 3 by 2 nKT. For number of the molecules are not given gara, take one and is nothing but 1 no, and 3 by 2 kT. That is for monoatomic gas, 3 by 2 kT. Same question for diatomic gas 5 by 2 kT. Because of U is equal to F by 2 nRT ga, where F is nothing but degree of freedom ga. For monoatomic gas F value 3, for diatomic gas 5. But given the monoatomic gara, that's why this is the answer. Already we know that kinetic energy is equal to 3 by 2 PV. PV is equal to nRT or nRT plus nKT. For one molecule gara 3 by 2 kT is over. So that is the another model. In 2020, in phase 2 question, the mean free path of the gas molecule is depends upon the diameter. Mean free path of the gas molecule is depends upon the diameter. Lambda is inversely proportional to d square. Actually, this one phase 2 is given this one phase 1. Already I am told that one. Whatever may be the question is the given, the same question is repeated in re-NEET. On that year, any second exam is there, same model say. Here formula is given. Here is asking the relation. Phase 1 and phase 2. So, simple models. Next, another question. In 2020, an ideal gas equation can be expressed as pressure is equal to rho RT by M. Rho RT by M, where rho and M naught are. Rho and M naught R. What are that? Same question in 2020 phase 1. This one is the given phase 2. Phase 1 amma, in the previous question I am explaining rho is equal to what is the formula? P M naught by RT gara. Ademo phase 1. This one emo phase 2. And same model not same model, exact question. What is the form? What is the expression of rho and M naught? Rho means the density of the gas, where M naught is nothing but molecular weight. Over. So any exam is there on the same year, 2 times are there, models are is repeated. So we can follow that one previous questions. Now another question. 2019. So there are the first one is the hydrogen. Other one is nothing but helium, and another one is the diatomic gas but whose molecules are not rigid. Diatomic gas but whose molecules are not rigid. Whose molecules are not rigid. There are the 3 gases are there. One is hydrogen, helium, diatomic gas but whose molecules are not rigid. So that's where they are having some additional vibrational mode is there gamma. What is the values of gamma? Is asking the gamma of these 3 values. Like this one is the diatomic gas 7/5, monoatomic gas 5/3. Diatomic gas whose molecules are not rigid means the additional vibrational mode. That's why what is the value of gamma value? 9/7. You can observe them on the table. Previous one I am explaining the table. Like this is the answer. But we can observe them 1, 2 options. These 2 are same. But the last one is the different one. So that's why these models are the important one. Now another model. In a 2019 question. This is the 2019 Orissa question amma. This is the general question. And increasing the temperature of the gas is filled in a container. Which one is increasing? Kinetic energy, the temperature of the gas. Temperature of the gas is value is increases. Temperature of the gas is increases. Then which of the following them is increases? First one is mass value increases, kinetic energy increases, pressure value decreases, intermolecular distance is decreases. Which one is the correct amma? Already we know that kinetic energy is equal to 3/2 nRT or 3/2 nKT. All are nothing but same ega. But here temperature of the gas is increases. Which one is increases amma? Kinetic energy of the gas is increases. Kinetic energy of the gas is increases. That is the simple question on 2019. Next one. In 2016. In 2016 question. What is that? At what temperature the RMS speed of the oxygen molecule becomes just escaping from the earth surface? Now the RMS already here entire the room some gas molecules are is moving. At what temperature this total gas molecules are is escaping from the earth atmosphere is asking amma. But that mass of the oxygen molecules. Mass of the oxygen molecules 2.76 into 10 power minus 26 kg. And Boltzmann constant 1.38 into 10 power minus 23 joule by Kelvin. At what temperature? At what temperature room can be heated? Here all the gas molecules are escaping from the earth atmosphere is asking that question. Already we know that Vrms is equal to 3 RT by M, where M is the molecular weight, or 3 kT by M, where M is nothing but mass of the gas molecule. Mass of the gas molecule. So which formula can be here? Like this one, nega. V RMS is equal to 3 kT by m. So is asking the temperature squaring on both sides. That's why what is the value of T? V square RMS into mass by Boltzmann constant into 3. But already we know that when the gas molecules are escaping from the surface, how much velocity is required? Is nothing but escape velocity. What is the value of escape velocity? Now this VRMS is nothing but escape velocity. Now that gas molecules having the escape velocity, they are overcoming the gravitational field. How much value? 11.2 kilometer per second. So here 11.2 into 11.2 kilometer converted into meter. Because of square is there 11 power 6. What is the mass value 2.76 into 10 power minus 26 by 3 into what is the Boltzmann constant value? That value is also given. So the total value is simplifying. We get, what is the answer? 5.016 into 10 power 4. 5.016 into 10 power 4 Kelvin. So this is the gravitational topic and KTC concept mixed problem. So this is the another model. Now another question. In 2017 question, a gas mixer consists of 2 moles of oxygen, and 4 moles of argon. 4 moles of argon at a temperature T. Both are at the same temperature. That's why what is the total internal energy of the gas? What is the total internal energy of the gas? What is the total internal energy? What is the formula of internal energy? F by 2 nRT nega. Here the two gases are mixed like U1 plus U2. What is the first one? Like O2 and like diatomic gas. For a diatomic gas, how many degrees of freedom? 5. 5 by 2. How many number of moles? 2 RT plus argon, monoatomic gas. Monoatomic gas 3 degrees of freedom. 3 by 2. N value 4 RT. We can write the separate values. 2 cancel 5 RT. 2 times 6 RT. We get 11 RT. That is the total internal energy of the gas 11 RT. Right. Now another question. In 2013 question, the amount of the heat required to rise the temperature of 1 gram of helium at NTP from T1 Kelvin to T2 Kelvin at a constant volume. At a constant volume is asking the dq at a constant volume. What is the amount of the heat required at a constant volume whose 1 gram of the helium gas at NTP from T1 Kelvin to T2 Kelvin. Right. Already we know that at a constant volume means the work done value 0 nega. Work done value 0 dq is equal to du nega. Already we know that the total internal energy is nothing but kinetic energy nega. Kinetic energy. What is the formula of that kinetic energy? F by 2 nRT nega. F by 2 nRT. Over problem. F degrees of freedom. What is this one, amma? Helium, monoatomic gas. 3 by 2. Number of moles, mass by molecular weight. How much mass, amma? 1. Molecular weight of the helium, 4. Right. R into change in temperature, amma, like T2 minus T1. So how much value? 3 by 8. Here, amma, R. Already we know that R by Na is nothing but Boltzmann constant. R by Na is nothing but Boltzmann constant. That's why what is the R value? Cross multiply them. Na and Avogadro number into Boltzmann constant into T2 minus T1 is the given the option like this model. What is the expression of what is the amount of the heat required, amma, at a constant volume? Already we know that at a constant volume, amma, work done value 0. Work done value 0 means, amma, dq is nothing but du nega. Du, the total internal energy, is also known as kinetic energy. What is the formula? F by 2 nRT. The change in heat energy kada dq kada, this value can be written as F by 2 nR dt. Only heat energy or internal energy means F by 2 nRT. Change in heat energy is nothing but change in internal energy, that is the change in kinetic energy ne F by 2 nR dt. What is the value of F for helium gas? 3 by 2. N number of moles, mass by molecular weight, R into change in temperature. But R by Na means Avogadro number, that is equal to Boltzmann constant. R value of Na into Kb into T2 minus T1. So that is the 2013 question. Now another question. In a 2016 question, the molecules of the given mass of gas have the RMS velocity 200 meter per second at a temperature of 27 degrees centigrade, having the pressure is 1.01 into 10 power 5 Pascal pressure. What is the temperature? When the temperature and the pressure of the gas are 127 degrees centigrade, whose pressure value 0.05 into 10 power 5 Pascal, then what is the speed? That is the question. Now listen carefully. Generally, the speed value is 200 meter per second at a temperature 21 pressure. Pressure temperature is given the RMS velocity. The RMS velocity is equal to 3p by rho R3 RT by m. Which formula can be used here? V directly proportional to root 2 here. V directly proportional to root p. P is the pressure, rho is the density. Which formula can be used here? Directly proportional to root p and directly proportional to root t. Two formulas low, common factors are not used on the single formula. How to solve that one? One of the important point. As the pressure of the gas is doubled, density of the gas is also doubled, then RMS speed is remain same. What is that point? As the pressure of the gas is doubled, density of the gas is also doubled, then RMS speed is same. So that's why RMS speed is independent of pressure of gas. The RMS speed is independent of pressure of the gas. Why RMS speed under root 3p by rho, where root 3p by rho means as the pressure of the gas is doubled, density of the gas is also doubled. That's why RMS speed is remains same. So that RMS speed is independent of the pressure, that's why this formula is no use. What is the remaining value? Vrms is equal to root 3RT by omega. And what is the relation between Vrms and temperature? Root T. So initial value 200, final value don't know. What is the initial temperature? 27 degrees centigrade, like 300 Kelvin. So 127 degrees centigrade, like 400 Kelvin. So root 4 means 2. Therefore, what is the second one? Cross multiply them. So root 400, sorry, only 400 by root 3 meter per second. So here the important point is nothing but here pressure. So as the pressure of the gas is doubled, density also doubled, overall RMS speed is remains same. Vrms is independent of the pressure. That's why only take them V directly proportional to root T. So V1 by V2 is equal to root of T1 by T2 is over. Okay, right. So these all the models on KT0 compulsory one question is the given important chapter simple small chapter one question is the possibility. Okay. And tomorrow only one last chapter is there, thermal properties of matter. In that total thermal properties of matter only we discuss the heat transfer topic. Because on last 6-7 years only given the heat transfer topic models . So on tomorrow heat transfer some models we can explain on tomorrow. Like, thank you amma. అబ్బా ఇంకొక రోజు ఉంది సార్ తినదిన సార్
Hello all. Today we are going to start with the next chapter or the last chapter in my track, which is coordination compounds. From coordination compounds, we will discuss certain important questions, various models on isomerism and on the crystal field theory and other important applications of coordination compounds. On all the concepts possible, we are going to discuss various questions. Let's start with the first one. The first question is, if manganese tetrabromide nickel tetrachloride nickel tetracyanide tetracarbonyl COF6 minus 3 Cn 6 times minus 4. -3 Cu H2O 6 times +2 -3. ಇಷ್ಟು ಕಾಂಪ್ಲೆಕ್ಸಸ್ನಲ್ಲಿ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಎಷ್ಟು ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಹೌ ಮೆನಿ of these are paramagnetic in nature? There are so many complexes given. We will analyze one after the other. Manganese tetrabromide nalli manganese in oxidation state Mn+2 4 - 2. ಇದರ ಕಾನ್ಫಿಗರೇಷನ್ 3d5. 3d5 ಅಂದ್ರೇನೆ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 5 ಇರ್ತವೆ. ಆದರೆ ಬ್ರೋಮೈಡ್ ಅನ್ನೋದು ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಅಲ್ಲ, ರಿಅರೇಂಜ್ಮೆಂಟ್ ಮಾಡಲಿಕ್ಕೆ ಬರಲ್ಲ. ದೇರ್ಫೋರ್ ಖಂಡಿತ ನಮಗೆ ಇದೇ ತರಹ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ಬಿಡ್ತವೆ, ಅವು ಏನೂ ರಿಅರೇಂಜ್ ಆಗಲ್ಲ. ಒಂದು ವೇಳೆ ಆದರೂ ಕೂಡ ಒಂದು ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದ್ದೇ ಇರುತ್ತೆ, ಬಟ್ ಇಟ್ ಡಸಂಟ್ ಅಂಡರ್ಗೋ ಆ್ಯಕ್ಚುಲಿ. ದೇರ್ಫೋರ್ ಒನ್ ಅನ್ಪೇಯ್ಡ್ ಇಟ್ ಇಸ್ ಅ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಇದು ಒಂದನೇದು. ನಿಕೆಲ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್, ಇದರಲ್ಲಿ ನಿಕೆಲಿನ ಚಾರ್ಜ್ +2, ಕಾನ್ಫಿಗರೇಷನ್ 3d8, 2 ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅದಾವೆ. ಎರಡು ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅದಾವೆ. ಕ್ಲೋರೈಡ್ ಇಸ್ ಅ ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್, ಇಟ್ ಕೆನಾಟ್ ರಿಅರೇಂಜ್. ದೇರ್ಫೋರ್ ಇದು ಕೂಡ ಪ್ಯಾರಾನೆ, ಸೆಕೆಂಡ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಹೈಬ್ರಿಡೈಸೇಷನ್ sp3 ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ದೆರ್ ಇಸ್ ನೋ ರಿಅರೇಂಜ್ಮೆಂಟ್ ಪಾಸಿಬಲ್. ನಮಗೆ ಡಿ ಆರ್ಬಿಟಲ್ಸ್ ಎಲ್ಲ ತುಂಬಿದ್ದಾವೆ, sp3 ಆಗುತ್ತೆ, ಟೆಟ್ರಾಹೈಡ್ರಲ್ ಸ್ಟ್ರಕ್ಚರ್. ಬೇಕಾದರೆ ಅವು ಕೂಡ ಬರೆದು ಬಿಡ್ತೀನಿ. ಇದು ಕೂಡ ಅಷ್ಟೇ. ನೆಕ್ಸ್ಟ್ ನಿಕೆಲ್ ಟೆಟ್ರಾಸೈನೈಡ್, ಇದು ನಮಗೆ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ನಲ್ಲಿರುವ ಕಾಂಪ್ಲೆಕ್ಸೇ. ಇದು ಕೂಡ ಅಫ್ಕೋರ್ಸ್ ಇದು ಕೂಡ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ನಲ್ಲಿದೆ. ನಿಕೆಲ್ ಟೆಟ್ರಾಸೈನೈಡ್, ನಿಕೆಲ್ +2 3d8. ಇಲ್ಲಿ ರಿಅರೇಂಜ್ಮೆಂಟ್ಗೆ ಸಾಧ್ಯತೆ ಇದೆ, ಬಿಕಾಸ್ ಇಟ್ಸ್ ಅ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್. ಫೋರ್ 2s are 8. ಒಂದು ಡಿ ಆರ್ಬಿಟಲ್ ವೇಕೆಂಟ್ ಇದೆ, ಒಂದು ಎಸ್ ಆರ್ಬಿಟಲ್, 2 ಪಿ ಆರ್ಬಿಟಲ್ಸ್, dsp2. ಹೈಬ್ರಿಡೈಸೇಷನ್ ಅಂದರೆ ಇದರಲ್ಲಿ ಪೇರಪ್ ಆಗಿದೆ, ನಮಗೆ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಬರುತ್ತೆ. ಆ್ಯಂಡ್ ದೇರ್ಫೋರ್ dsp2 ಸ್ಕ್ವೇರ್ ಪ್ಲೇನಾರ್ ಸ್ಟ್ರಕ್ಚರ್. ನಿಕೆಲ್ ಟೆಟ್ರಾಕಾರ್ಬೊನಿಲ್, ನಿಕೆಲ್ ಟೆಟ್ರಾಕಾರ್ಬೊನಿಲ್ನಲ್ಲಿ ಇದು ನೋಡಿದರೆ ನಿಕೆಲ್ಗೆ ಚಾರ್ಜ್ 0, 4s2 3d8. ಇದು ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್, ಈ ಎರಡೂ ಕೂಡ ಇದರಲ್ಲಿ ಹೋಗಿಬಿಡ್ತವೆ. 3d10 ಪೈರಪ್ ಆಗುತ್ತೆ, ಅಂದರೆ ಇದು ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಎಸ್ ಖಾಲಿ ಆಗತ್ತೆ, ಪಿ ಖಾಲಿ ಇರುತ್ತೆ. sp3 ಹೈಬ್ರಿಡೈಸೇಷನ್, ಟೆಟ್ರಾಹೈಡ್ರಲ್. ನೆಕ್ಸ್ಟ್ CO F6 -3, CO +3 ಚಾರ್ಜ್, 3d6 ಕಾನ್ಫಿಗರೇಷನ್. 4 ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತವೆ. ರಿಅರೇಂಜ್ ಆಗಲ್ಲ, ಫ್ಲೋರೈಡ್ ಇಸ್ ಅ ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್, ಇದು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಎಕ್ಸಾಂಪಲ್. ಸೊ 4 ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಡಿ ಖಾಲಿ ಇಲ್ಲ, ಸೊ sp3 d2 ಹೈಬ್ರಿಡೈಸೇಷನ್, ಔಟರ್ ಆರ್ಬಿಟಲ್, ಹೈ ಸ್ಪಿನ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಇದು ಪ್ಯಾರಾ ಅಲ್ವಾ, ಪ್ಯಾರಾದಲ್ಲಿ ನಮಗೆ ಮೂರನೇದಿದು. ಈಗ ನಾಲ್ಕನೇದು ನೋಡೋಣ, ಇಲ್ಲಿಗೆ ಬರೋಣ. FeCN6-4. FeCN6 ನಲ್ಲಿ ಚಾರ್ಜ್ Fe+2, ಕಾನ್ಫಿಗರೇಷನ್ 3d6 ಬರೆದ್ರೆ 3d6 1 2 3 4 5 6. ಈ 6 ಕೂಡ ಸೈನೈಡ್ ಇರೋದ್ರಿಂದ ರಿಅರೇಂಜ್ ಆಗ್ತವೆ. 3 pairs. So diamagnetic, no unpaired electrons. D2sp3 hybridization, 2 d orbitals ಖಾಲಿ ಅದು, octahedral shape. Next MnCN6 - 3. ಇದರಲ್ಲಿ ಮ್ಯಾಂಗನೀಸ್ಗೆ ಚಾರ್ಜ್ +3 ಅಂದರೆ 3d4. 1 2 3 4. ಒಂದು ಖಾಲಿ ಇದೆ, ಇನ್ನೊಂದು ಬೇಕು, ಪೈರಪ್ ಆಗುತ್ತೆ. ಆದರೂ ಅನ್ಪೇಯ್ಡ್ ಇದೆ ನೋಡಿ, ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 2 ಬರ್ತವೆ ಇದರಲ್ಲಿ. ಇದು ಕೂಡ ಪ್ಯಾರಾ, D2sp3 ನಾಲ್ಕನೇದು. ಇನ್ನು ಉಳಿದಿದ್ದು ವೆರಿಫೈ ಮಾಡಬೇಕು, ಮಾಡೋಣ. ಇಲ್ಲಿಗೆ 4 ಆದು. ನೆಕ್ಸ್ಟ್ TiCN6 ಚಾರ್ಜ್ +1 +3, ಕಾನ್ಫಿಗರೇಷನ್ 3d1, ಒಂದು ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್. ಅದು ಏನು ಮಾಡೋಕ್ಕೆ ಬರಲ್ಲ, ಪ್ಯಾರಾ. ನೆಕ್ಸ್ಟ್ ಅಂದರೆ ಇದು 5ನೇದು, ಕಾಪರ್. ಕಾಪರ್ +2 ಚಾರ್ಜ್ 3d9. 3d9 ಕೂಡ ಪ್ಯಾರಾನೆ, ಆಕ್ಟಾಹೈಡ್ರಲ್. CO +3. ಕೊಬಾಲ್ಟ್ ಕೇಸ್ನಲ್ಲಿ ಆಕ್ಸಲೇಟ್ ಲಿಗ್ಯಾಂಡ್ ಇಸ್ ಅ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್, ನೆನಪಿಟ್ಕೋಬೇಕಿದು. ಉಳಿದ ಕೇಸಸ್ನಲ್ಲಿ ವೀಕ್ ಫೀಲ್ಡ್ ಇದ್ದರೂ ಕೂಡ ಕೊಬಾಲ್ಟ್ ಕೇಸ್ನಲ್ಲಿ ಇದು ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಆಗಿ ವರ್ಕ್ ಆಗುತ್ತೆ. ಅಂತ ಎಕ್ಸೆಪ್ಷನ್ಸ್ ಅದಾವೆ ಕೆಲವು. ನಿಕೆಲ್ ಕೇಸ್ನಲ್ಲಿ ಅಮೋನಿಯಾ ಇಸ್ ಅ ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್, ಆ ಥರ. SFL ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಇದು. ಇವಾಗ ಈ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಇರೋದ್ರಿಂದ ಇದೇನು ಮಾಡುತ್ತೆ, ರಿಅರೇಂಜ್ ಮಾಡುತ್ತೆ 3d6 ಕಾನ್ಫಿಗರೇಷನನ್ನು. ನೋ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಡಯಾ. ನೆಕ್ಸ್ಟ್ ಇಷ್ಟು ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಆದ್ವಾ. ದೇರ್ಫೋರ್ ಇದರಲ್ಲಿ ನಮಗೆ ಅರ್ಥ ಆಗಬೇಕಾಗಿದ್ದು ಏನಂತಂದರೆ ಇಷ್ಟು ಬರ್ತವೆ ನಮಗೆ 5, ಇದೊಂದು ಪ್ಯಾರಾ 6. ಸೊ ಟೋಟಲ್ 6 ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಅದಾವೆ ಅನ್ನೋದು ತಿಳ್ಕೋಬೇಕು. 1 ಮ್ಯಾಂಗನೀಸ್ ಟೆಟ್ರಾಬ್ರೋಮೈಡ್, 2 ನಿಕೆಲ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್. ಸೈನೈಡ್ನಲ್ಲಿ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಮತ್ತು ಈವನ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿಅರೇಂಜ್ ಆಗುತ್ತೆ. ಆಮೇಲೆ ನಿಕೆಲ್ ಟೆಟ್ರಾ ಕಾರ್ಬನಿಲ್ನಲ್ಲಿ ರಿಅರೇಂಜ್ಮೆಂಟ್ ಆಗುತ್ತೆ. F6ನಲ್ಲಿ ರಿಅರೇಂಜ್ಮೆಂಟ್ ಇಲ್ಲ, ಆಗಲ್ಲ, ಸೊ ಪ್ಯಾರಾದು. FeCN6 - 4ನಲ್ಲಿ ರಿಅರೇಂಜ್ಮೆಂಟ್ ಆಗುತ್ತೆ. ಆಮೇಲೆ MnCN6 - 3 ರಿಅರೇಂಜ್ಮೆಂಟ್ಲಿಗೆ ಅವಕಾಶನೇ ಇಲ್ಲ, 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬಂದೇ ಬರ್ತವೆ. ಅದಾದ ನಂತರ ನಮಗೆ TiCN6 - 3ನಲ್ಲಿ ಟೈಟಾನಿಯಂ +3 ಅಂದರೆ ಇರೋದೇ 3d1 ಎಲೆಕ್ಟ್ರಾನ್, ಅದು ಅನ್ಪೇಯ್ಡ್ ಆಗುತ್ತೆ. ಕಾಪರ್ ಹೆಕ್ಸಾಕ್ವಾನಲ್ಲಿ 3d9 ಕಾನ್ಫಿಗರೇಷನ್, ಅದು ಆಗುತ್ತೆ. ಸೊ ಇದರಲ್ಲಿ ಆಕ್ಸಲೇಟ್ ಮಾತ್ರ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ತಗೋಬೇಕು. 3d6 ಎಲ್ಲ ರಿಅರೇಂಜ್ ಆಗ್ತವೆ, ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಆಗುತ್ತೆ. ಸೊ ಟೋಟಲ್ ಕೊಟ್ಟಿದ್ದ ಸೆಟ್ನಲ್ಲಿ 6 ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಅದಾವೆ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. an excess of silver nitrate is added. Hundred milliliter, 0.05 molar solution of tetra aqua dichlorido chromium 3 chloride. The number of moles of AgCl precipitated will be dash into 10 power minus 3. ಅದು ಫಿಲ್ ಮಾಡಬೇಕು. ನೋಡೋಣ. ಫಸ್ಟ್ ನಾವು ಆ ಕಾಂಪ್ಲೆಕ್ಸಿನ ಫಾರ್ಮುಲಾ ಬರೆಯೋಣ. ಟೆಟ್ರಾ ಆಕ್ವಾ ಡೈಕ್ಲೋರಿಡೋ ಕ್ರೋಮಿಯಂ 3 ಕ್ಲೋರೈಡ್. ಕ್ರೋಮಿಯಂ ಟೆಟ್ರಾ ಆಕ್ವಾ ಡೈಕ್ಲೋರಿಡೋ ಕ್ಲೋರೈಡ್. ಇದು ಕಾಂಪ್ಲೆಕ್ಸ್. ಇದು ಅಂದರೆ ಇದಕ್ಕೆ +3 ಅಲ್ವಾ, ಇದು 0, ಇದು -2 ಅಂದರೆ +1. ಒಂದೇ ಕ್ಲೋರಿನ್ ಬರುತ್ತೆ ಹೊರಗಡೆ. ಇದು ಫಾರ್ಮುಲಾ. ಇದರಲ್ಲಿ 1 ಮೋಲ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ತಗೊಂಡ್ರೆ ಒನ್ ಮೋಲ್ ಆಫ್ ಕ್ಲೋರೈಡ್ ಬರ್ತಾ ಇದೆ. ಅಂದರೆ 1 ಮೋಲ್ ಆಫ್ ಸಿಲ್ವರ್ ಕ್ಲೋರೈಡ್ ಬರುತ್ತೆ ಆನ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ವಿತ್ ಸಿಲ್ವರ್ ನೈಟ್ರೇಟ್. ಅಂದರೆ ಇದೆಷ್ಟೈತೆ ಅದಷ್ಟೇ ಐತೆ. ಕಾಂಪ್ಲೆಕ್ಸ್ ಎಷ್ಟು ಮೋಲ್ಸ್ ಅದು ಅಷ್ಟೇ ಮೋಲ್ಸ್. ಅದಕ್ಕೆ ಈ ಸೊಲ್ಯೂಷನಲ್ಲಿ ಫಸ್ಟ್ ಇವಾಗ ಎಷ್ಟು ಮೋಲ್ಸ್ ಅದಾವೆ ಅನ್ನೋದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ ಅದರಿಂದ ಕ್ಲೋರೈಡ್ಸ್ ಎಷ್ಟು ಅನ್ನೋದು ಮಾಡ್ಬೋದು. ಸೊ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ ಮೊಲಾರಿಟಿ ಇಂಟು ವಾಲ್ಯೂಮ್ ಕೊಟ್ಟಾಗ ಡಿವೈಡೆಡ್ ಬೈ 1000 ಹಾಕಿದರೆ ಮೋಲ್ಸ್ ಬಂದುಬಿಡ್ತಾವೆ ನಮಗೆ. ಮೊಲಾರಿಟಿ 0.05 100 ಡಿವೈಡೆಡ್ ಬೈ 1000 5 into 10 to the power minus 3 moles. ಅಂದರೆ ಇವು ಕಾಂಪ್ಲೆಕ್ಸ್ ಎಷ್ಟು ಮೋಲ್ಸ್ ಅದಾವೆ ಅಷ್ಟೇ ಕ್ಲೋರೈಡ್ಸು ಅಷ್ಟೇ ಸಿಲ್ವರ್ ಕ್ಲೋರೈಡ್ಸ್. ಅದಕ್ಕೆ ಇದು 5 into 10 power minus 3, ಅದು ಕೂಡ 5 into 10 power minus 3. ಆಯಿತು, ಆನ್ಸರ್ 5. ಈ ಥರ ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ಗೆ ಹೋಗೋಣ. ಸೊ ಫಸ್ಟ್ ನಾನು ಏನು ಮಾಡಿದ್ದೀನಿ, an excess of silver nitrate is added to 100 ml 0.05 molar solution of tetra aqua dichlorido chromium 3 chloride. The number of moles of silver chloride precipitated will be ಅಂದರು. ಅದಕ್ಕೆ ಫಸ್ಟ್ ಅದರ ಫಾರ್ಮುಲಾ ಬರೆದಿದ್ರೆ ನನಗೆ ಎಷ್ಟು ಕ್ಲೋರೈಡ್ಸ್ ಅದಾವ ಅನ್ನೋದು ಗೊತ್ತಾಗತ್ತಲ್ವಾ. ಅದಕ್ಕೆ 1 ಮೋಲ್ ಆಫ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇಸ್ 1 ಮೋಲ್ ಆಫ್ ಕ್ಲೋರೈಡ್ಸ್ ಅಂತ ಬರೆದಿದ್ದೀನಿ. ಯಾಕಂದರೆ ಇದಕ್ಕೆ ಫಾರ್ಮುಲಾ ಬರೆದಾಗ ಒಂದೇ ಕ್ಲೋರೈಡ್ ಹೊರಗಿದೆ, ಹೊರಗಿದ್ದು ಮಾತ್ರ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗುತ್ತೆ. ಸೊ 1 ಮೋಲ್ ಆಫ್ ಕ್ಲೋರೈಡ್ ಅಂದರೆ 1 ಮೋಲ್ ಆಫ್ ಸಿಲ್ವರ್ ಕ್ಲೋರೈಡ್. 1ಗೆ 1 ಬರ್ತಾ ಇದೆ. ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಈಕ್ವಲ್ಸ್ m into v by 1000. ಇಷ್ಟೇ, ಬರೋದಿನ್ನೇನಿಲ್ಲ. ಲೆಟ್ಸ್ ಗೋ ಅಹೆಡ್ ವಿತ್ ದ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್. The total number of unpaired electrons present in the D3, D4, D5, D6, D7 complexes. D3, D4 low spin. D5 high spin. D6 high spin. D7 ಲೋ ಸ್ಪಿನ್. ಕ್ಯಾಲ್ಕುಲೇಟ್, ಟೋಟಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಎಷ್ಟೆಷ್ಟು ಅದಾವ ನಾವು. ಈಗ D3 D4, ಫಸ್ಟ್ D3 ತಗೊಳ್ಳೋಣ. D3 T2G EG ಆಕ್ಟಾಹೈಡ್ರಲ್ ಇದು. ಅದರಲ್ಲಿ ಲೋ ಸ್ಪಿನ್ ಅಂದರೆ ಪೈರಪ್ ಆಗಬೇಕು. 3 ಇದ್ದಾಗ ಪೈರಪ್ ಏನಾಗಲ್ಲ, ಅಷ್ಟೇ ಇರುತ್ತೆ ಅದು. D1 D2 D3ನಲ್ಲಿ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಇದ್ರೂ ಕೂಡ ಏನು ಪೈರಪ್ ಆಗಲ್ಲ. ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್, ವೀಕ್ ಫೀಲ್ಡ್ ಎರಡು ಸೇಮ್ ನಂಬರ್ ಆಫ್ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಏನು ಚೇಂಜ್ ಬರಲ್ಲ. ಹಾಗೆ D8 D9 D10 ಕೂಡ. ಈಗ ಚೇಂಜಸ್ ಎಲ್ಲ ಬರೋದು D4 to D7. ನೆನಪಿಟ್ಕೋಬೇಕು, ಇದು ಮೂರೇ. D4 D4 ಕೂಡ ಲೋ ಸ್ಪಿನ್ನೇ, ಅಂದರೆ ಪೈರಪ್ ಕೆಳಗೇನೆ ಆಗಬೇಕು. ಮೂರನೇದು ನಾಲ್ಕು ಕಳಿಸ್ಬಾರ್ದು, ಇಲ್ಲೇ ಪೈರಪ್ ಮಾಡಬೇಕು. 2 ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. D5 D5 5 ಅದಾವೆ, ಹೈ ಸ್ಪಿನ್ ಅಂದರೆ ಪೈರಪ್ ಮಾಡಬಾರ್ದು. 5ಕ್ಕೆ 5. D6 ಹೈ ಸ್ಪಿನ್. R ಹೈ ಸ್ಪಿನ್ ಅಂದರೆ R ಇಲ್ಲೇ ಹೈ ಅಲ್ವಾ, ಸಾರಿ. ಹೈ ಅಂದರೆ 1 2 3 4 5 6 4 ಅನ್ಪೇಯ್ಡ್ ಬರ್ತವೆ. D7 ಲೋ ಸ್ಪಿನ್. One, 2, 3, 4, 5, 6, 7. 1 ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್. ಈಗ ಟೋಟಲ್ ನಂಬರ್ ಎಷ್ಟು? 3 + 2 5, 5 + 5 10, 4 + 1 5. So 10 + 5 is 15. Total number of unpaired electrons is 15. ಇದು ಕ್ವೆಶ್ಚನ್ ಇದು ಸಾಲ್ವ್ ಮಾಡೋದು. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಲೋ ಸ್ಪಿನ್ ಅಂದಾಗ ಪೈರಪ್ ಮಾಡಬೇಕು, ಹೈ ಸ್ಪಿನ್ ಅಂದಾಗ ಪೈರಪ್ ಮಾಡಬಾರ್ದು. ಆದಷ್ಟು ಪೈರಿಂಗ್ ಅಪ್ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು. ಒಂದು ವೇಳೆ ಎಲ್ಲ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲ ಆರ್ಬಿಟಲ್ಸ್ನ ತುಂಬಿಟ್ರೆ ಅವಾಗ ಮಾತ್ರ ಮಾಡಬೇಕು, ಇಲ್ಲಾಂದರೆ ಪೈರಪ್ ಮಾಡಬಾರ್ದು. ಸೊ D3 D4 ಲೋ ಸ್ಪಿನ್ ಅಂದಾಗ D3ಗೆ ಇನ್ನು ಪೈರಪ್ ಆಗ್ಲಿಕ್ಕೆ ಅವಕಾಶನೇ ಇರಲ್ಲ. D1 D2 D3 ಪೈರಪ್ ಆಗಲ್ಲ. ಎಷ್ಟಿರ್ತಾವೆ ಅಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಇದ್ರು, ವೀಕ್ ಫೀಲ್ಡ್ ಇದ್ರು, ಅದರಲ್ಲಿ ಎಷ್ಟಿರ್ತಾವೆ ಅಷ್ಟು ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತವೆ. D8 D9 D10 ತೊಗೊಂಡಿದ್ದಾಗ ಮಾತ್ರ ಈ ಮೂರರಲ್ಲಿ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನೋವು ಸೇಮ್ ಇರ್ತವೆ, ಮತ್ತು ಇದರಲ್ಲಿ ಕೂಡ ಪೈರಿಂಗ್ ಅಪ್ ಅನ್ನೋದು ಸೇಮ್ ಇರುತ್ತೆ ಅದರಲ್ಲಿ. ಸೊ ಅವಷ್ಟಕ್ಕೂ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ವೀಕ್ ಫೀಲ್ಡ್ ಅಂದಾಗ ಸೇಮ್ ಇರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಏನು, D5 ಹೈ ಸ್ಪಿನ್ ತಗೋಬೇಕು. ಸೊ D4ನಲ್ಲಿ ನಾನೇನು ಮಾಡಿದ್ದೀನಿ, D4 ಅಂದಾಗ ಲೋ ಸ್ಪಿನ್ ಅಂದ್ರಲ್ವ, ಅದಕ್ಕೆ ಪೈರಪ್ ಮಾಡಿದ್ದೀನಿ 4ನೇ ಎಲೆಕ್ಟ್ರಾನ್. ಅಷ್ಟೇ ಬಿಟ್ಟು ಎರಡೂ ಮಾಡಬಾರ್ದು. ಇದು ಕೂಡ ಪೈರಪ್ ಮಾಡಬಾರ್ದು, ತಪ್ಪು. ಹಂಡ್ಸ್ ರೂಲ್ ಫಾಲೋ ಆಗಬೇಕು. ಲೋ ಆರ್ಬಿಟಾಲ್ನಲ್ಲಿ, ಲೋವರ್ ಎನರ್ಜಿ ಆರ್ಬಿಟಾಲ್ನಲ್ಲಿ ಫಸ್ಟ್ ಈಚ್ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ರಿಂದ ತುಂಬಿ 4ನೇ ಎಲೆಕ್ಟ್ರಾನನ್ನು ಪೈರಪ್ ಮಾಡಬೇಕು. ಅದು ಹೈ ಸ್ಪಿನ್ ಆದರೂ ಲೋ ಸ್ಪಿನ್ ಆದರೂ ಕರೆಕ್ಟಾಗಿ ತುಂಬಬೇಕದು, ಅಂದರೆ ಹಂಡ್ಸ್ ರೂಲ್ ಫಾಲೋ ಆಗಬೇಕು, ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಇಲ್ಲಿ. ಈಗ ನೆಕ್ಸ್ಟ್ D6ಗೆ ಬಂದಾಗ ಮಾತ್ರ ಏನಾಗುತ್ತೆ, D6ನಲ್ಲಿ D5ನಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಹೈ ಸ್ಪಿನ್ ಅಂದ್ರಲ್ವ, ಪೈರಪ್ ಮಾಡಂಗಿಲ್ಲಲ್ವ. ಸೊ 1 2 3 ಇಲ್ಲಿ ತುಂಬಿದ ಮೇಲೆ ಒಂದು ಇನ್ನು ಉಳಿದಿದ್ದ 2 ಮೇಲಕ್ಕೆ ಹಾಕ್ಕೋಬೇಕು. D6 ಲೋ ಸ್ಪಿನ್ ಹೈ ಸ್ಪಿನ್ ಅಂದರು, D6 ಹೈ ಅಂದರೆ ಮತ್ತೆ ಪೈರಪ್ ಮಾಡಬಾರ್ದು. ಅದಕ್ಕೆ ಫಸ್ಟ್ ಏನು ಮಾಡಬೇಕು, 1 2 3 4 5 ಹಾಕಿ 6ನೇದು ಪೈರಪ್ ಮಾಡಬೇಕು. ಸೊ 4 ಬರ್ತವೆ ಅವಾಗ. D7 ಲೋ ಸ್ಪಿನ್ ಅಂದರೆ ಏನು, ಅದು ಕೂಡ ಅಷ್ಟೇ. 1 2 3 4 5 ಲೋ ಸ್ಪಿನ್ ಅಲ್ವಾ, ಪೈರಪ್ ಮಾಡಬೇಕು. ಸೊ 1 2 3 4 5 6 ಆಗುತ್ತೆ, 7 ಆಗುತ್ತೆ, ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ. ದೇರ್ಫೋರ್ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಗೆಟ್ ಹಿಯರ್. ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ ಅಬೌಟ್ ದಿ ಪೈರಿಂಗ್ ಅಪ್ ಇನ್ ಕೇಸ್ ಆಫ್ ದೀಸ್ ಕಾನ್ಫಿಗರೇಷನ್ಸ್. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. 5.33 grams of (6H2O) is a 1:3 electrolyte. Is dissolved in water and is passed through a cation exchanger. The chloride ions in the elevated solution on treatment with silver nitrate results in 8.61 grams of silver chloride. ಅಂದರೆ ಇಷ್ಟು ಕಂಪೌಂಡ್ ಏನಿದೆ ಇದು 8.61 ಗ್ರಾಮ್ಸ್ ಆಫ್ ಸಿಲ್ವರ್ ಕ್ಲೋರೈಡನ್ನು ಫಾರ್ಮ್ ಮಾಡಿದೆ. ಎಷ್ಟು ನೆನಪಿಟ್ಕೋ ಅಷ್ಟೇ ಸಾಕು, ಇನ್ನು ಉಳಿದಿದ್ದ ವಿಷಯ ಏನು ಬೇಕಾಗಿಲ್ಲ ನಮಗೆ. ನೆಕ್ಸ್ಟ್ ಒನ್, ದ ರೇಷಿಯೋ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ the ratio of moles of silver chloride complex reacted to moles of silver chloride formed is, ಇದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಈ ಕ್ವೆಶ್ಚನ್ ಮಾಡಬೇಕಂದ್ರೆ ಇದು ಎರಡು ವಿಧದಾಗಿ ಮಾಡ್ಬೋದು. ಫಸ್ಟ್ ನಾವೇನು ಮಾಡ್ಬೋದು, ಫಸ್ಟ್ ಇದನ್ನು ತಗೊಂಡು ಅದರ ಮೋಲಾರ್ ಮಾಸ್ ಹಾಕಿ ಮೋಲ್ಸ್ಗೆ ಮಾಡಿ, ಇದು ಮೋಲಾರ್ ಮಾಸ್ ಹಾಕಿ ಮೋಲ್ಸ್ ಮಾಡಿ ಎರಡನೇ ರೇಷಿಯೋ ತೊಗೊಂಡಿದ್ರೆ ಆಯಿತು, ಅಲ್ಲಿಗೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಬಟ್ ಅಷ್ಟು ಮಾಡುವ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ, ಯಾಕಂದರೆ ಅವ್ರು ಹೇಳಿದ್ದೇ 1:3 ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಂದ್ರೆ ಅಂತ. 1:3 ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಂದರೆ ಏನು, CrH2O 6 times Cl3 ಅಂತ, ಒಂದು ಕ್ಯಾಟಯಾನ್ 3 ಆನಯಾನ್ಸ್, ಇದು 1:3 ಎಲೆಕ್ಟ್ರೋಲೈಟ್. ಆವಾಗ ಕ್ವೆಶ್ಚನ್ ಏನಿಲ್ಲಿ, ರೇಷಿಯೋ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ರಿಯಾಕ್ಟೆಡ್, ಕಾಂಪ್ಲೆಕ್ಸ್ ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದು 1 ಮೋಲ್ ಅನ್ಕೋ, ಮೋಲ್ಸ್ ಆಫ್ ಸಿಲ್ವರ್ ಕ್ಲೋರೈಡ್ ಫಾರ್ಮ್ಡ್ ಎಷ್ಟು 1ರಿಂದ 3 ಬರ್ತವೆ ಅಯಾನ್ಸ್, ಅಂದರೆ 3 ಸಿಲ್ವರ್ ಕ್ಲೋರೈಡ್ಸ್ ಫಾರ್ಮ್ ಆಗ್ತವೆ. ಆವಾಗ ಇದು 1 ಅದು 3, 0.33 ಅದು ರೇಷಿಯೋ. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಅವ್ರೇನು ಹೇಳಾರು, ಎಲೆಕ್ಟ್ರೋಲೈಟ್ 1:3 ಟೈಪ್ ಅಂದ್ರೆ 1:3 ಟೈಪ್ ಅಂದರೆ ಅದರ ಫಾರ್ಮುಲಾ ಬರೆದ್ರೆ ಹಿಂಗೆ ಬರುತ್ತೆ, ಒಂದು ಕ್ಯಾಟಯಾನು 3 ಆನಯಾನ್ಸ್. ಈಗೇನು ನೆಕ್ಸ್ಟು, ಈ ಕ್ಯಾಟಯಾನ್ ಈ ಆನಯಾನ್ಸ್ ಅದಾವಲ್ವಾ ಈ 1:3 ರೇಷಿಯೋದಲ್ಲಿ, ಈಗ ಇದರಲ್ಲಿ ನಾವೇನು ಮಾಡಬೇಕಂತಂದರೆ 3 ಕ್ಲೋರೈಡ್ಸ್, ಇದು ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ದಾಗ ಹೊರಗಿದ್ದಿದ್ದು ಕ್ಲೋರೈಡ್ಸ್ ಎಲ್ಲ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗೇ ಆಗ್ತವೆ. ಆ ಥರ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆದಾಗ 3 ಕ್ಲೋರೈಡ್ಸು ಬಂದುಬಿಡ್ತವೆ, 3 ಸಿಲ್ವರ್ ಕ್ಲೋರೈಡ್ಸ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ಆಗ್ತವೆ. ಹಾಗಾಗಿ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿದ್ದೇನೆಂದರೆ ಅವ್ರು ಏನು ಕೇಳೋದು, ರೇಷಿಯೋ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ರಿಯಾಕ್ಟ್ ಆಗಿದೆ, ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಕಾಂಪ್ಲೆಕ್ಸ್ 1 ಅನ್ಕೋ, ಆವಾಗ ಮೋಲ್ಸ್ ಆಫ್ AgCl ಫಾರ್ಮ್ಡ್ 1ಕ್ಕೆ 3 ಬರ್ತವೆ, ಅಂದರೆ 1/3, 0.33 ಇಷ್ಟೇ. ಇದು ಏನು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ತಗೊಳ್ಳುವ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಇಲ್ಲ ಅಂದರೆ ನೀನೇನು ಮಾಡಬೇಕು, ರೇಷಿಯೋಗೆ ಇದರ ಮೋಲ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಇದರ ಮೋಲ್ಸ್ ಮಾಡ್ಕೋಬೇಕು. ಅದರ ಮೋಲಾರ್ ಮಾಸ್ ಮಾಡಿ, ಇದನ್ನು ಮೋಲಾರ್ ಮಾಸಿಂದ ಡಿವೈಡ್ ಮಾಡಿ, ಇದನ್ನು ಕೂಡ ಮೋಲಾರ್ ಮಾಸಿಂದ ಡಿವೈಡ್ ಮಾಡಿ, ಆವಾಗ ಎರಡಕ್ಕೂ ರೇಷಿಯೋ ತಗೋ, ಆವಾಗ ಕೂಡ ಅದೇ ಬರುತ್ತೆ ಆನ್ಸರ್. ಇದು ಕೊಟ್ಟಿಲ್ಲ ಅಂದರೆ ಹಾಗೆ ಮಾಡಬೇಕವ, ಇದು ಕೊಟ್ಟಿಲ್ಲ ಅಂದರೆ ಇದು ಮೋಲ್ಸ್ ಮಾಡಿ ಅದು ಮೋಲ್ಸ್ ಮಾಡಿ ರೇಷಿಯೋ ತಗೋಬೇಕು. ಅದು ಕೊಟ್ಟಿದ್ದಾರಲ್ವ, ಸೊ ಅದೆಲ್ಲ ಬೇಕಾಗಿಲ್ಲ, ಡೈರೆಕ್ಟ್ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಸೊ ಲೆಟ್ಸ್ ಗೋ ಅಹೆಡ್ ವಿತ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಈ ಕ್ವೆಶ್ಚನ್ ಏನಂದರೆ, X is the number of geometrical isomers exhibited. Y is, ಇದರಲ್ಲಿ GI ತಗೋಬೇಕು, geometrical isomers. ಇದರಲ್ಲಿ ಆಪ್ಟಿಕಲ್ ಐಸೋಮರ್ಸ್ ತಗೋಬೇಕು. ಇದರಲ್ಲಿ ಕೂಡ ಜಾಮೆಟ್ರಿಕಲ್ ಐಸೋಮರ್ಸ್ ತಗೋಬೇಕು. ಇವೆಲ್ಲ ಮಾಡಿ XYZ ಸಮ್ ಅಪ್ ಮಾಡಬೇಕು. ಫಸ್ಟಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ಇದು ಏನಿದು? MABCD ಟೈಪ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಇದು ಇಂಥ ಕಾಂಪ್ಲೆಕ್ಸ್ಗೆ 2 ಸಿಸ್ ಫಾರ್ಮ್ಸ್, 1 ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಬರ್ತವೆ. ಅಂದರೆ ಟೋಟಲ್ 3 ಜಾಮೆಟ್ರಿಕಲ್ ಐಸೋಮರ್ಸ್. X ವ್ಯಾಲ್ಯೂ 3. ಆಪ್ಟಿಕಲ್ ಐಸೋಮರ್ಸ್ ನೋಡಿದರೆ ಆಪ್ಟಿಕಲ್ ಐಸೋಮರ್ಸ್ ಇದರದು. ಇದು ಎಂಥ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದು? MEN ಟ್ವೈಸ್ Cl2 - 3 ಅಂದರೆ MAA ಟ್ವೈಸ್ X2 ಟೈಪ್ ಇದು. ಆವಾಗ MAA Cl ಇದು ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್. ಈಗ ಬರೀತಿರೋದು ಸಿಸ್ ಫಾರ್ಮ್. ಇದರ ಮಿರರ್ ಇಮೇಜ್. ಈ ಟೈಪ್. ಇವು ಆಪ್ಟಿಕಲ್ಲಿ ಆಕ್ಟಿವ್ 2. ಇದಲ್ಲ. ಟ್ರಾನ್ಸ್ ಐಸೋಮರ್ಸ್ ಆರ್ ನಾಟ್ ಆಪ್ಟಿಕಲ್ಲಿ ಆಕ್ಟಿವ್. ಸೊ ಇದರ ವ್ಯಾಲ್ಯೂ 2, ಇದರ ವ್ಯಾಲ್ಯೂ 3. ಲಾಸ್ಟಿಗೆ ಬರೋಣ. NH3NO3. ಇದು ಯಾವ ಥರ ಇದೆ? MA3X3 ಟೈಪ್ನಲ್ಲಿದೆ. MA3X3 ಅಂದರೆ ಇಟ್ ಎಕ್ಸಿಬಿಟ್ಸ್ ಜಾಮೆಟ್ರಿಕಲ್ ಐಸೋಮೆರಿಸಮ್ ಆಫ್ ದ ಟೈಪ್ ಫೇಶಿಯಲ್ ಆ್ಯಂಡ್ ಮೆರಿಡೋನಿಯಲ್. 2 ಫಾರ್ಮ್ಸ್ ಬರ್ತವೆ. ಅಂದರೆ ಇದರದು 2. ಸೊ 3 + 2 + 2 4. 3 + 2 + 2 7. Therefore the answer is 7. Next one. ಇಲ್ಲಿ ಇದು ಕೂಡ ಐಸೋಮರಿಸಮೇ. ಮ್ಯಾಚ್ ಮಾಡಬೇಕು. ಇವು ಮ್ಯಾಚ್ ಮಾಡಬೇಕಂದ್ರೆ ಇದು ಸ್ಕ್ವೇರ್ ಪ್ಲೆನಾರ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಸ್ಕ್ವೇರ್ ಪ್ಲೆನಾರ್ ಕಾಂಪ್ಲೆಕ್ಸ್ನಲ್ಲಿ MA2X2 ಟೈಪ್. ಅಂದರೆ ಇಟ್ ಎಕ್ಸಿಬಿಟ್ಸ್ ಜಾಮೆಟ್ರಿಕಲ್ ಐಸೋಮೆರಿಸಮ್. COEN ಥ್ರೈಸ್ it exhibits optical isomerism. CONH3 5 times NO2. NO2 is an ambidentate ligand. It exhibits linkage. CrH2O 6 times Cl3. Solvate or hydrate? This is matching. Next question. PtCl2NH3 twice. CONH3 6 times Cl3. NiCl4 minus 2 Fe A B C D. 1 2 3 4 4 octahedral, trigonal, bipyramidal, square planar, tetrahedral. ಇದರಲ್ಲಿ PtCl2NH3 twice ಇದೆ. ಇದು ಆ್ಯಕ್ಚುಲಿ ಪ್ಲಾಟಿನಮ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಈಸಿಯೆಸ್ಟ್ ವೇ ಟು ರಿಮೆಂಬರ್. ಪ್ಲಾಟಿನಮ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ವಿತ್ coordination number 4. Blindly you can say it is a square planar complex. Because platinum complexes with charge 2 ಏನಿರುತ್ತೆ coordination number 4 ನಲ್ಲಿ ಅವು ಖಂಡಿತ they undergo DsP2 hybridization. Because ಅದು weak field or strong field ಅನ್ನೋದು ಸಂಬಂಧ ಇರಲ್ಲ. It definitely undergoes rearrangement. Because in case of platinum plus 2, all of those act as strong field ligands. As a result, we get square planar complex. So, it is square planar. ಇದು octahedral ಸ್ಪಷ್ಟವಾಗಿ 6 ಇದ್ರೆ octahedral ಇನ್ನು ಬೇರೆ ಅವಕಾಶನೇ ಇಲ್ಲ. 4 ಇದೆ, ಇದು ನಿಕೆಲ್ ಟೆಟ್ರಾಕ್ಲೋರೈಡ್ ನಮಗೆ ಸಿಲೆಬಸ್ಸಲ್ಲಿ ಇದು ಟೆಟ್ರಾಹೆಡ್ರಲ್, ಹೀಗೆ ಹೇಳಿದ್ದೀನಿ ಅದು ಕೂಡ. ಟ್ರೈಗೋನಲ್ ಬೈಪಿರಮಿಡಲ್, ಇದು ಮ್ಯಾಚಿಂಗ್. ಲೆಟ್ಸ್ ಗೋ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಮತ್ತೆ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಯಾವುದು ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಅದರಲ್ಲಿ ಮತ್ತೆ ಬಂದಿದ್ವಿ ಅದಾವೆ ಕಾಂಪ್ಲೆಕ್ಸಸ್. ಸೊ ಐ ವಿಲ್ ಸ್ಕಿಪ್ ದಟ್ ಕ್ವೆಶ್ಚನ್. ಲೆಟ್ಸ್ ಗೋ ಟು ಅನದರ್. The correct order of wavelength of light absorbed by the following complexes is, wavelength in order ಬರೆಯಬೇಕು. A CONH3 6 times plus 3, COCN 6 times minus 3, Cu H2O 4 times plus 2, titanium hexa aqua. ಈ 4 ಕಾಂಪ್ಲೆಕ್ಸಸ್ ತಗೊಂಡು ನಾವು ವೇವ್ ಲೆಂತ್ ಪ್ರಕಾರ ಅರೇಂಜ್ ಮಾಡ್ಕೋಬೇಕು. ಅದರಿಗೋಸ್ಕರ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಫಸ್ಟು ಕಾಂಪ್ಲೆಕ್ಸಸ್ನ ಎನರ್ಜಿ ಪ್ರಕಾರ ಅರೇಂಜ್ ಮಾಡೋಣ. ನಮಗಿದರಲ್ಲಿ 2 ಕ್ಯಾಟಗರೀಸ್ ಅದಾವೆ, ಒಂದು 6 ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್, ಒಂದು 4 ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್. ಆಕ್ಟಾಹೆಡ್ರಲ್ ಕಾಂಪ್ಲೆಕ್ಸಸ್ನಲ್ಲಿ ಬರುವ ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಸ್ಪ್ಲಿಟ್ಟಿಂಗ್ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಟೆಟ್ರಾಹೆಡ್ರಲ್ಗಿಂತ. ಎದಕ್ಕೆಂದರೆ ಟೆಟ್ರಾಹೆಡ್ರಲ್ನಲ್ಲಿ 4 ಲಿಗ್ಯಾಂಡ್ಸ್ ಇರ್ತವೆ, ರಿಪಲ್ಷನ್ಸ್ ಕಮ್ಮಿ ಇರ್ತವೆ. ಆಕ್ಟಾಹೆಡ್ರಲ್ನಲ್ಲಿ 6 ಲಿಗ್ಯಾಂಡ್ಸ್ ಇರ್ತವೆ, ಸೊ ರಿಪಲ್ಷನ್ಸ್ ಜಾಸ್ತಿ ಬರ್ತವೆ. ಅದಕ್ಕಾಗಿ ನಾನು ಆಕ್ಟಾಹೆಡ್ರಲ್ ತೊಗೊಳ್ತಾ ಇದ್ದೀನಿ ಇಲ್ಲಿ. ಆಕ್ಟಾಹೆಡ್ರಲ್ ಫಸ್ಟ್. ಇದರಲ್ಲಿ ಸ್ಪೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಸೀರೀಸ್ನಲ್ಲಿ ಸ್ಟ್ರಾಂಗೆಸ್ಟ್ ಲಿಗ್ಯಾಂಡ್ ಯಾವುದು ಅಂದರೆ ಸೈನೈಡ್. ಅದಕ್ಕೆ ಫಸ್ಟ್ ಸೈನೈಡ್ ಬರೀತಾ ಇದ್ದೀನಿ, ಅಂದರೆ ಬಿ. ನೆಕ್ಸ್ಟ್ ಅಮೋನಿಯಾ ಸ್ಟ್ರಾಂಗರ್. ನೆಕ್ಸ್ಟ್ ಹೆಕ್ಸಾ ವಾಟರ್. ಲಾಸ್ಟಿಗೆ ಕಾಪರ್. ಈಗ ವಿ ಆಲ್ ನೋ ಎನರ್ಜಿ ಈಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಲ್ಯಾಂಬ್ಡಾ. ಸೊ ಲ್ಯಾಂಬ್ಡಾ ಆರ್ಡರ್ ಬಂದ್ಬಿಟ್ಟು ಸಿ ಗ್ರೇಟರ್ ದ್ಯಾನ್, ಡಿ ಗ್ರೇಟರ್ ದ್ಯಾನ್, ಎ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಬಿ ಬರುತ್ತೆ. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಕ್ರಿಸ್ಟಲ್ ಫೀಲ್ಡ್ ಸ್ಪ್ಲಿಟ್ಟಿಂಗ್ ಎನರ್ಜಿ ಪ್ರಕಾರ ಅರೇಂಜ್ ಮಾಡ್ಕೋಬೇಕಾಗಿದ್ದಾಗ ಮಿಕ್ಸ್ ಕೊಟ್ಟಾಗ ಫಸ್ಟು ಆಕ್ಟಾಹೈಡ್ರಲ್ಗೆ ಹೈಯರ್ ಎನರ್ಜಿ ಇರುತ್ತೆ, ಟೆಟ್ರಾಹೈಡ್ರಲ್ಗೆ ಲೋವರ್ ಎನರ್ಜಿ ಇರುತ್ತೆ. ಇದು ಗಮನಿಸಬೇಕು. ಅದಕ್ಕೆ ಟೆಟ್ರಾಹೈಡ್ರಲ್ ಲಾಸ್ಟಿಗೆ ಹಾಕಿ ಆಕ್ಟಾಹೈಡ್ರಲ್ನಲ್ಲಿರುವ ಕಾಂಪ್ಲೆಕ್ಸಸ್ನಲ್ಲಿ ಸ್ಪೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಸೀರೀಸ್ ಪ್ರಕಾರ ಅರೇಂಜ್ ಮಾಡ್ಕೋಬೇಕು. ಒಂದೊಂದು ಸಲ ಏನು ಮಾಡ್ತಾರೆ, ಚಾರ್ಜ್ ಜಾಸ್ತಿ ಚಾರ್ಜ್ ಕಮ್ಮಿ ಕೊಟ್ಟು ಅವೇ ಲಿಗ್ಯಾಂಡ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಅಂದರೆ CO NH3 6 times +2 ಕೊಟ್ಟಾರೆ ಅನ್ಕೋ ಇದರಲ್ಲಿ. ಆವಾಗ ಎರಡರಲ್ಲಿ ಯಾವುದು ಅಂದರೆ ಹೈಯರ್ ಇಸ್ ದ ಚಾರ್ಜ್, ಹೈಯರ್ ಇಸ್ CFSC. ಸೊ ಇದರಲ್ಲಿ ಫಸ್ಟ್ ಇದು ಸೆಕೆಂಡ್ ಹಾಕಬೇಕು. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಒನ್. ಈ ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಕಾರ್ಬೊನಿಲ್ಸ್ ಕೇಳಿದ್ದಾರೆ. ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಕಾರ್ಬೊನಿಲ್ಸ್ ಕೇಳಿದಾಗ M CO 10 times, CO 2 CO 8 times. ಇವು ಎರಡು. ಇದರ ಬಗ್ಗೆ ಕೆಲವು ಇಂಪಾರ್ಟೆಂಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಕೊಟ್ಟಾರೆ. ಯಾವುದು ಕರೆಕ್ಟ್? ಮೆಟಲ್ ಮೆಟಲ್ ಲಿಂಕೇಜ್ ಇದೆ ಎರಡೂರಲ್ಲಿ. ಬಿ, ಟರ್ಮಿನಲ್ CO ಗ್ರೂಪ್ಸ್ ಅದಾವೆ. ಸಿ, ಬ್ರಿಡ್ಜಿಂಗ್ CO ಅದಾವೆ. ಡಿ, ಮೆಟಲ್ ಇನ್ ಝೀರೋ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇದೆ. ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ನಲ್ಲಿ ಯಾವುದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನೋದು ನಾವು ಹೇಳಬೇಕು. ಇದರಲ್ಲಿ ನೋಡಿದರೆ ಮೆಟಲ್ ಮೆಟಲ್ ಲಿಂಕೇಜ್ ಅಂದರೆ ಈಗ MN ಸ್ಟ್ರಕ್ಚರ್ ತಗೊಂಡಾಗ ಅದರಲ್ಲಿನೂ ಮೆಟಲ್ ಮೆಟಲ್ ಬಾಂಡ್ ಐತಿ. CO ಸ್ಟ್ರಕ್ಚರ್ ತಗೊಂಡಿದ್ದಾಗ ಅದರಲ್ಲಿನೂ ಐತಿ. ಸೊ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಎರಡರಲ್ಲಿ ಕರೆಕ್ಟ್. ಟರ್ಮಿನಲ್ CO ಅದಾವೆ. ಹೌದು ಅದಾವೆ. ಇಲ್ಲಿ ಟರ್ಮಿನಲ್ 1 2 3 ಇಲ್ಲಿ ಕೂಡ ಅದಾವೆ. ಬ್ರಿಡ್ಜಿಂಗ್ CO ಅದಾವೆ. ಬ್ರಿಡ್ಜಿಂಗ್ CO ಎರಡರಲ್ಲಿಲ್ಲ. ಇದು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ನಾವು. ಇದರಲ್ಲಿ ಮಾತ್ರ ಅದ. ಸೊ ತಪ್ಪು. ಎರಡರಲ್ಲಿದ್ರೇ ಕರೆಕ್ಟ್ ತಗೋಬೇಕು. ಮೆಟಲ್ ಇನ್ ಝೀರೋ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್, ಹೌದು ಇದರಲ್ಲಿ ಝೀರೋ ಅದರಲ್ಲಿ ಝೀರೋ. ಇದರಲ್ಲಿ ಎಷ್ಟು ಬ್ರಿಡ್ಜ್ ಅದಾವೆ ಅಂತ ಕೇಳ್ತಾರೆ, ಎರಡು. ಆ ಕ್ವೆಶ್ಚನ್ಗೆ ಆನ್ಸರ್ ನೆನಪಿಟ್ಕೋಬೇಕು. ಸರಿ, ದಿಸ್ ಇಸ್ ಆಲ್ ಅಬೌಟ್ ಇಟ್. ಲೆಟ್ಸ್ ಗೋ ಟು ಅನದರ್ ಕ್ವೆಶ್ಚನ್. ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಇವು. Statement 1. CO NH3 6 times +3. And COF6 -3. are octahedral but differ in their magnetic behavior. Statement 2. CONH3 6 times plus 3 is diamagnetic. COF6 minus 3 is paramagnetic. ಇದು ಕರೆಕ್ಟಾ ತಪ್ಪಾ ಅನ್ನೋದು ಹೇಳಬೇಕು. ಇದರಲ್ಲಿ ನೋಡಿ ಫಸ್ಟ್ ಒನ್ CONH3 6 times plus 3 ಅಂದರೆ ಇದು 3D6 ಕಾನ್ಫಿಗರೇಷನ್ ಹೊಂದಿದೆ. ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ರಿಅರೇಂಜ್ಮೆಂಟ್ ಆಗತ್ತೆ, ಪೇಡ್ ಅಪ್, ಸೊ ಡಯಾನೆ. ಅದೇ COF6 minus 3 ಆದರೆ 3D6 ಬಟ್ ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್. ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಇದ್ರೆ 6 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹಿಂಗಿರ್ತವೆ, 4 ಪ್ಯಾರಾ ಆಗುತ್ತೆ. ಇದು ಇಂಪಾರ್ಟೆಂಟ್. ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟಿಗೆ ಹೋಗೋಣ. ಸೊ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್ ಬಿಕಾಸ್ ದೇ ಹ್ಯಾವ್ ಡಿಫರೆಂಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಬಿಹೇವಿಯರ್. ಆ್ಯಂಡ್ ದ ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಫಸ್ಟ್ ಒನ್ ಡಯಾ, ಸೆಕೆಂಡ್ ಒನ್ ಪ್ಯಾರಾ, ಅದು ಕೂಡ ಕರೆಕ್ಟೇ. ಸೊ ಬೋತ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಆರ್ ಕರೆಕ್ಟ್. ನೆಕ್ಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಗೆ ಹೋಗೋಣ. CONH3 6 times plus 3 is a homoleptic complex. Whereas CONH3 4 times Cl2 is heteroleptic. ಇದು ಸ್ಟೇಟ್ಮೆಂಟ್ 1. ಸ್ಟೇಟ್ಮೆಂಟ್ 2 ಏನಂದರೆ CONH3 6 times plus 3 has only one kind of ligands. CONH3 4 times Cl2 has more than one kind. ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಇದರಲ್ಲಿ ಒಂದೇ ಟೈಪ್ ಆಫ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಅದಾವೆ, ಸೊ ಹೋಮೋಲೆಪ್ಟಿಕ್. ಎರಡು ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಅದಾವೆ, ಹೆಟ್ರೋಲೆಪ್ಟಿಕ್. ಸೊ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ಟ್ರೂ. ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಗೆ ಬಂದಾಗ ಹೌದು ಇದು ಒನ್ ಕೈಂಡೇ, ಇದು ಎರಡು 2 ಕೈಂಡ್ಸೇ, ದಟ್ ಫೋರ್ ಅದು ಕೂಡ ಕರೆಕ್ಟೇ. ಸೊ ಬೋತ್ ಸ್ಟೇಟ್ಮೆಂಟ್ಸ್ ಆರ್ ಕರೆಕ್ಟ್. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. Types of isomerisms exhibited by compounds. ಇಲ್ಲಿ ಒಂದು ಸೆಟ್ ಆಫ್ ಕಂಪೌಂಡ್ಸ್ ಕೊಟ್ಟಾರೋ ಅವು ಯಾವ ಐಸೋಮೆರಿಸಮ್ ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತವೆ ಅನ್ನೋದು ಹೇಳಬೇಕು. ಅದೇ 3 ಕಂಪೌಂಡ್ಸ್. ಇವು ಯಾವ ಐಸೋಮೆರಿಸಮ್ ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತಿದ್ದಾವೆ, ಅದರಲ್ಲಿ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ ಎಷ್ಟು. ಇದು ನಿಮಗೆ ಗೊತ್ತಿದೆ, ವಾಟರ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಆಗಿ ಪ್ರೆಸೆಂಟ್ ಆಗಿದ್ದಾಗ, ಅದು ಹೊರಗಡೆ ಮತ್ತು ಒಳಗಡೆ ಕೂಡ ಇದ್ದಾಗ, ಆವಾಗ ಅದು ಪಾಸಿಬಲ್ ಆಗೋದು ಸಾಲ್ವೇಟ್ ಐಸೋಮೆರಿಸಮ್. ಸಾಲ್ವೇಟ್ ಐಸೋಮೆರಿಸಮ್ ಇದ್ದರೆ ನಾವು ಆವಾಗ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ 6 ಅಂತ ಹೇಳ್ಬೋದು, ಯಾಕಂದರೆ ಇದರಲ್ಲಿ 6 ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ ಇದೆ. ಸೊ ಇಟ್ ಈಸ್ solvate isomerism with coordination number 6. Answer. Next question. Which of the following complexes is more stable? Stable find out ಮಾಡಬೇಕು. CONH3 thrice, NO2 thrice. ಇದು ಫಸ್ಟ್. ಎರಡನೇದು COCl2 En twice NO3. ಮೂರನೇದು NH3 6 times twice SO4 thrice. 4. ಈ 4ರಲ್ಲಿ ನಾವು 1 2 3 4 ತಗೊಂಡಿದ್ದಾಗ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿದ್ದು ಯಾವುದು ಮೋಸ್ಟ್ ಸ್ಟೇಬಲ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಜನರಲಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಸ್ಟೆಬಿಲಿಟಿ ನೋಡಬೇಕಾಗಿದ್ದಾಗ ಡೈಡೆಂಟೆಡ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಎದರಲ್ಲಾದರೂ ಅದಾವ, ಟ್ರೈಗಾನಿ, ಟೆಟ್ರಾ, ಟೆಂಟೇಟ್ ಯಾವುದಾದ್ರೂ ಕೂಡ ಎಲ್ಲಾದರೂ ಆಯ್ತಾ ಅನ್ನೋದು ನೋಡಬೇಕು ಫಸ್ಟು. ಇದ್ದರೆ ಅದು ಕೀಲೇಷನ್ ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ಕೀಲೇಷನ್ ಇದ್ದರೆ ಅದು ಸ್ಟೇಬಲ್ ಅಂತ ಅರ್ಥ. ಇಲ್ಲ ಇನ್ನೊಂದು ವಿಧದಾಗಿ ಯಾವ ಥರ ಯೋಚನೆ ಮಾಡಬೇಕಂದ್ರೆ D4 to D7 ಕಾಂಪ್ಲೆಕ್ಸಸ್ನಲ್ಲಿ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಇದ್ದರೆ ಸ್ಟೇಬಲ್ ಅಂತ ಅರ್ಥ, ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಇದ್ದರೆ ಅನ್ಸ್ಟೇಬಲ್ ಅಂತ ಅರ್ಥ. ಲಕಿಲಿ ನಮಗೆ 4 ಎಕ್ಸಾಂಪಲ್ಸ್ನಲ್ಲಿ 2ನೇ ಎಕ್ಸಾಂಪಲ್ನಲ್ಲಿ ಡೈಡೆಂಟೇಟ್ ಲಿಗ್ಯಾಂಡ್ ಇದೆ. ಇದರ ಅರ್ಥ ಏನು ಅಂತ ಅಂದರೆ ಇಟ್ ಈಸ್ ಡೆಫಿನೆಟ್ಲಿ ಸಮಥಿಂಗ್ ಕಾಲ್ಡ್ ಸ್ಟೇಬಲ್. ದೇರ್ ಫೋರ್ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಇದ್ದಕ್ಕೆ ಇದು ಸ್ಟೇಬಲ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ವಿ. ಐ ಮೀನ್ ಒಂದು. ಎರಡನೇದು ಇದು ಕೀಲೇಷನ್ ಫಾರ್ಮ್ ಮಾಡ್ತಾ ಇದ್ದದಕ್ಕೆ ಇದು ಸ್ಟೇಬಲ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ವಿ ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಕೀಲೇಷನ್ ಇಸ್ ದ ಮೈನ್ ರೀಸನ್. ನೆಕ್ಸ್ಟ್ Next is a set of statements. Assertion and reason. Assertion ಬಂದ್ಬಿಟ್ಟು the metal carbon bond in metal carbonyls possesses both sigma and pi character. ಈಗ ಮೆಟಲ್ ಕಾರ್ಬನಿಲ್ಸ್ನಲ್ಲಿ ಮೆಟಲ್ ಕಾರ್ಬನ್ ಬಾಂಡ್ ಇರುತ್ತಲ್ವಾ, ಇದಕ್ಕೆ ಸಿಗ್ಮಾ ಆ್ಯಂಡ್ ಪೈ ಕ್ಯಾರೆಕ್ಟರ್ ಎರಡೂ ಇರ್ತವೆ ಅನ್ನೋದು ಫಸ್ಟ್ದು. ಎರಡನೇದು ರೀಸನ್. The ligand to metal bond is a pi bond and metal to ligand bond is a sigma bond. Ligand to metal is a pi bond, metal to ligand is a sigma bond ಅಂತ ಕೊಟ್ಟಾರೆ. ಇದು ಕರೆಕ್ಟೇನಾ ಇಲ್ಲ ಅನ್ನೋದು ಹೇಳಬೇಕು ನಾವು. ಸೊ ಫಸ್ಟ್ ನೋಡಿ, ಎಸ್ ಮೆಟಲ್ ಕಾರ್ಬನಿಲ್ಸ್ನಲ್ಲಿ ಮೆಟಲ್ ಆ್ಯಂಡ್ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಬಾಂಡ್ಗೆ ಅದು ಖಂಡಿತ ನಮಗೆ ಸಿಗ್ಮಾ ಆ್ಯಂಡ್ ಪೈ ಕ್ಯಾರೆಕ್ಟರ್ಸ್ ಎರಡನ್ನು ಹೊಂದಿರುತ್ತೆ. ಅದನ್ನು ಸಿನರ್ಜಿಕ್ ಬಾಂಡ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಇದು ಟ್ರೂ, ಇದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ರೀಸನಿಗೆ ಬಂದಾಗ ಲಿಗ್ಯಾಂಡ್ ಟು ಮೆಟಲ್ ಏನಿದೆ ಅಂದರೆ ಲಿಗ್ಯಾಂಡ್ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಮೆಟಲ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಡೋದು ಸಿಗ್ಮಾ ಬಾಂಡ್ ದ್ವಾರ, ಮೆಟಲ್ ಮತ್ತು ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಡೋದು ಪೈ ಬಾಂಡ್ ದ್ವಾರ. ಅದಕ್ಕೆ ತಾನೇ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡನ್ನು ಪೈ ಆಕ್ಸೆಪ್ಟಾರ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತ ಕರೆಯೋದು ಅದನ್ನು. ಹಾಗಾಗಿ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ತಪ್ಪಾಗತ್ತೆ. ಸೊ ರೀಸನ್ ಫಾಲ್ಸ್, ಅಸರ್ಷನ್ ಟ್ರೂ. ಮೆಟಲ್ ಲಿಗ್ಯಾಂಡ್ ಮೆಟಲ್ಗೆ ಕೊಡೋದು ಸಿಗ್ಮಾ, ಮೆಟಲ್ ಲಿಗ್ಯಾಂಡ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕೊಡೋದು ಪೈ ಬಾಂಡ್. ಸೊ ಈ ತರಹ ನಾವು ಅಸರ್ಷನ್ ಟ್ರೂ, ರೀಸನ್ ಫಾಲ್ಸ್ ಅಂತ ಹೇಳಬೇಕಾಗತ್ತೆ. ಕಾಂಪ್ಲೆಕ್ಸ್ಗೆ ಹೆಸರೊಂದು ಕೊಟ್ಟಿದ್ದಾರೆ. AgH2O twice, AgCN twice. ಈ ತರಹ ಕಾಂಪ್ಲೆಕ್ಸಸ್ಸನ್ನು ಕೊಟ್ಟಾಗ ನಾವು ಸ್ವಲ್ಪ ಚಾರ್ಜ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು ಕಷ್ಟ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಕೆಲವು ಇಂಪಾರ್ಟೆಂಟ್ ಚಾರ್ಜಸ್ ನೆನಪಿಟ್ಕೋಬೇಕು. ಸಿಲ್ವರ್ ಅಂದ್ಕೊಳ್ಳಿ, ಅದು ಯಾವಾಗಲೂ +1 ಇನ್ನು ಬೇರೆದು ಬರಲ್ಲ. ಅಂದರೆ ನಮಗೆ ಕಾಂಪ್ಲೆಕ್ಸಸ್ನಲ್ಲಿ ಬರಲ್ಲ, ಬರೋದು +2 ಬರುತ್ತೆ, ಬಟ್ ಅದು ಬೇರೆ ವೆರಿ ವೆರಿ ರೇರ್ ಕೇಸಸ್ನಲ್ಲಿ. ಸೊ +1 ಮೇಯ್ನ್ ಇದಕ್ಕೆ. ಹಾಗಾಗಿ ಎಲ್ಲಿದ್ದರೂ +1 ಎರಡರಲ್ಲಿ +1 ತೊಗೋಬೇಕು. ಆವಾಗ ಹೆಸರು ಹೇಗಿಡಬೇಕು? ಫಸ್ಟ್ ಪಾರ್ಟ್ ಕ್ಯಾಟಯಾನ್, ಸೆಕೆಂಡ್ ಪಾರ್ಟ್ ಆನಯಾನ್. ವಿ ಶಲ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದ ಕೋಆರ್ಡಿನೇಷನ್ ನಂಬರ್ ಫಸ್ಟ್. ಡೈ, ನೆಕ್ಸ್ಟ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ನೇಮ್ ಆಕ್ವಾ, ನೆಕ್ಸ್ಟ್ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ಸ್ ನಂಬರ್ ಸಿಲ್ವರ್, ನೆಕ್ಸ್ಟ್ ಬಂದುಬಿಟ್ಟು 1 ಚಾರ್ಜ್ 1. ನೆಕ್ಸ್ಟ್ ಡೈ, ನೆಕ್ಸ್ಟ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ನೇಮ್ ಡಯಸೈನಿಡೋ, ಲಿಗ್ಯಾಂಡ್ಸ್ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ಸ್ ನೇಮ್ ಸಿಲ್ವರೇಟ್ ಅನ್ನಂಗಿಲ್ಲಲ್ವ, ಅದಕ್ಕೆ ಅರ್ಜೆಂಟೇಟ್ ಅಂತೆ. ಇದು ಹೆಸರು. ಸೊ ಡೈ ಆಕ್ವಾ, ಸಿಲ್ವರ್ 1, ಡೈಸೈನಿಡೋ, ಅರ್ಜೆಂಟೇಟ್ 1 is the name of the complex. Next one. Order of energy absorbed according to color. Order of energy ಪ್ರಕಾರ ಬರೆಯಬೇಕು. ಇದರಲ್ಲಿ ಫಸ್ಟ್ ಒನ್ ನಿಕೆಲ್, H2O twice, En twice. ಇದು A, B, C, ಎಷ್ಟು ತಗೋಬೇಕು. ಇದರಲ್ಲಿ ಆರ್ಡರ್ ಪ್ರಕಾರ ಹೇಳಬೇಕು. ಅಂದರೆ ಯಾವುದು ಹೈಯೆಸ್ಟ್ ಎನರ್ಜಿಯನ್ನು ಎಬ್ಸಾರ್ಬ್ ಮಾಡಿಕೊಳ್ಳುತ್ತಾ ಇದೆ ಅನ್ನೋದು. ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಇದೆ ಅಂದ್ಕೊಳ್ಳಿ, ಆವಾಗ CFSC ಗ್ಯಾಪ್ ಜಾಸ್ತಿ ಬರುತ್ತಲ್ವ, ಆವಾಗ ಎಬ್ಸಾರ್ಬ್ ಮಾಡಿಕೊಂಡ ಎನರ್ಜಿ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ವಾಟರ್ ಮತ್ತು ENಗಳಲ್ಲಿ EN ಇಸ್ ಅ ಸ್ಟ್ರಾಂಗರ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್. ಹಾಗಾಗಿ EN ಎಷ್ಟು ಜಾಸ್ತಿ ಇದ್ದರೆ ಅಷ್ಟು CFSC, ಎಷ್ಟು CFSC ಇದ್ದರೆ ಅಷ್ಟು ಅಬ್ಸಾರ್ಪ್ಷನ್ ಆಫ್ ಎನರ್ಜಿ. ಸೊ C highest, then A, then B. ಇದು ಆರ್ಡರ್. ಯಾಕಂದರೆ ಇದರಲ್ಲಿ ಹೈಯೆಸ್ಟ್ ನಂಬರ್ ಆಫ್ ENs ಅದಾವೆ, ಇದರಲ್ಲಿ 2 ಅದಾವೆ, ಅದರಲ್ಲಿ ಒಂದೇ ಐತಿ. ಇಷ್ಟು ತಗೋಬೇಕು. ಇನ್ನೊಂದು ಕ್ವೆಶ್ಚನ್ ನೋಡೋಣ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಮೊಮೆಂಟನ್ನು ಡಿಸೈಡ್ ಮಾಡಬೇಕು. ಮ್ಯಾಚ್ ದ ಫಾಲೋವಿಂಗ್ ಕೊಟ್ಟರು. Five 5.92, 0, 4.973. ಮ್ಯಾಚ್ ಮಾಡಬೇಕಿದು. ಇದು ಐರನ್ Fe+3 ಸ್ಟೇಟ್ನಲ್ಲಿ ಐತಿ, ಅಂದರೆ 3D5 ಕಾನ್ಫಿಗರೇಷನ್. ಸೈನೈಡ್ಸ್ ಇರೋದ್ರಿಂದ ನಮಗೆ 1 2 3 ಆಗಿ 4 5 1 ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಉಳಿದಿರುತ್ತೆ. 1 ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂದರೆ 1 ಪಾಯಿಂಟ್ ಸಮಥಿಂಗ್. ನೆಕ್ಸ್ಟ್ ಇದು ಕೂಡ Fe+3ನೇ, ಇದು ಕೂಡ 3D5, ಆದರೆ ಅದರಲ್ಲಿ 5 ಅನ್ಪೇಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತವೆ. 1 2 3 4 5, ಯಾಕಂದರೆ ವಾಟರ್ ವೀಕ್ ಫೀಲ್ಡ್ ಲಿಗ್ಯಾಂಡ್ ಅಲ್ವಾ. FeCN6 times -4 ತಗೊಂಡ್ರೆ ಇದರಲ್ಲಿ Fe+2 ಚಾರ್ಜನ್ನು ಹೊಂದಿದೆ. 3D6 ಕಾನ್ಫಿಗರೇಷನ್ಗೆ ಹೋಗುತ್ತೆ. 3D6 ಕಾನ್ಫಿಗರೇಷನ್ ಬಂದಾಗ ಇದು ರಿಅರೇಂಜ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ನೋ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಇನ್ನು ಉಳಿದಿದ್ದು 4.9, ಅದು ಕರೆಕ್ಟ್ ಬರುತ್ತೆ. ಫೋರ್ತ್ ಒನ್ ಮತ್ತೆ Fe+2 ಬರುತ್ತೆ. 3D6 ಕಾನ್ಫಿಗರೇಷನ್ ಬರುತ್ತೆ, ಬಟ್ ರಿಅರೇಂಜ್ ಆಗಲ್ಲ. 4 ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತವೆ. 4ಗೆ ಮ್ಯಾಚ್ ಮಾಡಬೇಕು ಅಷ್ಟೇ. ಇಲ್ಲಿಗೆ ಇವತ್ತು ಸ್ಟಾಪ್ ಮಾಡೋಣ. ಉಳಿದಿದ್ದವು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ನಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ನಾಳೆ ಉಳಿದಿದ್ದು ಮಾಡೆಲ್ಸ್ ಕೂಡ ಕವರ್ ಆಗೋ ಹಂಗೆ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಕ್ವೆಶ್ಚನ್ಸನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಥ್ಯಾಂಕ್ ಯು.